Guys, welcome to this particular video. And in this particular video today, we're going to be talking about, we're going to be looking at Python programming language, and it's going to be a very extensive course. So over the course of the next 12 hours, we're going to be covering everything you need to know while getting started with Python programming language. Now, without wasting much time, I'm just going to kind of show you my screen of essentially what we're going to be covering today. So today we're going to be looking at how to install Python into your computer, even if you've not programmed with Python before in your entire life. This video definitely is going to be addressing that. And then we're going to be looking at variables, data types, how to accept user input. And inside of that, we're going to be talking about, some of the naming conventions. And we're going to also look at numbers, strings, Boolean, type conversion, user input, type checking, and all of that. And then also we're going to look at operators, conditional statements. We're going to look at arithmetic operators in Python. We're going to look at some of the comparison and logical operators. Also going to look at the if-else statement and some nested conditions, which we're going to also be looking at. And we're also going to be looking at, the loops, control statements in terms of while loops, how to use the break statement, continue, pass, nested loops, and all of that. Then that's now going to lead us into some of the data structures that we have in Python programming, like we have lists, we have tuples, we have dictionaries, and we have methods, and other operations. Basically, what we are saying here is some of the methods that you could use for some of these data structures. So we're going to also look at some differences between some of these data structures when you look at lists. What are some of the things you can perform inside of lists that you might not do inside of tuples and sets, dictionaries, and all of that. So that is actually what we're going to be doing. There's also going to lead us into functions. We're going to also look at functions. For when we talk about functions, we're going to be looking at some of the modules, like packages, that actually comes with some of these functions. It's going to give us some kind of extensive hands-on around some kind of return values, how to import, create models, and it's just kind of basically some information that are quite imperative with respect to functions and all the allied related information that comes there. Now, also going to be looking at file handling, how to handle files, exception handling, how to read and write files, file modes, try and accept, else finally, and all of that. So we're going to really, it's going to be a very extensive explanation here, and also going to be looking at how to raise exceptions, some kind of practical examples, and all of that. So also it's also going to take us into object-oriented programming, where we look at classes, and we're going to have a very deep dive on attributes, some methods, inheritance, polymorphism, and then we're going to perform some kind of mini projects in object-oriented programming. Now, that's also going to lead us into having us work around some libraries, common libraries in Python, uh, like, pandas, matplotlib, and NumPy, and some kind of simple automation project, which is going to have us have some sort of, more kind of mini project in Python. And so this is actually going to lead us to getting set in, working on capstone, projects and, some real world, you know, just kind of basically having us perform some coding exercises and understanding what is important, particularly with respect to using Python as in an important programming language. So I think that is definitely going to be that for now. I'm not really going to waste so much time, in talking about some of these. But with respect to why we commenced this particular 30 days machine learning challenge, I just want to kind of give us a warm refresher of what it looks like for you to cover the foundation of Python. And this is just what it looks like, a course outline that we are working with. And it starts from introduction to Python data types, data structures, control flow, some functions. Just kind of basically what I've talked about right now with respect to getting started, and then it lands you to your introduction to library. So depending on how you intend to learn how to program in Python, this is just an outline that is very much open for anybody who wants to, have a structured approach in learning Python as a programming language. And I want to also let you know something if you're watching this, having this conversation with me, just kind of, I want you to understand that if you understand some of the fundamentals of what I'm going to be talking about today, essentially these are definitely going to also apply in how you also approach other programming languages like maybe C Sharp, Java, and all of that. Okay, so that's it. So the last thing I'm going to do at this time is at this kind of introductory part is I'm just going to be talking about what the outline looks like for us who actually join this particular challenge, the 30-day challenge. As of the time I'm recording this video, this is August 2026, and if you're kind of watching this video in the future, I kind of just believe that there might have been some significant changes in how you program with Python, but basically anybody who is interested in machine learning or any sort of maybe deep learning or whatever, then this is still a very recommended pathway that you might want to explore. So this is actually how we start. We start with installation and all of that. Then it takes us to artificial intelligence. We look at machine learning. We kind of have an understanding of data. We look at the mathematics for machine learning. We're also going to look at the machine learning workflow and then Python libraries for machine learning. We'll have a machine learning marathon and just kind of understand that a lot of practices are definitely going to be performed. Look at regression in practice, classification algorithms, test-based algorithms. That's for tree-based algorithms and distance algorithms, improving models down to evaluation. We'll have a machine learning project marathon sometime by August 15. And then also we're looking at introduction to deep learning. Then look at artificial neural networks, how neural networks learn plus mathematics for deep learning. Then we look at backpropagation, activation functions, some PyTorch fundamentals, because we're going to be relying heavily on PyTorch. There are several frameworks that you use for machine learning, deep learning rather, but we have PyTorch and TensorFlow, but we're going to be working heavily with PyTorch. And then I think it's going to lead us to computer vision and then deep learning marathon. We will look at some SQL, which is kind of a database management system. We look at the SQL queries, fast API fundamentals. We look at how to create some REST APIs and routers, path parameters, some sort of query parameters as well. And then we look at how we can serve machine learning models. And we kind of have some, very important, conversation on Git, GitHub, Docker, and we deploy some AI models, and that's it. I'll build our portfolio. So this is actually what I might want to talk about with respect to outline, 30-day machine learning outline. So this is definitely going to be a very highly motivated marathon for these conversations. So I think those are actually definitely going to be that for now. If there are questions that you might have, you might want to kind of drop that on the chat bot. Of course, if I do get through them, I would always want to answer that. But other than that, we are definitely going to start this conversation. Now, I also want to explain something for this particular tutorial that we're going to be having today in the next 12 hours. I just wanted to know that we're going to be working with slides just for our participants to kind of have clearer understanding of explanation. So I'm going to be coding. This is going to be, there's definitely going to be a lot of coding exercises here and as well as slides. So how I've structured this lesson is that for each particular setup, we're going to walk through slides. I'm going to walk you through some slides, explain some stuffs, and then we definitely do some coding. And the idea here is that we don't just want to jump into, lots of coding without having you understand what is currently going on. Just basically you knowing that for you to understand how to program in Python, you really need that visual explanation before you get into the practice. So I just wanted to understand that if you're watching this video, definitely I'm going to be sharing lots of slides, and also I'm going to be jumping from slides down to my code editor just to make things really very important and easy and very clear for anybody who is definitely going to be watching. So that is definitely going to be that. Now, I've structured this class very well. So first of all, we're going to be looking at introduction to Python setup. Then from there, I'm going to move to variables, which is our module 2. I'm then going to jump into operations and decision making in Python, which properly aligns with what we said we're going to be doing. And then we're going to look at loops. And from there, of course, from there is going to take us into, I just wanted to be sure I didn't make any sort of mistake when I was talking about loops here. And yeah, because it looks like I mistakenly jumped something. Okay, all right, so that is definitely going to be that. Then we move to some data structures like dictionaries, and from there we look at functions, and just kind of, it's just going to require us jumping from pillar to post, but I just wanted to know that these 12 hours definitely is going to worth it. We're going to make as much as possible. We're going to make so much effort to ensure that we cover as much as possible. And then from there, we'll go into object-oriented programming. And then I'm going to also talk about NumPy. And also, we're going to look at pandas. Now, this is not a slideshow. This is fully practical. But like I said, I'm going to be coding a lot on my terminal. So I'm going to be moving from the slides to my terminal, right? From my slides to my terminal to my integrated development environment, just to make everything make sense, right? I wouldn't just want to be coding so much without me explaining terms. So I'll move from theories down to practicals just to make everything easy. So I think those are actually definitely going to be that. I've explained how the course structure is going to be, how we're going to jump around. And just to give some career advice, if you're watching this video right now, I just wanted to understand that there is a very good path for you in terms of programming in Python. And what it leads you is that it kind of prepares you to become a data analyst. It could prepare you also to become some sort of maybe data scientist. It could also prepare you to become, a machine learning engineer, an AI automation expert, whatever career path that you are looking at to get in terms of Python programming, it's really worth it. That's what I'm going to say. I think I'm going to put it that way. It's something that is really, really, really worth it, and it's worth all the time and investment that you're going to be giving inside of this course. So I think that's definitely going to be that for all of the introduction that I have done for this particular course, and we're just going to be jumping straight right up into it. Now, just like I said, now we're getting started. Now we're going to be looking at what is Python, right? So Python is a programming language. So I assume that if you're watching this video, you have not heard about Python programming before, or probably maybe you just have some sort of elementary knowledge of maybe you heard from a friend about how to program in Python. But for you to start programming in Python, the first thing you need to know is that there needs to be a setup, a working environment. So that working environment is what I'm going to be creating right now, okay? So I'm going to be explaining what it entails, how to set up a working environment, and essentially, basically, whatever thing you need to do to set your environment up. Now, don't worry about all of this code here. But what I wanted to know is that Python is a kind of a high-level language, right? So what do we mean by Python being a high-level language? It's sort of a high-level language in the terms that when you speak English to me, you can tell me, come, I'm at the room, or I'm at the kitchen, or I'm somewhere, right? And then I kind of understand what you're saying because that's English, that's words. Now, when it comes to programming, one of the things you need to understand is that programming requires that there are some sort of information that the computer does understand, right? If you're somebody that did computer science, maybe back when you were in school, you might have heard about binaries, zeros and ones, and lots of that, right? So what the computer does is that it kind of transforms numbers from it kind of transforms instructions that is being given into you give you an instruction to the computer to perform a task, maybe run this algorithm, perform so and so task, and the computer converts that instruction into binaries. So that is how it is being interpreted in the computer. Now, but when you look at Python as a programming language, it is high level in the sense that it is close to human language. When I write a Python program right now, it's something that you can understand, right? It's more closer to the human language, right? Compared to languages like assembly. If you write an assembly code or maybe a C++ code, or maybe you're writing very, very low level languages that are close to binaries, zeros and one, which is what the computer understands. You see that this is where Python as a programming language differ because it is statistically typed, and what this means is that what it can it's readable, right? It's something that is very readable, and that's why a lot of people do use it for a machine learning task and all sort of data science, data analysis tasks because of its readability and easy syntax. Am I saying the other programming language are not being used? Of course, they are being used, but Python's idea here is that it's quite very readable. It was created in 1991, and before it became, kind of a widely adopted language in the world. So, like I said, whenever we talk about the word syntax, we're talking about readability, right? So it means that it is very the rules and regulation for writing Python is very easy to interpret. And it's interpreted because it runs line by line. So there is nothing like compilers. We're not going to be looking at compilers, which we usually use probably for writing something like maybe TypeScript or maybe stuff like C++, C code, Java, and I'm talking of Java, not JavaScript, right? And most of those requires you to compile your code. So by compiling it, and when you write your code, you have to compile it, and that's it. Before it can now, more like it's being compiled before the computer can now receive it. That's the engine of the computer can receive it in binary and all of that. So it's cross-platform in the sense that you can run it on Windows. Currently, I'm running on Windows. You can also run it on Mac OS, Linux, and other sort of Linux, operating systems. Maybe you're using the Ubuntu operating system. Of course, you could run Python there. Yeah, it doesn't really require some sort of modifications. And I definitely going to show you lots of coding exercises, how you can check out, some Python versions, stuff like that, and all of that. So I'm kind of just going to keep my conversation in terms of a layman's format, just to make it easy for everybody to understand. So that is in terms of the story behind Python programming. Like I said, it started in sometime in 1981, in 89 rather, where Guido von Vossum, whoever that happens to be, designed Python as a hobby project for Christmas break in Netherlands. And then now it's all transformed down in 2000s when Python 2.0 now introduces some other garbage collections like lists, comprehensions, and all of that, lots of stuff. And over time, Python as a programming language has continued to modify. You know, a lot of new things continues to be added. Python right now is using performing a very wider range of tasks, and just basically understanding that why versions of Python is continuing to be released. It makes loads of things really very easy, particularly for the wider community that it has, right? So that is it. That's why programs like when you look at the language like Python, it's continuing to be released in versions. So when there is a new version, some other features is being added. Again, when there's another new version, we also add other features, right? So a traditional programming language, you have to make sure that you have data structures like lists, tuples, and all of that, maybe objects, and maybe it contains, there is actually a way you declare variables, there is a way you store, data types, and a lot of things. So just understand that the whole idea here is that while the language itself continues to, undergo some morphology, new features has been added, and of course, that's it. So the reason why Python is so popular, why is it so popular? The reason why it's so popular is because uh, we use it in a lot of things, right? It's really beginner friendly. It has a very simple syntax, clean syntax actually that reduces the learning curve for new programmers. It has a very vast ecosystem. So what I'm saying by that is that you're definitely going to see that there are so many things we're going to be importing in Python that we're going to be using. So for example, now when we talk about vast ecosystem, think of it this way. For you to start programming with Python, you have to look at the fact that you might want to perform some data science operations. Now, let's say, for example, you need a package that is going to help you for multiplication and division. Now, what it means now that there are already packages that has been created for that. Somebody has created something like NumPy, numerical Python. Somebody has created something like SciPy. So these are what we call packages that we use in Python programming. So that's why when you look at it as being fast, it means that so many people are using the language, and that's why there are lots of packages virtually that are actually being used, particularly in executing loads of tasks, right? It has a massive community, right? Millions of developers worldwide, contributing, to it. And, there are so many tutorials on Python programming. So in short, I'm going to say that what I'm doing right now kind of is one of the umpteenth one. There are so many people that have done so many videos on how to get started with Python. And there are millions of developers, just like I said, that are around worldwide who are using Python programming language. So it's really a very high in demand skill, which means Python skills are actually among some of the most common sought after tech skills when it comes to hiring. So where is Python used? You can use Python in web development. Some of what we're going to be doing on the course of this whole exercise. Uh, So we're going to be using Python somehow for fast API, which is a kind of a backend framework that we use in programming. And we can also use Python for data science, which can be one of you here. Maybe you have a career to become, you have a career, you're optimist in your career path. You want to become a data scientist or an analyst, and you're thinking of pandas, NumPy. Those are some of the packages that we do use there. And also, Python can be used for machine learning and AI, which is something I recently talked about in terms of TensorFlow, PyTorch, and a lot of things actually that relates to that. And also can use it for automation and scripting. We can use it to perform some kind of system task and some kind of bots. And also can use it for scientific computations, for research simulations. There are packages like SciPy, which I might not have really mentioned here, but just to give you some kind of warm refresher of what we can use Python for. We can also use Python for software testing. We have the package we call the PyTest, Selenium, and lots of that, okay? So the reason why Python powers the world is because the reason why Python powers the modern world here is because from NASA and Google, Netflix, these are some big companies that do use Python as a programming language, right? And it's kind of embedded in the infrastructure of a lot of companies. So even when we look at, what some of the AI tools that we use frequently, all the time, like ChatGPT, training, like it's Python, right? Python was used in developing ChatGPT. How is it to train the model? And any sort of AI tool that you've got out there, right? Python is something that is really very much used, right? So yeah. So for YouTube recommendation engine, Spotify music analysis tool, when we're going to be looking at some sort of prediction model and all of that, how that is being done, all of this is what we do with what Python as a programming what language. So before I get into installation, showing you how you can install Python, I just want to kind of talk about something. We have what we call the Python 2 versus Python 3, right? So the Python 2 is a legacy Python version, which means it's reached the end of life, particularly in 2020. And we did that, like I said, whenever you're working with programming languages, there are what we call some sort of security updates that are actually really made to them. And maybe some from time to time we fix some bugs and we make updates because say, okay, we're releasing a new programming language. But why I'm actually really saying this? The reason why I'm trying to say is that uh it, like just understand that there are definitely some times that we might require to install the Python 2, or maybe there might be several versions of Python that we might have to, iterate all over. But essentially, the point you must have to take home here is that while there are updates that are being made to each of the Python versions, which of course Python 3, that's where we are receiving change because we're going to be seeing 3.1, 3.2, 3.13.3, 3.1.13, 3.13.3, and all of that. You just need to understand that, right? The Python 2, which was used initially made back in 90s and early 2000s and kind of stopped in 2020, has a way it interprets some kind of values, right? So if you're using a Mac OS and you open your terminal, maybe I could just hit up on my terminal and I say maybe PowerShell, maybe Windows PowerShell. And of course, it's definitely going to open that for me. And I type something like Python dash, maybe dash dash version, for example. I can also do this on my command line. You're going to see that this is going to return Python 3.13.3. And the reason why it does this is because of what? This is the standard version that we have to use right now, okay? So so if you're using a Mac OS, most times maybe Google and Python 2 and all of that, or maybe Linux, Ubuntu system, Python 2 or thereabout. But most of what we should be using right now is Python 3. And for you to understand that the way we assign some stuffs like maybe some operators like integer operators and all of that behave differently in Python 2 versus the Python 3. So for the Python 3, which I'm going to be working around with, print is a function. Just for you to look at some of these to see that these are the version that is actively being maintained very well. And just like I kind of hit on my terminal here, you see that this is 3.13.3. So if you're watching this video maybe in the future, maybe you're watching the video in 2030 or 2050 or whatever, and maybe you're using Python 4, probably maybe there might be some changes that has been made. But as of the time of recording this video, I'm working with the 13.3 version, which could also change sometime maybe to 14 or none of that. So anytime you're trying to install in Python, use the Python 3 for all your projects, okay? All right. So this is where we're getting to now. We're going to look at how to install Python. So the first thing you usually do is you're going to go to python.org. So if you don't have Python on your computer, you just want to go to this website, python.org, and then when you get there, you go to downloads, and okay, I'm just going to hover my cursor there, and I'm going to go to install Python Manager. I'm running on Windows, of course. I'm going to click on this, and if I click on this, a box is definitely going to pop up, but I'm not going to click on that right now because I already have Python installed on my computer. So I kind of made a video on how to install, but I just want to just talk about it. Now, if you look at this here now, you see that we have Python 3.14.6, but compared to what I have on my terminal here, which is 3.14.6, so that tells you that what a lot of changes continues to be made on the what Python programming language. So that's what is going to be from that particular version that's from python.org. We'll now install, and then we'll make sure we add to path, and then we verify our installation by opening our terminal to check it out, which is what I did here. I'm just going to run that again. Python dash dash version. Of course, I could just press Windows R, and I'm going to hit on the command line. So this time around, it's going to open the shell, and I'm going to also do the same thing there. Python, just to Python dash dash version, and of course, it's still going to give me that. So this is the command line, and so the other one is the PowerShell. So whichever one you're using, if you're using if your operating system, maybe you're using a Linux, of course, you could look at command. Maybe you could press the command. That's you definitely use the command key, and then or maybe search for maybe that's the command line, and of course it's going to render. So if you're using the Windows has a PowerShell. Of course, that's going to help you understand the version for your stuff. So I could do 56 plus maybe 56 here. And okay, it's not recognizable here because this is not an external command. But if I open my integrated terminal, which I'm going to come to, of course, I'm definitely going to run those commands there, all right? So that's it. So I'm just going to close that gently. So just to give you a reflection of how I open my command line, I use my Windows key. I'm running on the Windows key and R, and then it's going to give me the CMD here. Then I'm going to select OK. Okay, so that's how I did that. Now, when we are done running the installer, uh, for example, if I just come here and like I said, and I click on this, it's going to start the installation process. And when it starts that installation process, of course, it's going to give me an opportunity to add Python to part. So what it means is that to add Python to part here, you must make sure you add it to part so that it's something that will be easy and compatible for you when you're navigating around your terminal. And yeah, I love that. So just kind of verify installation, then install your pip, and that's it. So I'm not, so the next thing is if we are, let me just show you something right now, and I'm going to go to PowerShell, and then maybe, okay. So let's see, I kind of do something like Python. Okay, let me say Python dash dash version. Let me just do that again. And maybe I try to do print welcome. Let's see if that works. Okay, unable to do this because okay, so what I'm going to do now is I'm going to show you something now, right now. Now, if I go back to here, now there is something we call a code editor. So I'll see what I'm going to do. Now, go to code.visualstudio.com. Maybe I'm just going to type this and I'm going to come here. Now, I just have to fit in on my all my dependencies properly on my terminal. But what I want you to understand here now is that whenever we are writing any Python code, we don't just want to be writing it on the terminal. You see some of what showed up when I was trying to write it on the terminal. It's told me, okay, it's not compatible to that and blah, 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 and all of this English language. But basically, what I want you to understand from there is we could decide to say, okay, instead of running our Python command on our terminal, we can have a better place where we can run our code. And that's what we call what? A code editor. So another name for this is an IDE. You could call it an integrated development environment, okay? And I think I'm just going to open a note. I'm just going to go to Microsoft. And just give me some seconds in case if you want to write. And all right, so it's going to let me log in. So this is where we're going to be making some notes. Got it? And we're just going to open this. Just in case we have some notes that we want to put down in place. And I'm just going to call this Python tutorial. All right, so we're going to be making notes here. And remember, the first thing I said is we have what we call the IDE, and this is what we call the integrated development environment. So this is just like a what? Code editor, right? So we have the VS Code, and then we have the PyCharm, okay? All right, so that's it. So what it means now is that so you're going to choose which one is actually compatible for you. So how do you download the VS Code? So you just open your computer, go to visualstudiocode.com, I'm going to check the download for Windows, and I'm just going to click on that. And of course, this is what is compatible for me on my system. And you could see that it has started downloading that. But I'm going to close it because I already have it installed here. Now, in a situation whereby you don't want to use VS Code, you could go to JetBrains, JetBrains Python. Just search that. That's www.jetbrains.com. So you're going to click on this. Then it's going to open it's going to open the it's going to open this particular layout for you. Then you're going to choose your operating system. As usual, I'm running on Windows, and I'm going to click on download. Now, I'm not going to download this because I still have it downloaded here. So that's also another environment where I can write my code. So I think that's basically that for now. We wouldn't talk about what these code editors are, but I'm just going to talk about them uh, when I'm done explaining what it entails. All right. So when we are installing, so we just make sure we install the Python extension for IntelliSense. And what do you mean by that? It's just kind of helping us in auto completion, right? And maybe some sort of lengthening and debugging. Okay. So PyCharm is also another one that we use. It's mostly used for Python. It's also a kind of a code editor. Now there are also other ones, other type of code editors. We have the Sublime Text. We have Sublime Text. We have Replit as well, which we can also use as our code editor. So let me just kind of say something of maybe Sublime Text. So you see that that's also a code editor. That's where you can write your code. Remember, the reason why I'm telling you all of this is because we don't want to write our code on the terminal, okay? We want where it's definitely going to be easy for us to write code that can be interpreted. So that's it. So this is also another one. Uh, they kind of looks alike, but just for you to just understand what it's all about. Now, I also have another one that we call the replit. Remember, like I said, I'm definitely going to explain all of this in details for you. So this is also this can be used as a code editor, right? And just kind of I'm just going to say replit code editor. So they also have kind of an AI built-in code editor, which also works, right? But basically what we're doing now is we're setting up the environment where we are going to write what? Code, because we don't just want to write our code on we don't just want to be writing our code on our terminal. We want where it's going to be easy for us to read. Other developers who might look at our project can also read our code and make some meaningful insights out of it. So that's definitely going to be that. I think I could just maybe shut some of these down and then open my VS Code so that we could know the next line of action. So this is our code editor. So what I'm going to do now is I'm going to create a file, and okay, I'm just going to create this on my desktop. Okay, so I could create it anywhere where I like, and so let me just kind of keep it on my desktop. So I'm going to right click here. I'm going to go to new. So I'm going to call this Python tutorial. Okay, and then I'm going to check this and I'll select the folder. Now, Okay, I think we didn't. I'm just going to come back here. All right, so good. So we'll open the file and then we'll select it, okay? And then the next thing I'm going to do, so this is where we're going to be writing several of our code. Now, but someone might actually ask, so I could just check out this, close this, okay? So I'm going to explain this interface for us. But before I actually explain that, let me also open another IDE. And this time around, this is PyCharm. So it's also released in versions, all right? So you can also sort of release it in, it's kind of, updated. There are kind of updated versions of the PyCharm IDE. But remember, the idea here is just to uh, make it familiar for you to see how code is being written, and that's it. So that's it. So this is the project folder. So I'm going to also explain that as well. So I could just expand this and then zoom out from it. Now, so I'm going to explain all this interface, but before we do that, let us have a look at our slides. All right, so I think it still kind of keeps us there about it. And since we now had a look, let me just give some kind of explanations on that on the interface. Now here you have file. So when I install VS Code, this is Visual Studio Code, right? So this is the integrated development environment for Visual Studio Code. Now, when I actually install uh, Visual Studio Code and then I've added it to path and all of that, this is what we call the files. So what do we do here? So this is where we kind of navigate around our files. We can create a new file. We create a new text file. We could create a new Windows. Lots of stuff we can do here, right? So that is what this particular drop down offers to us. Now, also, apart from that, this is also what we call the edit, right? So we could redo, undo, change things, Control Z. Maybe we wrote a certain line of code and we want to change it, want to change it back. Can use the edit, right? If we're not using the short, if we're not using the more of some of the command prompt, or maybe short maybe you want to do something like Control Z to undo, or Control Y to to maybe bring something further that you've done, right? So basically, you could just use you could use you could come to this particular part and then just kind of change some stuffs and then see. So you could also toggle line, you could toggle box comment, block comments, you could expand. But basically, the reason why I've not talked about some of this is I'll show you how to do some of this actually being done in the advanced session. But then for now, as a beginner, I just want you to understand that the edit tab is used to undo and redo, copy paste, and all of that. So for the selection tab, what do we use it to do? For the selection tab, we could select all, we could expand selection, we could shrink our selection, we could copy lines up, we could copy line down, we could move our lines up, we could move our lines down, we could duplicate our selection, we could add cursor above, we could add cursor below, we could do so many things on our selection from the selection tab, right? So I'm just going to show you how some of all of this is being used in real time. And then for the view This is where we can actually bring up our command palette. So you see that there are a lot of extensions here, with respect to settings, how to manage some accounts, lots of stuff, how to set your cell tag size, stuff, you know, actually could be done here. And we could change the appearance. I could decide to change the appearance here to full screen mode. I could to change it to maybe reduce the appearance, center the layout, but I don't just want to touch anything here because I'm quite very much okay here, and that's it. So even our editor layout too, we can do some changes there. We could split it, we could do some stuff, and that's it. So a lot of things could actually be done here. We could navigate to our source control, debug, go to our terminal. So if I kind of click here, this is like a dedicated terminal that is inside your Python, uh, that's inside your Python IDE. Okay, so here we could do something like, for example, Python, let's see if that works. Python dash dash version. Okay, okay, I think I made a mistake here. I added, okay, all right, so I made a mistake. I added more than one hyphen or dash. So you see, this is also what we call an integrated terminal. Just the same terminal or work shell that you might have on your that's PowerShell on your Windows or your Mac, Linux, Ubuntu, whatever stuff. You could also do some stuffs here as well. So you can also create a virtual environment here, which is somewhat advanced. I'm going to talk about that later. So I just want to kind of keep all of this very simple. You could have more than one terminal. If I click on this, it's going to give me another part of the terminal where I could do something like Git. I can perform some Git actions, so say Git init, and it can initialize a repository. I can say Git add dot, and of course, give some command, maybe Git I want to commit this project, git commit m, uh, initial commit. Now, what I want you to actually understand here now is, okay, I made a mistake. I didn't spell that correctly. Now, what I want you to understand here is that we can have two uh, dedicated terminals that's running, right? So I could be running something on this part, and then I'll move to this part. I'm running my git changes and all of that. So the next thing I'm going to look at right now is this button here. Here you could switch some groups, if there are, kind of just depending on how you structured your project. And you could go to file, we could do some declaration, we could use, go to the lines, and a lot of things that we can do here, which is very useful, particularly when we are trying to deploy production, based applications and all of that. So I think that's definitely going to be that for now. Uh, to run here is you check out that's the program, right? That you're trying to execute. And then you of course, you will always run it, right? You will always run it. And of course, I'll show you how that works. And then we'll have our terminal and then help. So I've just taken out my time to talk about some of what is in the top nav bar. Now let's look at the sidebar, what you can actually perform. Then I will have what we call the extensions. So that's what this is. Now, immediately you're done installing Python, and then you've now installed the IDE, that's the integrated development environment. The next thing I want to do is to install an extension. So what do we mean by that? Now, by installing an extension, what we are saying now is what? By immediately you're done, you need to install the extension for that. So we've installed Python and the IDE. So we might want to come here to search for Python. So what is going to be sorry, I'm just going to search Python. So from this extension here, what we want to get now is that we want to kind of get some that we want to make sure that the language itself is matching with that's the base interpreted, or maybe that's the base interpreted file that we've downloaded, right? So by installing this now, it means that we can write some Python programs here, do some stuffs here. And of course, it's going to be interpreted on that's the initial one that we did install, which we don't really just want to be running it on what do you call it? Running it on maybe on the terminal and all of that. Do you get? So yeah. So that's why it's very important for us to, actually install all of this. Now, the next one, now, if you're joining this particular session, so it means that kind of you have some machine learning aspirations, right? Another environment that we're going to look at here now is what we call the Jupyter Notebook, which is what I'm going to be talking about next. But I'm just starting to talk about it here in this extension, just to let you know that even when you install Anaconda or maybe any sort of Python or maybe any kind of an environment that lets you to write, machine learning code, and then or maybe you want to use this particular IDE, we must have to install the Jupyter extension as well, because you can see that I have it installed, and over 100 million people have this thing currently running. So that means what I actually means right now is that what we have to install this so that it can let us have our notebook on a particular in this environment, which we are definitely going to be seeing. So a lot of things are definitely going to be done just to make things really, really very easy for us. So if you're running on C++, maybe any other type of programming language, you could actually come here to install that particular extension. And of course, I'm just going to CPP just to see. So you could see that here you have to install the C++ extension for compiling C++ code. Now, if it is Java, we're going to also search that. And then you can also see that as well. So we have about 6 million people who have installed this. Now, I'm not only going to install this because I'm not a Java developer, but just for you to have understanding of what I'm talking about. Now, if you see, the same thing also happens, just like C++, and then you see I could just continue to go down. There are millions of extensions. Then what other language do you have in mind? That, as for Flutter, and you're going to see also you have to still install the extension. So what point did I just teach you right now? What I just kind of showed you right now is that if you're using the VS Code, which is what I highly recommend using VS Code. You must make sure that you install the relevant extension. So first thing you must do as a machine learning engineer is you must install the Python extension so that it can be able to translate your code to your interpreter, which you've installed initially. Remember, the first thing we did was to go to python.org, and then we installed Python. And then from there, we said, okay, we don't want to run our code on our terminal. We want to run it on an IDE where it can help us with lengthening, show us if we're making mistakes and all of that. And then what we're now seeing right now is that having the extension installed is actually very imperative. There are also other things out there like debugger and a wider array of it, right? So this is really, 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 really what recommended. So I think that is definitely going to be that. We now have an idea of what this is. So this is so I'm just going to check out this. So this is actually where we can actually run, open some files, perform some debugging, and this is, our source control, right? Source control. So maybe each time if we want to maybe manually, or we don't want to use code, particularly to push things to our Git repository. What I mean by Git repository now is kind of a library where we store files and all of that, right? We store and update our code. If we are done writing code now, we'll commit it there, keep it, and then if we make updates or changes to the code, because we have our Git repository, it can be easier for us to, check, change some things from it, use the previous version of our code, just kind of make some changes or anything we want to do on it, right? So source control powers that. So here's where we can search, and this is this kind of takes us back here as well. So I'm just going to delete that. So that's definitely going to be that. Now for your, if you decide not to use the VS Code, and of course you find it very interesting to use, maybe you want to use PyCharm as a programming language, then that means you might want to use open it, and then if I kind of delete this now, let me just delete this. I don't know why that. Just okay. Let me just press the delete key. Okay, so what I did was I pressed the delete key, and yeah, so I've deleted it. Now let's say you're using PyCharm, and then you're done installing it. You want to start writing Python code. So what you might want to do now is to click on this place, right? So you click here, and then it's going to open Python file. So I'm going to click it. So what I'm now going to write what I want the name to be. So I could say main. Now I don't necessarily need to say .py here because this is already going to give it to me by default. So I run that. So it gives me this. And why do we have main.py? Because py is the extension for that. Now let me just kind of go back to VS Code here, and let me just kind of go back. And maybe here, I want to create a file. So I'm going to say main.py. Now remember that when I created this folder, there's nothing really special about the folder. Like there's nothing really, really, really special about it. I see it pops out some warning. Now, the reason here is this. The reason is because the reason why there's nothing really special about it here is because of the fact that what is going to be special about the type of programming language I want to use is the extension that I have. That's the added extension to the keyword. So let's say, for example, I have something like index.js. Now I see that this is a JavaScript file because of the extension what? JS. So if it's Py, let me see, it's a Python. If I have something like main.html, And then also maybe I could add rough.cpp. Now you see, it's trying to tell me now to install the recommended extension for C++. I'm not going to install that because I'm going to delete this. And the reason why it is untracked here is showing is because of that git command. In short, I'm just going to delete that real quick. So let me just close that. In short, what I'm going to do now is, so I'm going to delete the file, and then I'm going to open this again. So I'm just going to open folder, just so you watch what I'm doing. So remember, I'll come here, I'll create main Python project. And then I'm going to open the folder. I've opened it. You must open it. And then I'll now select it. Don't save. So yes. So inside of here now, like I said, I could create main.py, and that's it. So you see how, and I could create, or maybe random.html, and it's going to create the HTML file, which I can create a boilerplate for it. Okay. And then also I could create maybe index.js. Now, what am I trying to say? The extension that you use matters. I'm using py because that is what Python. So here I can now say print whatever thing I want to do, right? Which we're going to come to. So I think that is actually very important. I'm just going to close this AI window. So random.html is going to take only HTML files. So if you're building websites and all of that, and then you're using this as a code editor, then of course you're going to be using this particular extension. So that is definitely going to be that. So so the next thing is going to take us to how to run our first program. But then let's talk about other IDEs that we use for machine learning, right? So I'm going to come here. So how we'll call we have the Jupyter notebook, and then we have Anaconda, then we have the Google Collaboratory. Okay, etc. So we have a lot of them. So what am I trying to show you here? What I'm trying to say here now is for you to open Jupyter, how do you open Jupyter Notebook? I'm going to come to my VS Studio Code. Let me just kind of close this. So I'm going to click on practice dot interactive Python notebook. Now, so that's the extension that we use for it. So let me just kind of write the name. So I'm going to use a markdown extension for files. Okay, and so so if we use, I'm just going to kind of, so if we use the .ipymb, so that means interactive Python notes notebook. Okay, so that's actually the extension for this, right? So if we use the .py, so that's going to be the what? Python, right? Cool. So yes, I do understand, Sha, if you're watching this video, maybe you might want to just kind of maybe get into the practical parts, but I feel like most of these are actually really very important for beginners. So this extension here now means that it's going to render this page for us. But if we use Py, you're going to observe that we just have multiple lines where we can write lines of code and all of that, right? But when you look at this particular interface here, what here means is that you can write multiple lines of code actually here, but I can be doing something in this interface and then create another one and start doing something here. For example, I could say print uh, welcome. Okay, all right, wait, hold on. So the next thing we'll do now is we'll select our kernel. So what do we mean by kernel? Kernel is where we are going to, that's our Python environment. So I'm going to choose Python 3.13.5. Okay, so I've selected that. So what that means here now is that if I come to this place and I print welcome to Python programming, and then I kind of go up, I could go up here and say print. So no welcome to Python programming. So to run that, I'm going to use Shift Enter. That's going to run it. So I'm going to say x is equals to 10, print x, and then I'm going to come and say x equals to 78, print x. So this first runs, and this first runs, and this also runs. So what does it mean, which I'm going to explain? So it means that we can actually write code at various cells. So maybe we might be training a neural network here, whereas here we're actually performing another, maybe another kind of task. Or maybe here also we're performing another task. And maybe here we're performing another task. That's why we use the interactive Python notebook. So I think that is definitely going to be that. I don't really want to waste so much time, particularly on this part. But if I want to show you the Google Collaboratory, so I'm just going to just jump straight into mine. So I'm just going to come here and so I'll click on Drive. So this is something everybody has on their system. Now click on New. Now go to More. I'm going to select this. Now what did I do? Drive, New, More. Now the reason why you can actually have this, so I just got it and So the reason why you want to use this is probably if you don't know how to install Python. This can actually get you started immediately. So if maybe I click on it, it's going to load the interface, right? For me to write Python programming, right? So I'm just going to close this and maybe I could just call this. Well, I think I'm just going to keep this practice. That's practice Python. Now you see the extension here, interactive Python notebook. So it means that this also behaves the same way like the previous one. Here we can write code here. I could just say uh, maybe print how many came yesterday, right? And then I could just go up and I print welcome. Now I could use this button run all. And I'm just gonna give it some time. So you see, I didn't really do anything here for this Google Colab. I just kind of jumped into it and then I started programming for me. I didn't install Python. So that is how Google has actually provided that. So usually why I could use it so many times is because of the fact that you can install things. It has TensorFlow installed. It basically has all the packages, that you want to use to code installed inside of it. Okay, so that's it. And I think after this, there's also another code editor. You could write lots of long code here. You could do a lot of things, of course, which gradually we're going to get into that. So that is definitely going to be that for now. I just believe I've covered everything with respect to installation, setup, and let's kind of look at how you can run your first program, okay? I have this here. I must say I've already done that for myself, but if you're watching this video, I think the best thing to do for yourself is to bring out your laptop and start typing. So here I could just do print, uh, hello world. So I'm going to shift enter, and then also I could just kind of create a variable real quick. Go say name is equals to David, print name, and that's it. So that is how it works. Now, how about the mempi file? Of course, uh, could print welcome to Python programming. Now here, if I do shift enter, okay, of course, it's definitely still going to work. But what we will always do here is to use this box here. So click on it, and then it is going to run it. Run it, and then you see it here. Welcome to Python programming. Okay, all right, so that is definitely going to be that. I think that's it. We've just kind of looked at how to run your first program and how it displays on the console, several integrated development environment, and that's it for now. So what's actually our workflow before we continue here is we move from writing code in VS Code down to our PyCharm. We save it using the .py extension. We run it in our terminal, and then that's the file name .py, and then we review the output. Now look at when we say run it in the terminal, that might be kind of confusing, but this is what it is. Let's say I don't want to click on this now, and I do something like maybe let me just create a function. I know this is very advanced. Okay, no, let's leave that. So let's say print my name is Mason, and then now ordinarily it doesn't print it, but when I come here and do main.py, it returns my name is missing at the end. So that's what we mean by running it in our terminal. So we can review the output, fix errors, and iterate. All right. So that's actually the life cycle for you to install dependencies, master this cycle, write it, save, run, review. This is just the foundation of many things that are going to be doing in Python. Okay. So I think that is definitely going to be that for now. If there are concerns with respect to this, we started by talking about how to install Python, into your local computer setup, and then set up your extensions, some several IDEs that we have, and the extension inside of it that you could want to set up. But a good questions could be, okay, whether we should have downloaded any extension here. But the truth is that the PyCharm here is built specifically for what? For Python related, tasks. So there might not be need for you to install any extension. It immediately you install it as a code editor. It automatically communicates with your immediately with your that's the interpreter, that's the Python interpreter that you've already installed. And I think that's definitely going to be that for now. Now, so we're going to get into the next part of this lecture. And then the next one we're going to be looking at right now is we're going to be looking at variables and data types. Now here we're going to learn how Python stores, labels, transforms information, and essentially, how to read user input, how this is what we're going to be covering in this second module. All right. So I'm just going to kind of close this. So I'm going to start by talking about comments. Then after that, we'll talk about data types. And then we've got variables. And then we'll look at accepting user inputs, and then any other thing that comes with it. So what's a variable? Now, whenever we talk about a variable, we're talking about a container that stores a value inside your computer's memory. Okay, so it's just like a labeled box. So the name is the label and the value is what's actually inside it. So for example, people say X costs 5, name is cost Aisha, score is cost to this. So what it means is that in the memory of the computer, Python is going to create the box, give it a name, and place the value inside of it. So if I want to kind of buttress that particular point, let me just delete this. Okay, let's just keep our file clean. And So I'm just going to be navigating around. I'll come here, the next time I'll move in. But I think it's going to be better practice here. I'm going to show you why I'm also navigating within this particular part. So I just defined variables right now. Variables, right? So it's kind of, I say stores variable, it stores information in a container, okay? It stores information in a container. Now you know why, basically what I want to talk about comments, but let me just show you something right now. So let's say, for example, we see name is equals to, uh, name is equals to Cynthia. Now, if I print name, now it prints Cynthia. Now watch, it doesn't print this two particular line here. And that's what's called what? A comment. So comment is some of the information we don't want the computer to run, but we want to use it to display some display or communicate information with the reader or other developers, right? So that's actually what we mean by comments, right? So we can also have multi-line comments. So this is just a single line comment. So if I say 4 plus 5, 4 plus 5, and I run it, it's going to give me 9. So you see nothing happens here. But what happens if I remove this pound sign here and I run it? It's going to throw syntax error or indentation what error. Okay, so indentation, so let me take it to the end, and then we'll have syntax what? Error. So that's it. So that's what we mean by what? Comments. All right, so I think that settles that. So, right, so let me just kind of, so as a shortcut for putting our comments is I could use the control backtick or command backtick if you're using maybe a Mac or whatever. So if you look at this particular stuff here now, you see that it stores information in a container, okay? So variable stores information into a container. So you have name is equals to Cynthia, you have a surname, I could say surname is equals to Greg, and then you have age is equals to 78, and then you have uh, eating equals to 2, and then maybe that's like weight is equals to 87.3, right? So these are what we call what? Variables, right? So what happens in the memory of the computer now is that there is a box called name, and it is now representing Cynthia. Okay? So that is basically what it talks about. So there is there's a box now called what? Name, and it represents what? Cynthia. So that's what that box represents there. So yeah, so that's just basically it. So what it means now is that for surname, there is a box called surname. It represents what? Greg. And then that's why you can actually print, I could print surname, comma, age, comma, eating, just like I did explain all of them, and then meet. And of course, I'm going to run that, and it's going to print out everything for me, okay? So that's what we mean by what? variables. So it means that all of these things now are now holding some kind of information in their memory. So some are holding some type of data type, which I'm going to explain later on, but then some are also holding all of others. So it could have something like blood glucose level, and then I could call this maybe 78.8. So you could print blood glucose level, and of course it's going to give you that. So what just this means is that these variables are actually holding some information in memory. But I want you to really understand something here, that the same thing, you can see that it's displaying all of these outputs here. If it was to be in our main.py file, and probably that we just kind of run all of this here, you see that it's going to display it below the console, and that's here. So let me just kind of delete this. So to open my terminal, I'm going to press Control backtick. Control backtick, please command backtick if you're on Mac. And then I'm going to run all of this again. So here I'm just going to say main.py. And then you see Cynthia, Greg, and all of that. So this is just basically the same thing here, right? Now you see that the difference now between this and this is that, so it means that we can easily do something here without having to alter this part. And that's where it's going to be really very easy for us compared to this main.py, which means it's going to be running everything from top to bottom. But here it can allow us to create another cell, do something privately there, and run it, rather than having to call that particular, running the whole stuff all the time, right? So that's just the idea here. But I don't think it just change anything. I just kind of wanted to give you an update to that insight. But yeah, every other thing is still the same. Okay. So these are what we call what? Variables. So what is a variable here now? Name is a variable, surname is a variable, age is a variable, eating is a variable, weight is a variable. They are all a container that is holding some sort of information in memory. So some of them is holding strings, some of them is holding integers, some are holding what we call Boolean data types, and just basically understanding, and that's how it works. So that's actually for variables, right? And yeah, so the next thing I'm going to be looking at now is type naming conventions. Naming conventions. So what do we mean by naming conventions? So by naming conventions, we're kind of interested to know how, how to name our variables. So if I come back here now, it's going to tell me how to name my variables, right? I don't need to, I need to know how to use, I need to be case sensitive. That's basically anytime I'm naming my variable, I must start with, maybe a letter or an underscore. I need to use letters, numbers, just basically how to do it. I cannot start with a number, no spaces, special characters, cannot use Python keywords and all of that. So let me explain all of this in code. Now, so what are we trying to say now? Take, for example, now, when I said age is equals to 78. Now, I can't move my cursor here and say height is equals to 7. Now, that's going to throw an error, right? So it means that I will say here, there should not be spaces before the indent, okay? Now here, age, I can good practices. I can say age is equals to this. So this works as well. It works. Because if I say print, of course it's going to work. But here we'll say good practice is start your variable with a what? With a lower case. So that's why we say age, and that's why we can say height, and that's why we can say maybe is available, maybe true, maybe it could be false. Okay, but just basically what you need to understand here is this is what, so this is good practice. Okay, so you need to start your what? Start your variable usually with a lower case. Now, I can't say I, maybe I can say one name is equals to Uche. Then, rather, I think Uche has to be in string. Now, this is a bad practice, right? So this is a bad practice. You don't start a variable with a name, with a number. Okay, so that's actually bad practice. Now, another one that we're going to look at right here is we're also going to look at, what we call camel case. So that's what we call the camel case. So what do we mean by camel case? We can have something like this: name of name of school is equals to Abuja International. Now, this is what we call a camel case because we have lower, then before the next root word, we have upper, and then lower again, then the next root word, upper. So let me just kind of make that clearer. So let me see, I want to do something like Nigerian, okay? You don't need that. In then, okay, is equals to praise, praise David, okay? Because I'll become a president. And then I could say something like maybe equational maths, equational mathematics is equals to start point one. And so all of this actually works. So kind of print name of and then I'm going to print equation mathematics. So I'm going to run that and then that's it. And so that's what we call the camel case. So what's like the snake case? Snake. So we have something like this. We could say um, department name. Now you see we use the underscore. So we could say department name is equals to machine I could also do something like pattern of moving. Maybe so yeah. So that's actually how we name variables, right? So put a snake case and what else? Okay, I think that's better. And then I could also say something like maybe child nutritional status. And that's going to be something like positive. Okay. So that's also another naming convention, right? So these are also other what? Other naming conventions. That's how we actually name our variables. So very, very important. So we can do something like or maybe something like class is equals to maybe primary. So we can't do this because what? We can't start with quotes or any other special symbol. So it has to be what? It has to be started with a letter and most case lower letter. Now, if we wanted to add a number here, we could say class 1. So that's going to work. Or even without that class 1, and then we'll print. Of course, this was from my train. So you're going to see this as well. Child nutritional status, title movie, department name, and a lot of things actually there. So I want you to also understand that we could have multiple lines of comment. And I could just assign everything here to details. So watch, if I can print. So you see, I've converted everything here into multiple line comments. And also printed it like a paragraph kind of. So that is definitely going to be that. And yeah, all right, so I think I'm just going to delete this. And so that's it. So, what are we actually able to take home right now? So we now know that this is actually how to name variables. You have to make sure that you don't start with names. So you don't start with numbers. You don't mistakenly indent. You also need to make sure that it's kind of very properly formatted in lowercase and just basically some of those nitty-gritty important steps, particularly in terms of naming your variables and all of that. Like it doesn't really have to be much of a big deal. So the next thing I'm going to look at right now is since we now understand how to name our variables, we know what to do is before we talk about data types, we'll just kind of slide back here and look at some of the core data types that we have. So we have We have three core types of data, right? So we have numbers, we have strings, and we have booleans. Now, under numbers here, every values that you see in Python, belongs to a data type. So Python figures it out automatically, no declarations needed. So what it means is what? If you're writing a program in C or C++ and all of that, you might want to do something like this. Remember, we are currently now at data types. Let me just kind of make this a markdown so it's easy to read. Okay, that's why I always want to use this. So I just want to kind of make everything easy for you to read. I'm just going to spell that wrong. And okay, so here's going to be naming conventions. So what did I say? I said for data types we have what we call numbers, we have strings, and we have what? Booleans. So numbers is going to be divided into two. We're going to have we'll have integers as whole numbers, and then we're going to have floats. Now, so that's that. I think I actually forgot one thing here, particularly in these naming conventions, which is reserved keywords. Let me just kind of talk about that briefly. So reserved keywords. Now, what I mean by reserved keywords, so I'm going to click on code here, none of them. So what do I mean by reserved keyword here before I continue with data types? Is that in terms of, this is also naming conventions, continued. Now, what it means is that there are some certain words we don't use in assigning variables. So I can come in and say, maybe I can come in and say y equals to David, right? And I can come here and say if equals to uh, Donatus, and maybe I will now say try equals to Chidex, or then we will now say 4 equals to maybe 67 point this. Now, if I run this now, it's going to create an error. And the reason here is because all of these terms are reserved keywords that we use in Python programming. So what I'm going to do is towards the end of this session, I'm going to just kind of go through some of the slides, just to give us some feed forward, like just some kind of refresher again on some of what I've already been talking about previously before now. But basically, what I'm trying to point out right here is that there are what we call what reserved keywords. So we don't use some of these keywords in assigning variables, right? So there are many of them. So you just kind of look them up. We can say import equals to maybe
Hmm?
equals
Is this? Maybe. Hmm?
okay. So just kind of keep questions to the end. Just keep questions to the end, like just to make everything easy. All right, just kind of write them down and keep it to the end. But like I said, these are what we call reserved keywords that we don't use them in 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 naming variables and all of that. Okay, so there are loads of them. Pass, can actually have pass, can have continue. So these are bundle of. So how do you actually know them? By working with Python. When you continue working, working with Python and all of that, you see that there are so many things that we don't use. We can't use list. So uh, this might work. This equals to precious print. This might work, but this is not advised, right? Because these are special characters, special keywords rather, that we use in Python programming. So these are actually some of that I just wanted to mention. It doesn't affect any other thing that I've talked about before in terms of how to name it, using keywords and blah, 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 you know. But just know that there are so many words that we can use, right? Every other ones can be used. Okay, so now based on data types, now what do we mean by data type now? So let's say, for example, we are trying to build a health data set. We are navigating a health data set, and then we are dealing with something like maybe, for example, ordinarily we have something like maybe first name. Remember, this time we're using the snack case, is maybe Sherman, and then just know what's the issue? Issues? Okay, all right. So let's say, for example, we are doing something, maybe first name, and then that's Chioma, and then maybe second. So I want to get the, let's kind of get the health profile of a patient so we can now be able to know what data types are. So, right? So first of all, now we're working with a patient health profile to make understanding of data types easy. Okay, so what's actually the first thing you might get from a patient profile? You might be asked what is the age, and then maybe you could say maybe 45, and then what is the gender, and then of course that's going to be female, and then just going to take this up, and then you can also ask what is the history of malaria, and that's going to be severe and persistent, 2 weeks. And then also you could actually look at test score. So probably you're gonna see positive, so 7.9. And yeah, so availability of patients weekly. Now this is what we call what? Maybe you could see true. They are always available. So I think that's just basically that. Maybe I'm just going to change this to, maybe let me add another one. I'm going to say Um, Number of those here is going to be maybe 20, 23 or maybe 12 or 12 per day, all right. And then that's the score, probably the person's BMI was going to be maybe 29.7. Now, there are two things that this particular assignment now teaches us right now from the health profile of this particular patient. Now, first thing is that it kind of shows you how variables have been assigned. So this is what we call an assignment operator, okay? So if I kind of go back here and I come here, I'm just going to tell you something, right? So there's what we call what we call the assignment operator. And what is the assignment operator? It is the what equals sign. So we're going to be using it severally in this particular tutorial. So that's why we use it here. Equals, single equal sign, and all of that. But that shouldn't take us away from what we are talking about right now because we are more interested in knowing data types in Python. So now imagine I cannot do print. No, so how do we know the type of data that this is? So I could do something like print. Now remember, we talked about the print function, right? So what do we do? The print function is what we use to display something in the console or in the terminal or whatever. So you kind of, I print age is holding this data. It releases 45. That's what it is. It kind of reveals who you are. Okay. So rather than doing that now, I'm just going to see. Now, what we are interested in is we want to know the types of data. Now, I'm going to now pass in another maybe method or function inside of it. So I'm going to pass in type of age. So I'm going to print type of gender. Now you see that each time I type gender, whatever thing, it kind of gives me an autocomplete. And that's why it's important for you to write using a, a code editor because a code editor helps you much more better. You know, it makes your work really very easy. Uh, Number of those, I'm gonna print type of history. So we want to know the type, print. Remember, repetition is going to really make us understand this very well. Okay, I think I've done that before. And then I'm going to pass in BMI. I'm going to print. Okay, print. Okay, now that's it. So I'm going to now pass in something inside of this. Now I'm going to say the type of age variable is, then I'm going to also come back here and I'm going to see here, I'm going to see the type of gender variable is, I'm just going to show that. I'm also going to come here, I'm going to see the type of num on this variable is the type of history of malaria variable is. Now, I just want you guys to really understand this very well. Type of BMI So I'm going to also highlight that. Let's see. Type of available. Now, you're going to watch what I want to do now, right? Now, the reason why I'm actually doing this now, typing all this is out info, is just so that you guys can actually understand what this entails. So if I kind of run this here, now what does this show you now? So it shows also that the type of age variable is of the class int. So what int means? What does int mean now? So int here means what? It's an integer type. So it also shows us here that the type of gender variable is what? Of the type what? String. Now, the next thing here that it shows us that the type of number of this variable is what? Integer. I'm going to write it integer. It also shows us that the type of history of malaria variable is what? String. So that's what? String. And also shows us that the type of BMI is now something different now, listen. Float. And then it shows that the type of test score of that also is what? Float. And then it also shows that the type of this is what? Watch. Boo. Now let me say I kind of add uh, uh, maybe let's say for example, coming to class, watch, and I do false. So it means that if I try to say print the type of coming to class variable, and then I kind of remember you separate the comma, and then you pass in the type, then you pass in coming to class. Of course, that's still going to give us what? Bool. So it means that this is going to be what? A Boolean. So before I actually show you slides or open my slides and all of that, just kind of show me what some of these are, right? So it means that this is an integer, right? That's age is an integer. So what are integers? Integers are what? Whole numbers, all right? So that is definitely going to now bet us into maybe understanding data types so much more better. So integers are what? Whole numbers, all right? I'm just gonna write that here. So I'm going to say integers are whole number. So most times in machine learning, we're going to be working with integers, maybe, and that could be our label type. Usually our label type there you can have zeros and one, where zero can mean infected, not infected, one means infected. And maybe something like, let's say for example, number of children at school. All right. So in that case, now that's what? That's an integer because you can't have something like, you can't have something like 56.4 children are in school. That doesn't really work. And another one thing you can actually have here is a number of, it could maybe be another thing, maybe altogether, maybe age at last birthday, maybe number of women at the market. I think that actually has similar example with well, actually detail. But just basically anything that's going to return a whole number. Anything that returns a whole number value. So that is definitely going to be for that. Now, but what are strings? So strings are actually some kind of sets of characters, sentence, or words. Now, I might have not used a character here because that is more like a word. So let me say I want to print type of maybe C. So C is a character. It's going to give me string, right? Because instead of storing this thing inside of a variable, I just kind of printed it direct. So that tells me that it's what? A character. That's a what? A character. So by being a character, uh, it just entails that it just kind of tells you that this is a string, right? So you can also have a very long sentence. Maybe let me just kind of put something like this. Let me show you what I'm talking about. So we have three. Welcome to Nigeria. I am available today. Hope you're doing well. Now, if I kind of run this also, it tells me that this is a string. So whether it's a sentence, whether it's words or a character, that is definitely going to be of the class string. So that is just for that for data types. For floats, that's for strings as a data type. So for floats, what are we actually after? So floats are what? Decimal numbers, right? Floats are what? Decimal numbers. So if you have something like maybe age reading, maybe not age reading. Now let's say for example, we have body mass index. That's of course definitely going to be a float. And if you have something like maybe if you have something like let's say for example it could be really anything, right? But just think about it as anything that is going to be like anything that results to what decimal. That could be maybe something like blood pressure. Another example, that's a float. Another example could be anything, right? Child, or maybe say fracture. And we could have something like wound, fracture, score. And then maybe probably it is scored in maybe 0.00 to 100.00. That is what we call what? That's what we call a float. So that's definitely going to be that. So it could be literally anything that's of decimal value. So where do we usually use floats? We usually use it maybe whenever we're training neural networks and yeah, any sort of neural network, activity, they do require floats at many times whenever we normalize values. Okay. So let's say we have some kind of image scores and we want to pass them through a neural network. Of course, we might have to kind of normalize them. And maybe when we normalize those values, it can all become some sort of, kind of float, whatever stuff that you want to call it, right? So when you normalize values, you kind of reduce them so that it's more easier to pass it through the neural network. I know that might actually seem confusing at this stage, but don't worry. It's only something to bother about. All you need to know right now is that floats are what? Are some sort of decimal values, and that you're going to be using it all the time. Now, I just want to kind of make an important distinction, remark that if you are doing, if you're performing any sort of now, if you're performing any sort of, let's say, for example, you're doing maybe this time around now, you're using JavaScript. Now, you might not actually have it being called a float, because in JavaScript it's usually called numbers. And but here in Python, just understand that when we're looking at data types, we've got some of floats, which are decimals, and then the ones that are whole number values are integers. But in JavaScript, it could be numbers for both of them. But just important for you to have that, distinction. But then in other languages like C++, you have C, you might want to use what, floats if they are designated, keywords out there. But as a machine learning engineer, you must really, really, really know data types, right? When you have numbers inside of a list, sets, whatever thing, understanding, the data types helps you even have much more clarity in navigating the data structure and algorithms. So those are actually going to be that for now. Nothing to really worry so much about. I just kind of hope this really makes a lot of sense, particularly to anybody out there. But yeah, I just kind of need it to just to see that everything works out really well. Now the last one is going to be booleans. Booleans now, for booleans, so booleans are usually true or false, right? So we have true or false. So what do you mean by true or false for booleans? So basically, what true or false implies here is that you could actually say is available, or maybe present, and is present here is going to be a boolean. It's going to be present true, and of course I could print is present, not is stands, and that's it. So that's true. Okay, now what I'm trying to say here now is that if I try to get the of this variable here is instance or not is present, it's going to tell you that it's of the class Boolean. So what that means is that being of the class Boolean here is there are definitely times where we're going to be storing values with Booleans. We're going to be passing some variables in classes. And, it just kind of gives us really that understanding of what we are doing. That maybe we could, I could also do something like maybe, let's say, for example, I have maybe a function. No, I don't really kind of go so advanced there, but basically I could just kind of create more insights here. Like maybe for example, let me just have available, false, not present, true. Let me just kind of false, and then also maybe I could say original, class, true. So if I kind of print type of all of this, I'm just kind of making some of this so repetitive. Print not present. And I kind of print type of original class. All of this is going to give you what? A bullet. Okay, I say available is not different. Okay, I didn't spell this correctly. So all of this is going to give you class of Boolean. Now, I am intentionally kind of repeating and making sure that I stress on all of this because we're going to be using these things severally on the course of this particular lecture series. Okay. So all right, so this is actually really very, very important for us in this particular conversation that we're going to be having. All right, so I think that is going to be that for now. Basically, we've covered the data types. We've talked about booleans. We've talked about strings, floats, and integers. Are there other data types? Surely, sure. But for now, I think these are actually some of the basic ones, most important, foundational ones that we are going to be using in particularly whenever you're programming in Python as a data scientist or a machine learning engineer, whatever thing you want to be. But really very, very important for you to understand out there. So you could just see some of these here. We have the true, false, we have name, we have message, hello, we have price, we have age, and just for you to have understanding of what we are doing. So right now we are looking at numbers and strings in action, right? And so we're basically working with numbers. And I've already really showed you this, right? I've kind of showed you several of all of these flutes. But some arithmetic operations is what I'm going to be showing, how to perform some concatenation, which is what I'm going to be really talking about right now, just some arithmetic operations, okay? But I just really just want to jump so much into that. So what I'm trying to say now is, let's just call this, maybe I want to call it string data type manipulation. Let me just call it data type. Now, this is something very important and very foundational. Now, let's say, for example, now look at all of these data types that I have here now, and I just want to use, uh, let me just use a real-time, real-time example now. So let's say we have patient X is maybe some Mustafa, okay, Mustafa, and then we see maybe patient Y. Just gonna spell out correctly. Is maybe Chine. And then we also have age of X is maybe 17 or maybe 18 rather. Age of Y is going to be 25. And then basically what we're going to do right now is I just want to show us how we can manipulate some of the string, perform some kind of string concatenation, something we'll call, maybe we're going to do some string concatenation. Let's just call it concatenation and some manipulations, right? And then maybe let's kind of add another variable. Let's say true, let's say health checkup, because I'm using the snake case. Health checkup is true. Remember, we say true. Now, basically, what I could do right here is I can say, what I can do right now is, okay, since I can have a checkup true, I could do something like maybe patient X, or rather I could say print patient X plus, maybe. And then I'm just kind of adding a space here, right? I think this is, I could just kind of create a space here. Let me just create that space here. Okay, so it's better we understand how this works. And then, okay, maybe we can have if this actually works. Let's actually see if this is going to work. Plus maybe patient Y. All right, so we kind of created double spaces here. And now, what I want us to understand is there's something I want you to understand now. We could actually have something like maybe on a sentence now, say patient. Let's just remove the print statement here. Just keep it here. I think there is a PR is not defined. Where do you have PR? Okay, so there's a mistake here. Now, you kind of, I could just kind of trim out this space, right? And let's see, invalid syntax. Let me show you something now. Patient X, and then we'll have patient Y, okay? And okay, that's top. And then we could do something on, okay, we have this, we could have this, right? Mustafa and Chinene. If we want to create spaces, we could use the normal, this to create spaces, right? So that works. Okay, let's just take the plus sign away because this is string, okay? Because this is a string. Now let's say we could do something like age of X plus age of Y, right? And let me just comment this out. Just wrap it in the print form, and then probably I'm going to just put something here. This kind of a text. The sum of the two patient ages is, all right, so that's going to work. I could do the product, and I could just I think we are cool with that, right? And then of course, it's definitely going to give me that because this is 18 and 25, so it's going to add it together, right? So remember we did explain this as what? Variable, right? That variable is holding this particular integer data types, right? So variable is holding an integer data type. So same thing also happens here. Now you see that it works. Now you see when I try to concatenate this both, now watch what is going to happen. If I try to add this, let's see what happens as well. And okay, you see, it kind of joins the string, right? It joins these both strings together. So this is what we call string concatenation. We call this what? String concatenation. So ordinarily here, you could just call this integer operations, right? Which is part of our data types. It's part of our data type manipulation. Now I'm looking at this from the lens of data type what? Manipulation, how to kind of manipulation, right? So we could add two integers because that applies. Of course, it's going to happen. But then how about we kind of do that for strings, Mustafa and Chinene, of course, it joins. So it does join them, right? And if we wanted to kind of create a space, we could just create a space and use this. Maybe this time around, we now need to have some sort of a comma. And of course, that's going to work this time around. Now, but there's something we call the format string. That's the format. That's how we can format our string. And this is really, really very key, particularly if you're somebody here that is kind of you're getting new to Python, because we could also say, okay, we want to join health checkup with this. But sometimes there are sometimes where we want to combine two strings that are two data types that are not that's two different data types. Let's say, for example, now I do something like health checkup plus age. Yes, let's see what happens. Okay, so it kind of ignores this because of what that's true. So it does ignore that. And maybe if we kind of do it assumes both of them actually maybe it's kind of strange because if I let me just check, let's check print type of this. Let's see the operation type of this operation here. Okay, it kind of assumes that to be an int. And if we do so, before I introduce you to the format specifier, let's say we do something like okay, like let's take Chinenye and add it with age. Let's do something like Chinenye. So what's the data type there? That's patient Y plus HY. Let's do that. So we say print patient Y plus H HY. Now let's see what's going to happen. Now, it said can only concatenate string and not an int to string. Now remember, if I change this here to patient, I'm just going to change it to patient X. Now you see it works. Now the reason why it works is because Chinenye and Mustafa are strings, right? They are the string types. That's patient Y and patient X are string types. So it can actually concatenate. If I want to just create some space, I could just decide to use maybe some kind of something like this, just to create some space. I don't know. Of course, this is definitely going to create one space there. So this is what we call string concatenation, right? String concatenation. But when we substitute this now with an integer, right? Or some stuff. Now, of course, it handles this as an integer. The reason why it handled this now is because of this particular space that we've actually given here. But if you kind of remove this and do some direct addition, it's not going to work. Well, because the reason why I'm going to tell you handles that is that if we try to check the type of that operation, let's check the type of operation that happened there. I'm just going to check. Okay, so it takes only one argument and not this. So that means maybe I could store, if I store that, let's store it as a variable and then now check it, okay? So what we're doing now is I'm going to store that operation as a variable. I'm going to say our check, I'm just going to our check is going to be equals to this. And then let's kind of check our check. And it actually returns a tuple. Cool. So so that's that. So that is definitely what that's going to be. So that kind of handles that actually to a tuple, which we are definitely going to come to. But I just wanted to understand that for string concatenation, we can actually combine two strings. We could join two strings, patient X plus patient Y plus patient Y. That's going to work. But each time when we now bring in another type of data type, maybe like let's say health check, that's not going to work because we can't concatenate string with Boolean. Now, but I'm going to show us how we can use the format specifier. That's something we call the format specifier. Format specifier to perform some of these operations. So you're going to be using it several times, the F string. And let's say, for example, we could do something like print. So I'm just going to use the F string directly. So I can now use what we call curly braces. Now, this is what we mean by curly braces. If you look at your keyboard, you're going to see something like this, right? So this is what we call the what? Curly braces, right? So we have what we call this. So this is the what? The block. That's the block list or whatever thing you want to call it, right? So this is the you can call it the block bracket or whatever thing, right? So we have what we call this. So most times we use this for tuples, and this is just your brackets. So you can call this your brackets. So this is the block and this is the curly braces. So we're going to be using this particular one for inside of our format specifier to concatenate different type of that's several data types together. Right? So we won't be having that kind of error again. So remember, this is curly braces. We use it several times. We can use it on the course of this video. We can use it for dictionaries, some sort of dictionaries, for sets and stuff like that. For this, we use this for lists. Most times inside of an array, you can have it inside of an array. There's a numpy array. A numpy array usually contains a list, of course. And we use this one is used widely for tuples, right? That's tuples. So what do I mean by tuples? Tuples are like, we'll get to that when we get there. So why am I actually explaining this thing slowly is that if we now see, if we go up here and look at our data types that we have here, let's kind of practice using the format specifier. So we could do something like, we could say print, now F, we use the format specifier, F, this, we put a double bracket, and then we're going to say, the name of the first patient is, now you bring in our curly braces, and now passing the variable name, patient X, and the second patient is, now bringing that again, passing the second one, so patient Y, right? And their age, and the age of the first patient is, now bringing that again, passing that again, age X, and their height, and the age of the first patient is, and the second patient is, we'll do that again, age, of course, that's going to take in Y, and I'm going to run that, and then you see at this point, it kind of replaces that. Now that helps, that makes it quite easier for us to concatenate string. Now, unlike maybe if we remove this now and put some kind of plus and then add the number, rather here, somewhere here. Let's say we remove this now and add the number. You see that to tell us that you can concatenate strings with maybe with an integer, but then it has to be an int for int, string for string, boolean for boolean, and then as the case may be. Just so you have an understanding of what we are talking about, all right? So this is actually really very important foundational insight because I'm going to be doing this severally in this video. Particularly when we're going to be creating some sort of maybe tiny game or something that is quite important. But overall, right, really very important for anybody who is actually getting started programming Python. So okay, I think I actually need to spell this quite well. Okay, yeah, just to spell that correctly. So I think that is actually definitely going to be that for in terms of some data manipulation. So there are actually a lot of other things that we could do. If you look at our some like our slide, which I did promise, you could see here we have apple as 3, we have orange as 7, and then we could perform some mathematical operations. Of course, floats and integers definitely are going to work because they are some sort of numbers. And you remember what I did here, right? So Ada and Lovelace first and second, we kind of separate them with some space, and then we have our last. Then for the grid here, we could have hello grid plus 3, of course, my work, and then we could multiply our strings. Let me just show you what that means. I'm just gonna show you what I'm talking about. And for example, here we could see name, main, could call this main name is going to be maybe David. I could do something like main name times 3. Okay. And that's going to give me David, 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 David. All right. So that also works. Just some kind of data types manipulation. Okay. Now, let me just kind of go slightly advanced. So I could do something like for X in, for letter in, main name. So this is just kind of using a for loop. Don't worry, I'm going to explain all of this. So I could just print letter, and then I'm going to say the end is equals to dash. Let me just take out this. Now, what do you think this is going to return? Oh, sorry. All right, so I'm going to pass dash inside of this. Now, what do you think this? Okay, of course, I already did return that. So you see that here, I could also perform a lot of things inside of this string. I could loop around it. I could, you know, perform some multiplication, a lot really can happen. If I cannot remove this now, I think it's going to be horizontal or vertical rather. And actually, there's actually that. I could just have something inside of this particular loop here. Don't worry, don't worry. I'm just kind of scratching advanced a bit. And maybe I could just change this to this. And then, of course, that also happens. And that's it. So, so that's actually some data manipulations that you can actually do with strings. So I just hope this is really very understandable and it's well understood. That's actually the right way to say that. But really, 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 there are several ways you can define data types. You can assign your variables, loop around it, perform some operations, just for you to have really very much detailed insight and context on what I'm talking about, right? So that's just basically it. So I think that's definitely going to be that. I think I'm just going to clean this up so that it doesn't really confuse us. So now remember we are going line by line, and we talked about the fact that we could use plus to concatenate, and I now showed you how we can use a format specifier to concatenate. We're going to be doing lots of those examples, right? So these are actually the same thing for Booleans. I don't really want to go so much into conditional operations, but there are several ways we can actually declare Boolean variables. Now, let me show you something again. When we're talking about Booleans, right? Initially I was saying something like maybe is present, so is present, or is past, or is absent. Is he absent? And then you say true. Now, ordinarily, you could come to your Python console and do something like print 3, 4 is greater than 5. Now, what do you think it's going to return? It's going to return a Boolean to tell you that it is false because 4 is not greater than 6, right? I was saying 5, but still false. 4 is not greater than 5 or 6 or whatever number you want to assign that to be, okay? That's also the same way to print if is what if is absent. Okay, but I don't want us to kind of rush into conditional operations right now. But I just want it to really be very easy to understand and have very deep grasp on it. There are several ways you can because of course we're going to be working on machine learning. We're going to be doing a lot of machine learning and model training. But you really need to be so familiar programming in Python because that's the language for machine learning. But there might be time where you can set a variable at true and then you give a condition why it should run, or maybe you could set a variable at false and then you can tell us probably what's actually going to really make it to maybe change to true, and just kind of depending on the context, depending on the context where which you're setting that variable or whatever thing that you're doing. All right, so that's it. So I think that is definitely going to be that makes some sense. this is not equal to. I'm going to talk about this, not now, but just so you have an idea of what some comparison operators could look like on the course of what we're going to be doing, programming with, Python or whatever. So now I'm also going to be going to type checking. I've literally talked about this. You have use type to inspect any sort of value. And I did mention that. That was some first thing we did mention. You can have some hello, that's a string. And you could check its type function to check. And then also you could have you can actually cast values using int. Maybe you could cast values, of course, using int to as floats and all of that, which I'm going to show you, and type conversion. But just to show you that a lot of things are really possible. You can have an integer, change it to a string. You can have a string and then change it to what? An integer. Now, let me let you know that as a machine learning engineer, there are several times whereby you might receive a data set, right, online, and inside of that data set, it happens to be that uh, some participants might have maybe inserted a maybe that's inside of the data set, right? Maybe let's say for example now in a column now where you're expected to have some kind of numbers, and then somebody now goes inside of that place and go and fill in a string. Let's say for example you have a data set here, and then you say what's your name, and then the person enters, of course, David, and then you say what is your height, and then the person enters something like maybe 45. Now, what happens there is that if you cannot print, now watch, if you print type of, if you cannot print type, if we check, because we're checking the type, if we check the type of height and inside of here, now it's going to return a string. But now we expect this to be a float, right? So this is what we could do. We could say new height, could say is equals to int of height. Now we've converted this to a string, to an integer. So we're going to print type. Now let's check now what is now the type of new height. So that's going to be an int. So we've now converted it to an int. Ordinarily, I could just float this with an int. All right. That's still going to work. It's still going to work here. All right, so I've now changed this thing, everything inside of this place to an int. Now, but what happens if that is not a number? Let's say, for example, we have something like, okay, let me just I don't want to delete this thing because I'm going to leave some markdown inside of this. Now, let's say we have something like maybe blood pressure, right? And then maybe instead of blood pressure, the person says something like high. Now, and we expect this to be maybe, let's say, print type of int of blood pressure. Now, it's going to be value error. Now, the reason is because this is the characters. These are what? String characters. But if this was something like maybe 67, it will work, right? It's going to work because inside of here now, I'm nesting my functions here now, because inside of here now is that I kind of, I've converted it to, some sort of, so int, and then outside of it, I'm checking the type. So it works really well. So don't be confused. I'm going to be doing it severally. But essentially, what you just need to understand here now is that if this is a word like, let's say, for example, low temperature, let's say low blood pressure, low, or let's use the word low, is going to throw an error because it is an invalid literal that cannot be converted to a string. So an int rather, okay? If I use that, that's the best word. So I'm just going to change this to 45, and then of course that's definitely going to work. So this is what we call type conversions in Python. Please, these are actually very important basics that you must actually need to understand. So we've got conversions, type conversions. Let me just call it data types conversion. So we looked at data types, then we looked at uh, data type manipulation, and now we're looking at what? Data type what? Conversions. So remember, we started from looking at data types, we look at data types manipulation, how you can actually manipulate, and where we talk about concatenation and a lot of stuff. And of course, even the conversion, right? Or that is data type conversion, it's still kind of I'm just still going to say it's still part of manipulation, just depending on the context we're actually seeing it, right? But essentially, this is just what it talks about, and not really much of a big deal anyway. All right. So you have that's just what it is. Okay. So yeah. Now the question that might arrive here now: how about floats? What if we're working with floats? Okay, now I think it's better we check that out. So let's say, for example, we have a data set because we're going to be working with CSV along the line. And then maybe somebody passed in something like maybe blood, maybe a height, right? For example, and then maybe have something like 78.6. And then I kind of do something like, now, is this good? Are we going to get an invalid literal? That's what we want to check. So maybe I could just say print uh, int. Okay, let me just kind of make it this way. Now, height, let me just make it in a way that's going to be easy for you guys to understand. Height converted is going to be int of height. Remember, we're following the rules of naming conventions, how to store data, how to, assign, how to properly name variables. And then let me just kind of print height converted. Now, what happened? It knocks off all the decimals. Now, even if I have a 7777777, this is going to give us 78, right? Let me just change this to 100. 710, of course, gives us 710. So that also works really well. We can also convert from uh, we cannot we can also convert from uh, we can also convert from a string. We can also convert from an int to a float. Now let's say we have something like a number of children, and then we have something like maybe 18 children, and then we could just say new float, new children, let us call it new children, and that's, so say float of number of, I'm just going to say number of children, right? And then, so I'm just going to print new children. And then, now watch, it's now a float. What do you mean by a float? It now has a what? A decimal. All right? So that's just basically what it is. It now has what we call what? A decimal. So that is definitely going to be that. I think that's just that. Not really to waste so much time in terms of this part, but just to understand that we can have conversion from int to float, from float to int, from string to float, and all of it. Just depending on what we have, and then making sure we have the appropriate literal, right? That's a conversion literal. So this is like saying from string to float. And then this is going to be from float to string. All right. And then this is going to be from string to int. And so this is like from float to, no, this is from float to int. And also this is going to be from, uh, I'm just going to say this is int height, right? So that's from string to int, right? So that's going to be from string to int. All right, so I think that is definitely going to be that. And yeah. So the next thing we're going to do right now is, since we now have our strings, all right. Okay, so since we've already, since we've got done all the necessary conversions that we actually really need, we're going to now move on to the next part of this particular session right here, because remember I did talk about this, because this contains an invalid literal. That's not going to work. Is we're going to now look at how to take user inputs. All right. So this might actually require us to get into the next, that's the other type, that's the other file that we have. Because in that's the other file here, I'm talking about the main.py, because initially we were using the practice.py, but I think this is really going to work out very well here, right? You could still do it on your Jupyter, and that's on the interactive Python notebook. Of course, it's going to work really well. But basically, what I just want you to have in mind now is that um, you could actually take user inputs, right? So, all right, so let me show you something right now, okay? So here, let's just kind of look at this, just to have some visual understanding of what I'm going to be doing. So how we call the input method, right? So it kind of pauses the program and asks the user to give us something, like pass something in, right? And then the result is always a string. Then what I mean by result, that's usually the default. And then kind of say, okay, it gets us what's your name? Okay, how old are you? And then maybe then we can perform some concatenation. So I don't really want to waste my time so much on these slides. So I'm just kind of jump straight into this practical. So remember, I did create this. I could print welcome. Of course, this is going to run on the console. That's one side. Shift enter is going to run that. Alternatively, let me just kind of remove this. I could do print uh, about to practice user input. I'm also going to show you how it works on the interactive Python notebook, but there's a reason why I'm doing it here. Now, I'm going to press Ctrl Backtick to open my terminal. That's the integrated terminal, and I'm going to run main.py, and then it's going to return this. And just to be sure, okay, so that's saved. Now, what are we saying now? So for example, now I could say name. What's your name? Uh, name is going to be input. So how about we call the input function? So it's going to be enter your name. So when you say enter your name, now watch what's going to happen here. We can take this out. So you click on this button here, you run the file. Now you say enter your name. What's your name? David. And I run that, that's it. Now, so let's say, for example, now, and I'll say print, because I want it to print something now, because I just entered the name. So let it print. Now, watch your, remember, this is a string. Your name is, now, I'm going to just put full stop here, and then comma, plus, then I'm going to say plus what? Then I'm going to say plus name, right? Okay, so let's see what happens. So if I kind of run that, So to ask me to enter your name, I'm going to say David. Now it crashes because of what? Bad operand type. So what I'm going to do now is I'll take out this and let me just kind of close this up. So enter your name, David. Your name is plus David. Now you see this is what we call what? String concatenation, right? So I've kind of now concatenated it here, right? Because I could try to remove this and I run this again. And okay, so what's the issue? Let me just delete this again and run that again. Okay, enter your name, Samuel. Let me just enter Samuel. So your name is Samuel, right? So this is just string concatenation, right? So basically, what are we trying to say here now is that whichever by default your input takes in returns a string. So now let's say, for example, now I want to do something like maybe I need something more on that. So maybe I say age is a question. Uh, input, watch. Then I say enter your age. Then I'll come down and I'll say print your name is plus name plus you are plus age plus years old. Now, watch what we're trying to achieve here now. What we're trying to achieve is this is our name. We enter our name, age. We're going to enter our age. So that means our age now is going to, we want to kind of concatenate this now, but maybe we might have an integer here, be it expected. So let's see what's going to happen right now. So let's kind of run this. Let me just clear up all of this. All right, so now, so if you now kind of look at this right here, right? I will now say, okay, so if I kind of run this here, and I say enter your name, my name is David, and then what? Okay, I think I would have added something here, just kind of a space. So let's start it again. Okay, enter your name. So my name is David. Enter your age, maybe I'm 26, and that's it. So you see, now the reason why this works is because of what? This is an integer, right? This is a string. It takes this age as a string. Now let me prove to you that now. So when we say something like print type of age, let's see what's going to happen. Let's be sure. Enter age, maybe 45. Now what did you say? String. I seen it. It printed it as a what? As a string. So I think I would have kept a space here. All right. So that is it. So age here is a what? A string. So now, but that's not how we want it to be. That's not how we want it to be, right? So what we're going to say is input int, or we can wrap it with an int. And of course, then let's run it. Watch what's going to happen now. Okay, let's just clear this up again. I will say David 56. It throws up an error. What does the error mean? You can only concatenate a string and not an int to a string. So what happens is that when that David runs, you see, enter, David runs, right? And then 56, that runs again. Now, when that comes to this line, it throws up an error because of what? You can't add an int here. But usually, whenever you're accepting user input, maybe you're working on an app, you're creating any sort of an app or stuff, basically, you just need to know that your age here, of course, is going to be an integer. And Yeah, it's an integer. Like you need to also make sure that whatever thing the person is passing is an integer. Of course, how do we actually handle this error in real time? That's where we can use what we call the try and accept, where we can use the try and accept, block, in a situation whereby the participant enters something that is not what we want. Maybe somebody goes inside there and enters something like a character, whereas they're supposed to enter a number, then we can easily handle that error without it crashing our program. So this is just what taking user inputs looks like. And but how can we actually handle this particular one in real time? That means we need to use what we call the format specifier. So using the format specifier means now we'll remove all this plus here and then wrap this inside of a curly braces. And then I'm just going to remove this. And I'm also going to remove this. And I'm also going to just, so that's it. So this time around now it's going to work. Okay, let's remove this try block. All right, so we're going to run that, enter your name. Okay, let's just kind of kill this terminal and enter your name, David 27. Are you seeing it? Your name is David. You are 27 years old. Class of int because of what we did here. So we could decide to also change this to a float. Of course, that's also going to work. Enter your name, David. What's the issue? Could not convert string to float. So because of what? We can't, we enter the float, we enter the string. All right, so I think that is that. So let me show you what I actually meant here. So let's say David, and then here we enter 56. Of course, it's going to work. Now, if you try to enter anything that is not a number, remember we talked about numbers, int and float, it's going to throw up an error, right? So you see that it converted this thing now to a float, right? So that's actually basically how that works. We could change this to string. Of course, that's still going to work. Enter your name, David, 45. You are 45, that works fine, of course, but the class is string. So I think that is definitely going to be that for now. Although we're still going to do some kind of more examples because repetition is really going to make it sync. But just kind of understand that anytime you actually have your input, the input function, it always returns a string unless you maybe categorically state it here that okay, this is going to be maybe an int, or maybe it's going to be a float, or whatever type of data that you want to be. So don't worry, we're gonna build some sort of games and all of that. Then that is where a lot of things are definitely going to make some sense. Okay, and then we can also maybe perform some kind of operation. Maybe like here. Let me just show you what I mean by that. And then maybe like I'm trying to predict my birthday, for example. So age is int of this. I'm gonna say birthday, new age is going to be what? It's going to be age plus 1, and then you are now, I'm just going to put this, I'm just going to kind of say new age, years old, because, sorry, let me use this wrong keyword. So I'm just going to put my terminal, main.py, sorry, main.py, and then use this key, and then run that. Samuel, 26. Your name is Samuel. You are now 27 years old, and all of that. So that's just basically how it works. And also, you could decide to also add it somewhere inside there if you want to kind of shorten your syntax, but I think those actually might really be advanced for now. But just to give you something that makes some sense and that you can actually do. So yeah. So we are just going to perform some mini exercise right now. Maybe a greeting program. Then we're going to do a greeting program. Ask for somebody's username. City print it, and then do some kind of age calculator, type detective. Create one variable each, float, and print their types. I think basically some of this are what we've done. No need of repeating all of this again, but just to do an age calculator, I think this is what it is anyway. This is our age calculator. Yeah, so let's do something like a BMI calculator. So what is a BM? What is body mass index? So that is usually your age. No, it's usually your weight over height squared, right? Okay, and that is what we're going to do now. So first of all, we're going to ask the user to give us their name. Then we'll ask them to tell us what their where they live, just to make it more interactive. Then we'll ask the user to give us their height, and then we'll also ask the user to give us their weight, and then we're going to now print that's the body mass index of that particular user. That's what we're going to be doing right now, okay? Just to make sure that we now understand how that basically is just going to give us much more deeper understanding of how to assign variables, how to what data types it tells, how the user takes an input, and essentially if there's any other thing that requires us to have very full grasp of that actually sets the foundation for that. So the first thing I'm going to do right now is as usual, I'm going to say we're going to print welcome to this BMI calculator application. Okay. All right, so let's kind of comment out this. Remember, we talked about comments. The reason why we use comments is we don't want, we don't want it to, we don't want the computer to display that. So those are actually one of the reasons. And sometimes we use it in debugging, right? We can use comments in debugging. So what do we mean by debugging is maybe there are some bugs we're trying to check. We could just comment out some lines instead of deleting it, and then just use it to trace where the maybe the problem or the fault might be coming from and all of that. So I think that's that. So here we'll start by printing welcome to BMI calculator. That's the first thing that's going to display. All right, and then so we're going to say username. Username, what's your name? Username, please. I will say input. Somebody could actually say something like this: string input, maybe something like please enter your name. Right? That's still fine. Please enter your name. And then somebody's going to say age. I mean, let's call it user. Age is going to be int. So the person must enter an integer. It's a must. If you enter a float, it's going to crash our program. So say input, you're going to pass the input function, and then you're going to say please enter your age as at your last birthday, right? So that actually gives us a float because somebody can be 24.5 years old. That means 24 years and 5 months. When you say, what was your age as of your last birthday? My last birthday, okay, that was my age. Probably 27, whatever, 10, so I was 28 or whatever. Okay. And I think that's quite for user age. And then the next thing is going to be, what's the next thing in there? Of course, we can now say, okay, enter your BMI user. BMI, no, not BMI, user height, or no, user location. Let's make it interactive. It's a string, input, Please enter where you reside. Okay, and I'm going to say user, maybe some user height. No, it's going to be int. I'll put as a float. I say impute. Now remember, we're using the impute function. So we're saying, please enter your current height in mm or kg. Oh, no. That's going to be in inches or in cm, whichever way we want to do that. I'm just trying to remember what that's going to be. 1.7. No, that's not going to, that should be something like actually around inch. Or maybe any kind of scale that you want to use out there, it's really going to make some sense, for you. And let me just kind of leave that blank. So we say the user, wait, float, so impute, enter your weight. Kg. And so I think that's just that. The next I'm going to do is I'm going to print an F string. And now we want to now add the birthday. Now, new age. Okay, no, not for that. I want to say BMI. Now, what's going to be the BMI is going to now be. Now, remember, all of these things here are variables. Each time a user enters anything here, it is stored inside of this as a container. If the user enters this now, it is stored inside of this as a container. I just hope that makes some sense. So it means that for us to get our BMI, it means that the program is going to run from top to bottom. So it means that when it's done running here, it's interpreted. So it's going to run from top to bottom, right? And it's kind of using a procedural approach, which is move down from up to bottom, not from bottom to up. So that means when the user enters all of this now, we now have variables now. We can use to perform arithmetic function. So what it means now is that what is going to be our BMI? We said that it's the height all over that's the weight over the height squared. So what this means that it's going to be the user weight divided. I'm going to come to that. I'm going to come to operations divided by the user height all squared, right? And then that's going to give us print well done, let's just kind of use a format specifier, right? So as it can actually display the name, we'll say well done. Now put the name with curly braces. Say your name and well done the name, right? Colon, that's an exclamation. Well done name. And I see you are, then here we have user age and from uh, user location. Okay. Now, if we want to continue on a new line, we use this backslash, right? And then your, no, I don't want that to create some space. Your age, your BMI is you pass user. I think we'll just call this user BMI. So it's kind of that's meter squared, right? I think that's meter squared. And then that's kilogram per meter squared. And probably you could say kg per m squared. If I thought that's that, and that's it. So we're going to now run this. Just to have it on our terminal. So we use control backtick and open main.py. All right, okay, it kind of welcome that it didn't pop up our user input. So what we're going to do now is we'll run it here. So it welcomes us to the BM calculator application. What's your name? Your name is Samuel. What's your age? Just the last birthday? 21. Enter where you reside. I reside in Abuja. Please enter your current height. Okay, probably 1.7. What's your current weight? It is 89. You see, it says, welcome, someone. I see you're 21 from Abuja. Your BMI is this. Now, I think I might have not actually wanted that to do that, but if I run this, I don't know why that keeps collapsing my application. Just use the run button here, and then say David, and then what's your age? Of 23, where do you reside? Ocean, and then what's your current 1.6, maybe 67, and that's it. Now, you see, this is actually how we've now successfully created a BMI application checker, right? So very easy and easy. Now, how about if we want to round this? We could round this to 2 decimal places, possible, and that's where we can do here. So here we can actually just wrap it with round, and then so we could just round it to 2, and let's just see what happens. Let's see what happens. I just always like to start this again. And so David, 23, 1 point, okay. Abuja, 1.5, maybe 45. And that's it. So you see, it kind of rounds it down. So your BMI is 20.0. Are you seeing it? So let me just kind of, so you could do as much. If I remove this round function here, I know that might actually seem slightly advanced at this stage. You see that it's not going to round it. We're still going to have the normal Daniel 45, Cross River 1.9, 78, and that's it. So you see, it's not rounded again. So this is just basically how to just create that particular game. And other than that, I think that is everything that we need to know, particularly in terms of creating, accepting user input. Now, there are other more advanced things that we're definitely going to do along the line. But at this particular level, this is just basically what you just need to actually have and understand. So here, just some key takeaways for this particular module of our conversation here. We've now known how to store variables. You know, we now know the naming conventions. We now know the containers that variables are actually used in storing. You know, I just used to storing information in memory. And then I told you how to use the snake case, as a snake case, and also the camel case. right? So if you're just starting this video, of course, I did mention that, severally. When I actually talk about the snake case here, basically what I'm saying is maybe you have something like name underscore class, something like that, right? This is what we call what? Snake case. But when you say something like uh, healthcare, let's say, for example, care, healthcare assessment check. Now watch, you see that each beginning of the word, instead of using this snake case, we're using uppercase to prove that, and that's what we call what? Camel case, okay? All right, so that is just basically what that means. Okay, so we talked about the three core data types, the int, the string, the Boolean types, and also the how Python actually detects them automatically. And then we talked about how to check for them using the type, function, and then also how to convert, and then also how an input always returns a string, and then how we can actually wrap it with an int or float just to give us what we want. So that's actually going to be that for that. We're going to be moving into the very next session of this particular video. So kind of welcome very much. In this video, we are going to be talking about operators and decision making in Python. Now, the first thing I'm going to do right now before I actually start from this part is just to show you some stuffs that I might have wanted to show you. I'm going to call this operations.py, right? And also just more of, more of these. I've already started using it. Some basic arithmetic operators, that we have in Python. All right. So we have what we call, that's we're looking at some of the basic arithmetic operators. We have what we call the addition. We have what we call the subtraction. And we have what we call the what? Division. Right? We have the division. We have also have what we call the what? Modulus operators. And we have what we call the integer floor division. And just kind of basically some stuff that are actually very, very pertinent, right? That we could actually do in Python. All right, so now let's kind of get into our practice folder back where we'll be looking at these arithmetic operators, right? So you can have a grasp of it. Remember what actually brought us out here is that we wanted to show you how to take user input, and it's quite more easier if I'm displaying it on the terminal than when I display it here. It might really be very ugly because it's kind of displays up, but really, really, really important if we do that in our terminal. So let's get back here, arithmetic operations. So what are some of the arithmetic operators? So we could do something like x is equals to 78, y is equals to 67, and excuse me. Now, if we do something like x plus y, now, if we kind of do something like x plus y, that illustrates some sort of an addition, right? Addition, that's an addition operator. All right. So that is just basically what that is. And then if I kind of do something like maybe x minus y, that's going to give some subtraction. And then if I do something like maybe if I do x divided by y, that's going to give you some sort of division. And if I do something like x times Now, how is the times use this, right? Star times y, that's going to give you so that's going to give you some sort of the multiplication, all right? And then now watch, if I do x, this, y, now what do you think this is going to give you? Now let me show you something. Can I print this? Now this is going to give the integer division. So I'm going to run that and it gives you 1. Because when you divide this by this, it kind of flows it down, gives you that's the integer floor division. Now, but if you cannot remove one this here, it's going to give you 1 point. So this is just, let me just kind of reduce this number to maybe something like 23 or something, right? So integer floor division, what it does is it gives you the value. Let me just kind of use this. Let me just bring that. So this is going to be the integer floor division. All right. So what the integer floor division is, that it's going to return only an integer. Now think about it this way now. Remember, there was any time I was doing typecasting, right? Something like, for example, now I have data is equals to 67.5 or 67 points. Now watch, if I do something like print int of data, it gives me 67, right? Let me just kind of put this at something like maybe 8. It still gives me 67, right? Now, but what happens if I do something like maybe, let's say, for example, we print out this is 3.39. I'm just going to reduce this slightly. And I watch, and I'll kind of do an integer division. Now, it gives us the same thing, right? So what it does, the integer floor division, is that it just gives us the first integer there, right? 3. Every other thing, maybe it's 3.9 or whatever thing, it doesn't care about it, right? So that's what we call integer floor division, going down, right? It goes what? Down. So yeah, very, very important to note. So anytime I want to perform an integer floor division, we use what? The double division stuff. Now we have x times y. So we try to get what? The value raised to the power x value raised to the power of y, right? So regardless, so the more we continue to add this, right? It just continues to expand. All right. So it's actually really very important for us to know, and I could still continue to reduce this, maybe reduce this to something like that, maybe 9, and it gives me 8. And if I take out this, let's add plus. Okay, so these are mathematical operators. So it adds this, gives us 87, and then we can just print x plus x minus y. It gives us that, and then I'll print x divided by y. Okay, we can print um we can print x times y. Now it can also take another value. Of course, I'm sure you're very much aware of that. And also, we call the modulus. I think I'm not going to forget that. Modulus. Now that's what. Let me just, how will I put it now? Okay, say x modulus y. Let's see what that's going to be. So this is what That's the remainder. Now, unlike this one, now we're getting the floor division right here, but here we are getting the what? The remainder. No, we kind of see everything, but so so I'm going to just add a comment here so that a description so that it will be easy to get grasp on. So floor division, uh, that's is, and then we're going to say something like maybe x backward slash y. They're going to print modulus of x and y, just an x modulus y. Now it is 6. Now, why is it 6? Now, watch. When x divided by y, it gave us 86.666. So 6 is the remainder. That is what our modulus is. Now, you might be wondering why these things are actually imperative, but let me just tell you something. Some of these arithmetic operations are quite very important in Python programming because sometimes when we might be training a neural network in epochs, something we call epochs or batches, we could just say, okay, we just want you to anytime anytime the batch size modulus 10, right? So that means if the batch size is divisible by 10 at all points whereby the batch or the epochs, that's epochs right now, that's the training cycle is divisible by 10, just give us that result. We don't want to get result for when you train it at 1, 2 to 1,000. Just give it to us at anytime it is the epochs is modulus 100. So what does modulus mean now? Is that if we say epochs modulus 100 is equal to 0, right? So we are trying to say anytime the remainder is 0, that means it's clearly divisible by 10. Of course, it should give it to us. So look at what I'm saying now. Let me just show you what I'm saying now. So you and I know that that x, that if maybe j is equals to 67, sorry, let me just say is equals to 10, you know that modulus j modulus uh, that's j modulus, let's say for example 10 is equals to 0, right? This should be true now. J modulus 10, check, let's say check this, let's just use a variable to check this. Now this is going to give us a boolean. Let's say print check this 0, because j modulus this is going to give us what? 0. And yeah, if I wanted to give me a boolean of true, what I could do is okay, I could now bring in a conditional if j modulus 10. But don't worry, I don't want to confuse you guys, right? So basically what I'm saying here is modulus is just the remainder. So what this means now is that j is divisible by 10. If you put this as 100, it's still going to give you 0. If you put this thing as 1,000, whatever thing, it's still going to give you 0. If you put this thing at, let's say I now add 1 here, it's no longer going to give you 0, it's going to give you 1. Because ordinarily, when you divide this, when you do j divided by this, it's going to give you 10, this point 1. So it means that the modulus now is 1. That's the remainder. So what modulus means is the remainder, right? Modulus means the what? The remainder. It's just kind of talking about what? The remainder. So this is something we're going to be using severally in our what? In most of what we're going to be doing in Python programming. All right. So I think that's just so we just want to kind of make sure we are so familiar with so many terminologies in Python, like how things are working. But there are kind of some basic things that we need to understand today, so that throughout the rest of the week, when we're going to be going into some kind of foundation, when we start throwing up some Python symbols, it's not something that's going to be confusing, but it's just something that are really going to make some sense, right? So I think that's actually that. for that. So remember, I'm just going to reiterate here that some of the arithmetic operators, these arithmetic operators that we have in Python is that we have the addition operator, we have the subtraction operator, we have the division operator, we have the multiplication operator. We have, we could actually raise some values, right? You could just do x squared. Remember when I did when we developed the BMI game here? If you look at our BMI game here, you see that here we used this particular raised to power user height raised to power 2 just to give us what we wanted, and just basically that, right? So these are integer floor division. You might be asking me, but when are we going to use this? Of course, let's say, for example, you want to transfer some images into a neural network or maybe some machine learning algorithm kind of stuff. Maybe you have some tabular data and you must pass in an integer. You don't need something like 67.4. What you're going to do that time is either you wrap it with an integer here, or you're trying to divide, split a data set, and you don't want to have, let's say, for example, you have a data set, people that responded is 305 people, and you want to divide it into two. You don't want to have 300, you don't want to have something like maybe 125 or 175.5. Because 350 divided by 2 is going to give you 175. We could check that 350 divided by 2 is going to give you 175.0. But now let's say I now put int of, let me divide it by 3. Let's divide it by 3. By 3, it gives us this. But when I now wrap it with an int, so it gives me 116. So that means I don't want to pass in decimals inside of there, right? If I didn't want to wrap it with this, I could have just used the floor division. And then, of course, it's still going to give me 16. So I'm going to press Shift Enter to execute this at this cell. So this is actually what you need to know about the foundations of Python. Remember, today we are taking it gradually, just to make sure we arrest all the necessary terms. So far, what have I talked about now? Before we just look at our slide again, I've talked about some of the operators: addition, subtraction, division, multiplication. That's the power operators, right? Because this could actually contain 3, right? You could actually think of it as kind of cube root or stuff. And then also the integer floor division and the modulus operator. So that this one called the modulus, right? That's the modulus. If I could spell correctly again now. I'm trying to spell. Okay. Okay, so that's actually going to be that for now. Let's just kind of get out of that particular position and then return back. And also have what we call comparison operators. I'm going to be coming into that. And this is actually what we're going to be covering here. Now, remember, when I started this lecture a couple of hours ago, I did actually mention that what we want to do is we perform some practice, we show our slides so that it gives us some visual comprehension of what we are doing, right? So essentially, the idea here in this module is that we want to get some, some arithmetic, comparison operators, which we've talked about. We're going to look at this now in a jiffy. And then we'll look at some assignment operators, which we already started from the ab initio of this particular lecture. And then logical operators, membership operators, and then we'll look at some identity operators, and then also if-else, some nested logic, which is what we're going to be doing, right? So these are conditionals. I do call them conditionals operations, right? So I've actually gone through this, right? Just show you floor division, modulus, exponentialization, whatever thing you want to call that. And of course, all of these resources are definitely going to be disposed on my Git repository, where you can always download it and, kind of make useful use of them. All right? Now, we're going to now look at these parts, right? Comparison operators here. We have equals to sign if we're trying to make some kind of comparison. And then we have the not equal to, we have the greater than, we have the less than, we have the greater or equal and what will be less than or equals. All right. So we're going to jump into our code editor right now to make some sense out of that. And I think comparison operators, right? So that's a very good way to look at that. So I'm just going to comparison operators, okay? Now, basically, what I want you guys to do right now, to understand now, is that a number can be, let's say, for example, let's think about it this way. You are looking at patient data, right? And there are a lot of things that are inside of itself. Now, let's say we have weight, let's say new weight, right? So I don't want to overwrite what I've previously assigned, but that actually works because I could assign J to be this here, and I come here and I say J is now equals to 78, and then I print J, and then it's going to overwrite it, right? So this is what we call this particular attribute means that there's all continuous modification of what variables in what in Python programming. So I could go up here, change J and all of that. It works, right? But the reason why I'm going to be using some new terms is just to make it easy for us to understand. So I'm going to say something like maybe new weight, and then I'm going to maybe assign it to 89.5, and then I'm going to say something like new height, or maybe let's say old weight, and then I'm going to assign it to 19. No, until probably 67.9. Now, what I'm going to do now as comparison operators? And the first thing now is in programming, there are times whereby we have to compare two variables, all right? To compare two particular variables to check if they are equal or if there are some sort of equality inside of it. So here, if I cannot do equality checks, don't mind my spelling, quality checks, I could do something like new weight, if I didn't get that auto completion, so just to wanted to be sure that is equals to. Now, this is wrong, right? This is bad practice. Now, somebody can actually tell me why this cannot be this. Now, the reason is that if I do this, this might throw up an error, right? Okay, it doesn't because, but what happened here now? Look at what happened. What happened here now is that the new weight now got assigned to the variable of the old weight. It doesn't make any sense. So watch, if I kind of print new weight, now watch, it is now taking the variable of the old weight. So that's what happened here. But this is not what we want to do, right? What we are trying to do is that we want to check if this thing is equals to this. That's it. So when I say this is equals, use the double equal sign. Now, what happens here now is that Python now checks, okay, this guy is doing a comparison operator. He's trying to check if this particular weight also has the same number of quantity with what is inside of here. And if I kind of wrap this with the print function, so it's going to return a Boolean, which is true or false, if I'm correct. So it's going to return false. And the reason is that our old weight is 67 and new weight is what? 89. So that means they are not the same. Now, what happens if I kind of change this thing here to maybe 89.5? Now, it returns true because of what? Both of them are actually what? The same. So that's kind of a quality check. So we're going to be doing this severally, and we're just going to do a game. We're going to work on an exercise where we're going to check out student scores, do some comparison checks, and just kind of mess ourselves up with it. All right. So I could just maybe change this to a string. Let's kind of change this to something like maybe big. Let's see what happens. And that's false because they are what? The first thing that happens here is that Python kind of checks their data types. it checks their data types, and then you see that this is a string, this is a float. So that means it is not even the same. They are not the same. No need going forward, right? So this is a float. Remember, what is a float? A float is a decimal number. This is a float, and this is a what? String. And that's it. So you see that what? They are not the same, right? So that means this is float, this is string. Now, but what happens if I kind of change this to something like small? It's still false because they are not, they are both, it checks, okay, string, but they are not the same, but still not the same. But if I change this to big, true becomes true. Now, this is very case sensitive because if I change this to big, it's going to be false because this is different from this. Now, it's just like declaring a variable and I say age is equals to 78, and then I say age is equals to 89. Maybe 78, for example, right? And then I kind of say print age is equal to age. Watch. True. Okay, because they have the same values, right? Now watch. If I now say, okay, if I now change this to 71 and print age, and I print it, that's 78, right? So that's it. So this is different from this. I could also print, I could also print age. And then, of course, it's still going to give me 71. So it means that it is case sensitive, right? It is highly case what? Sensitive, all right? So that's actually that equality there. And we could do, maybe we could do height. Maybe, I think that's actually good. Definitely going with that. That really makes some sense. Let's kind of look at Booleans, right? So let's say, for example, is active, and then say true, and then we'll say not around, and then something like maybe false, and then we'll say something like it's active is equal to not around. I just kind of looked for a random variable, right? Not around, and that is false because they are not what? Equal, right? They have different data types. So this actually comparison operators. I could just not waste so much time there, but I just wanted to do some stuff that are really very important. Right? X, we could do print x is equals to y. Sometime in this program, we did display that. Now, we also could have not equal to. That's true because x is not equals to y, and it is true. All right? Let me comment this out. Comment it out. And then run it again. X is not equals to y. Old weight is not equals to. Now, let's kind of comment this out again now. Okay, nothing works here. And then not equals to. That's true because this is not equals to this. This is true and this is false, so they are not equals, so that's true. So what are actually the comparison operators that we have? Just like I showed in the slide. So this means what? Equals to. Now, this is different from an assignment operator. This is an assignment operator. Only one equals is an assignment. That's what we use in assigning what? Variables. And we're going to say not equals, this is not equals to, and this is actually greater than or equals to. We're going to come to that. Greater than or equals to, less than or equals to, this less than equals to, and then we have Okay. All right, so let's kind of run a simple program now to cement that now. So let's say, for example, A is equals to 12, right? B is equals to 23. C is equals to 12. And D is equals to, yes. All right, so now the first thing we're going to do now is we're going to see A plus A, I'll say A plus B, that's Z is equals to B plus B. Just get the math. And I'm going to say print A is greater than or equals, no, A is not equals to, now when I say not equals to, I use the exclamation and equals to. Exclamation and what? Equals. And the normal equals. Now, equal to means equals to. That we're trying to equate here. We are trying to compare two values, right? Not assignment. It's not assignment, right? Let me just kind of put it there too. Equals means what? Assignment. Assignment operator. We are trying to assign a number. Assign something to a variable, right? So this one no follow, right? These are our what? Comparison operators. So this one equal sign means we're trying to assign, we're trying to, you understand? We're trying to label something to a variable. Let me use the word label something to a variable, right? So here is equals, we're trying to compare two values or data types or quantities. All right. All right. So if so just to kind of round that up here, we could say A is not equal to B and A is not equals to B and print. So basically what we're expecting booleans, and we can say Z is greater than D. Okay. We could print C is equal to A. We could print B. We could actually perform some arithmetic operation. B minus C is equal to um A. Let's see what happens if this works. And then we could print D is not equal to Z. All right, so we run that. Okay, what is the issue? Print Z is greater than D. Okay, good. Okay, so it's not supported. This instance is not supported between an int and a string. Okay, so we could just change this to maybe to B, and that's it. So you see what we have here, and it kind of shows up. A is not equals to B. A is 12 and B is 23. That is true. And then we can say Z is greater than B. How did we even get Z? First of all, we get Z by adding A to B. That's going to give you, let me just print Z. So let's get Z. So Z is 35, right? So add Z. We got Z. So Z is greater than B. Is that true? Yes, it is true. Now we say C is equal to A. Is that true? C is equals to A. That's true. Now we say B minus C. First of all, we take that math. So what's B minus C? 23 minus 12 is going to give you what? It's going to give you 11. So 11 is equals to 12. Is that true? No. That's false. We now say Z, D is not equal to Z. Ordinarily, D and Z is 35. This one is a string. So no need to even perform any kind of what operation. So that's automatically choose out to be what? True. So that's actually how we perform arithmetic operations. Not arithmetic now, that's kind of comparison operators rather, in Python. And yeah, that's it. So all right, so the same thing actually happens. You can actually use that for less than or equal to. And I'm just going to show you something, how because sometimes you might be seeing these stuffs here. And basically, once we're done with this, we can kind of go through a game, which I'm definitely going to develop. But these are actually some assignment operators that you need to understand. You need to store and update variables. Like you could have plus plus, minus, assign, multiply, divide, and all of that. And then we have what we call logical operators too, which is and or not. All right. All right. So let's kind of just go into that real quick and. That's assignment and logical operators, right? So remember assignment operators, we just talked about equals to and all of that. So, but there are some sort of advanced functions that we can do. Now, when I say A is equals to 56 here, remember this thing can be anything. It's because when I say A, you think I'm mathematical. It could be something like maybe height. Height is equals to 56, right? And then for example, and then I'll say something like height is equals to height plus 1. Print height. Now it gives me 57. Now, but there's a way to write this better. Instead of to say height is equals to height plus 1, what we could do now is we could say height plus equals to 1, right? And of course, it's still going to give us 7. Now, if I can't add 2, just to show you that that changed, let me just add 4. Right? So what this happens that is this is kind of a shorthand method, right? So we're going to be doing it so many times. In JavaScript, I could have wanted to show you something in JavaScript, but I don't want to deviate from Python and jump into another thing. But if it's in JavaScript here, you could do something like height plus plus to always add 1. But that's not the case in Python programming, right? Because here you have height, and then instead of you to kind of just have saying height plus again, or maybe could just do now, maybe let's say, for example, uh, patient risk is equals to maybe 34.5, and then we'll say, instead of saying patient risk is equals to, now because we're trying to assign, because so what we're doing is we are doing an assignment plus arithmetic operation. All right. So that's what this is definitely going to be. So let me call that assignment plus arithmetic shorthand operations, right? So basically here, instead of saying patient risk is equals to patient, assign it again, and I say patient risk plus maybe plus 10, for example, we'll now say, and then we'll now kind of print patient risk, right? Now, what we will now do right now is, instead of doing this now, we'll just clean this. I don't know why this is not highlighting. So we say patient risk plus equals to 10, plus equals to 10. So patient is plus 10, then we assign it back again. And that's going to give us 44.5. So now that's for addition. Now how about subtraction? So let's say I have maybe community 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 nets, that's mosquito net, is equals to 100. And I'm now going to say community, just to make sure I spelled that correctly. Community net minus equals to maybe 2, and kind of print, just to raise that up. So it's okay. I just want to make it more readable for everybody. And then I could now say community nets. And of course, it's going to subtract 2. And of course, from it. So that's actually the same thing. So I could have 10 instead of me saying community, because this is the same as saying community net is equals to community net minus 2. Okay, I could just comment out this. And of course, that's the same thing. Okay, so just for you to familiarize yourself with this, this is something we are going to be using severally in this particular conversation. All right, so guys, that's definitely going to be that. So we kind of look at the multiplication part and then also the division part of it. So let's say we have health, maybe for example, could have number of schools, and then is 100. Maybe for this time around, or maybe let's say for example, something like 200. Okay, and I'll say number. So number schools are divided equal to 20, and I want to print number. So when you divide 200 by 20, it kind of gives you 10. So the last one I'm going to do right now is I'm going to do for the multiplication, and then I'm also going to show you that. So we could say maybe for example lesion score could be for example 55.8, and I could say something like lesion multiplied equal to 2, and I'm going to print lesion score, and that's it. So this is just going to be the multiplication. And then, of course, I could just kind of raise this up slightly. And this is the division. And this is going to be the subtraction. And of course, this is going to be the shorthand addition. So actually, these are that here, for us to have very good grasp of particularly in programming Python. And I think that's that. Other than that, let's just I'll just jump straight to the next line of action. So now the next one that is logical operators, right? Probably we should have talked about that. And I'm just going to logical operators. So what do we mean by logical operators? So by logical operators now, we're looking at, let's say, for example, we have, we'll say A is equals to, let's say your maths score is 67, your physics score is equals to 19, and then now usually in Nigeria, most times before you're given admission into JAMB, there are some certain logic that is applied, and then your chemistry, is maybe 45, for example, and then maybe your English is going to be maybe, say, for example, 60, 61. Now, we're now going to say something, print, uh, now this is going to lead me to bringing in the if else logic, but I just want to, I don't want to really jump out some stuff, but I'm going to say maths, because I could say something like this. I say, if math score, if math score is greater than or equal to the physics score, and now watch, and so what are actually the logical operators here? We have the and, we have the not, we have the or, and English score is greater than, maybe, for example, is greater than 50. I'm going to say print, you have gotten admission, for example. So we can run that, and that doesn't satisfy it, right? Because math score is not greater than physics score. So we say else, don't worry, I'm going to explain that. Print, no admission for you. Don't worry, I just wanted to give you just some kind of advanced stuff. Now, if you look at this right here now, right? So you're going to find out that, we used we use the and operator, right? But let's kind of say this is less than, and then see, you have gotten admission, because you can't the and logical operator combines the conditions from these two expressions. So that's what we're going to call this. This is an expression. Okay. So you can make an expression in programming, and then you use an and or the not operator to do what? To combine it. All right? So that's actually what we do whenever we are programming in Python. So if you kind of use or and then have this as greater than back, how it was. Remember, initially when this was as at and, he said no admission for you. But if I use the or operator, that means I'm saying, okay, even if this other condition has it, okay, just say yes, go ahead. Just choose this or this. And then of course you have gotten admission because it still satisfies that. All right. So actually these are really very imperative for you in your learning trajectory for Python programming. All right. So really very, very important, and has uh, some kind of benefits for anybody who is getting started with this language. So I told you that I didn't really want to use this for now. So I could have just commented that out, but let me just show you something now. And what I could actually do now, because you can look at this here, you could see, you see that it brings in our if statement, right? Really very difficult to use your logical operator without your if statement. And you could say math score plus physics score. And now, I don't think this actually makes any sense, but unless we want to assign something, but we're going to use it to perform so many things. So I'm going to keep this here, and then let's talk about the if-else conditions. Now, in, prog in programming, there's something we call the conditional operators, right? So let me just talk about it right now. Conditional operators. So that actually just like a markdown. Now, in conditional operators here, right? No, we're not looking at comparison, no, right? So we're looking at conditional. Remember, we have arithmetic operators, we have comparison operators. Now we have logical operators, which is and or, and now we have the what conditional operators. Now the reason why I want to talk about the conditional operators now is because it kind of helps us to digest the logical operators because of how much we use you know if else statements in our in whatever thing that we are doing, right? So this actually like kind of the reason. So what actually our conditional operator, we have the if statement. What it does is that it kind of checks if a condition is true, then execute it. Now these are actually functions, right? And there's something I'm going to tell you in terms of indentation, right? So let's just kind of go into this particular part. Now I want to show you something here, guys, right? Okay, cool. Now remember here I talked about assignment operators, right? And I said we have comparison operators, right? Where we are looking at something like less than, we have not equals to, we have, sorry, that should be here. We have greater than, sorry, less than or equal to. We have greater than or equals to. We have the equals to. And yeah, if it's something like in JavaScript, you might have something like this, equals to, equals of, equals to. This exists, but it doesn't exist in Python. So depending if you're coming from JavaScript and probably something that's really very deep on front, and you definitely know what I'm talking about. Now we say we have logical operators, right? We are now talked about we have our or we have our and we have our not, right? So now we're going to talk about we're now looking at our what our conditional operators, right? So this is if or else or elif, which is what I'm going to be talking about right now. So we also have arithmetic operators where we have equals to, we have plus equals to, minus equals to, divided equals to, and multiplied equals to. Okay? So these are what we call what? Arithmetic operators, but mostly what we do use is this one to assign values. Now, what are we talking about right now is now because we are looking at we are more concerned with our conditionals, right? We are more concerned with our conditionals, which I'm going to just sketch out somewhere here. Now, if you cannot write an if statement, the first thing that happens is what? At the end of you writing an if statement, you must leave what we call what? A colon. I didn't say this is what you leave. I didn't say this, not this, but what? This. Anytime you write any function, right? When you make an expression in Python, you must leave a what? Colon. Let's say you do something like y, you must leave a colon. You do something like try, you must leave a colon. You do something like for, you do a for loop, you must leave a colon. And anytime you leave a colon, the general rule is that on the next line, you must start on the what? On an indentation. All right? All right, so let me kind of explain this more better now so that it sinks well. So here, we're looking at the rules, okay? So let's say, for example, number one, we declare a function, a function, any function, right? So this is if or else, you must end it with what? A colon. A colon. And then two, start with an indentation. That could be like for indentation or whatever stuff. Okay. So this is actually like best practices in Python. Three is now ensure it is properly wrapped. All right, so there's actually a reason why I am actually putting this down because it's one of the mistakes a lot of beginners do make sometimes, because you're working on, you're kind of doing something and you really, really don't know how to wrap it properly. And of course, uh, it kind of leads to lots of challenges and all of that. But essentially, what I want you to know is that, well, there are some kind of rules of thumb that you must abide by. All right. So let's say, for example, now, based on what I said here now, let's say if, for example, if name, let me say name is equals to David, if name is equals to, now I'm going to use the equality sign now, is equals to David. Now remember that I did not use the normal equals now because this is equality. Print this is your portal. Welcome. Okay, so I run it and that's true. Because what? Now, if this is not, if I change this here to Samuel, now what happens? Nothing prints because this is not true. So instead of us not to have anything printing, we have what we call the else statement. So usually in the else, we don't need to pass any expression here. Whenever you have the if statement, you can pass an expression here, but you must end it with a colon. And then the next line, which means that this is what I want you to execute based on this expression. It has to start on the what? On an indent. If you bring this thing out here, it doesn't make any sense again. Because of what? We don't know, okay, if this is this, and you're not saying print, this is another line of code. But what tells Python that you are still inside your command, you're still inside this line, is that you have what? An intention. Remember, this is not good practice for you to have name of David and then you put surname equals to maybe innocent. These are not the same. Reason, this is not a function. One, this is not a function. So this is not possible. All right, so it must start with another intention. But in a situation whereby this is a function, and it ends with a colon, it means that there are now other things we want that function to do, what we want the function to execute, because basically we've written the expression. So we're expecting that particular function to now execute that. So that's why we're going to now say, okay, so print, this is your portal, welcome, right? So basically here now, we're still inside of that indentation here. We don't need to get out because this is still a function. Else, could now say print, I am, else, if it's not it, it said, please look for what David is. That's it. So it's a look for what David. Now let's kind of look at something much more important, right? Let's say uh looking at our scores here, we'll now say uh if math score is greater than, now let's use, we're going to be combining several approaches now. It's greater than or equal to physics Okay. Now say print. Now it's not just print. We could also do another thing. We could say math score plus 10 is possible. We can still do this, right? And then say now if we want to have more than one expression and not just say okay else, let's just say else, I'll print math score. Let's see. Let's just see. Okay, print okay, if math score is less than this, so here you cannot say no need to add on math score. It is higher. Now watch. Math score, if math score is greater than math score plus 10, print math score. What's math score? 67. So we'll run all of this again. And so, okay, yeah. So what we would have done is that we would have assigned it to a variable. So we say math score plus equal to 10 plus equal to 10. That's it, right? So I hope you got the gist here. So what we did here is we said, okay, if math score is less than 10, we want to add score for it. We say, okay, now math score is not going to be equals to math score plus 10. Because inside of this function, we must make sure that we do, inside of this particular block, this if-else statement, right? You can call it this if-else statement, it's fine, but it's still a function, right? But the fact it has this colon, it's a function. But the reason why we call it a statement here is so it makes sense. So when we start discussing proper functions, in Python, everything is going to make a lot of sense for you, right? So we're saying if math score is this, okay, just give us add 10 to it, right? The math score, print the math score. So let's say math score here was 89. It was kind of greater. No, it's still less. Let's say 99. What's going to happen? So we've saved that. And then when we run it, it said no need to add math score. It is what? Higher. You see that? Because it's this. So this particularly will not run because first thing happens, it checks this condition. Is it? Okay, not. It doesn't qualify. It doesn't execute this function because it checks this particular first line here. They say, okay, math score is less than. No, it is wrong. So it bullets out. But in a situation whereby I did something like, now I added a logical operator, I say, or math score, math score is maybe um is greater than or equal to English score, then math score plus 10, then English English score plus equal to maybe 30, right? Print math score. This is your, okay, you see, we can't do that, right? So we need to use a format specifier. So say double quotes and recommended. So say something like this is your math score. So I could say this is your new math score, and this is your new English. Or say your new math score is All right, so you see that. So if math score is this or math score is that, so it means that this condition here is met. So it's going to add 10 to math score and then also uh you know basically add to English score. And then we can now print them out here. So that's actually how that works. All right, so I think that's basically that, right? So you just need to have this understanding, just for things to make some kind of sense for you. I'm just going to show you how we can print out, use the else if statement, so that we can also have a very good understanding of that. So let's say let's say patient score is maybe patient risk score is maybe something like maybe 24.8. And then we can say something like if patient risk, so if patient risk score is greater than, maybe for example, let's say if it is greater than, so if patient risk score is greater than 19, right? So we're gonna print patient, so I'm going to print this. Patient risk score is too extremely high. Now, I can't do something like if patient, if I can't do something like using an if again, risk score is equal to 24.8. Now, watch what is going to happen. I just want to show you something. Print, welcome. Uh, now, let me assume I reduce this to 20, right? Now, watch what's going to happen. Patient risk score is too extremely high. Now, it checks this. Now, because I added another if statement, oh, patient score, the patient has equal risk score. But if I change this to elif, and then I'll now do something like else, print, no risk score for the patient. Now, you see what happens here is that because I use the else if, which is an alternative block, the way it runs is that it runs from top to bottom, right? It runs from top to bottom. So it checks the first line, then checks the second line, and then checks the third line. So the first line is going to check is immediately checks the first line and it satisfies it. It doesn't need to check the third block again or the second one. Okay? So that's actually how programming in Python works, is that it kind of checks the first block, and then if you're using if else and elif, it will only stop where it satisfies that particular condition. And that's why it's really very what advisable. And let's say we have also another thing like let's keep patient risk score as this, and then saw patient saw size is 87. Now, watch what's going to happen here. Now, we could use and is greater than 90, and now patient is greater than maybe 50. So say the patient's risk is extremely high, and okay, this is less than, is rather greater than, and we could say L if patient score is equal to patient saw size has a very high risk. So that means it's greater, it's equal to this thing, and patient score is maybe greater than 50 at that case. All right. So just kind of combining lots of stuff. I could have multiple of these. Uh, I could just put patients, maybe source size is less than or equal to the patient source size is less than or equals to 10, or patient risk size is greater than 30. I'm just gonna make it 34, and then the patient has severe high risk. And then of course, I could just without, so the patient has a severe high risk. So first thing it does is, okay, patient risk score is greater than 19. Is that true? No. And this, so no need of entering here, it leaves this block. So it comes here, patient risk score is equal to this, and patient risk is greater than 90. Is that true? No. It leaves this block and comes here. Patient's score size is less than or equal to 10, and patient risk score is greater than 30. Print the patient has a what? A low risk. I think I'm going to use a low risk, right? Or no risk score for the patient. So that is just basically what that um, illustrates at this particular point. It's not something you need to really find very cumbersome, but just easy and important for one to actually get started, with. All right. So those are definitely that, and that is what comparison operators are. Now I could just do some last one, with this math score here, just to make everything sync. And I could say if you're for JAMB, what's the criteria for JAMB? You need to pass all of this. So if math score here is greater than 50 and physics score is greater than 50, is greater than, is greater than 50, and chemistry and English. So let me just put an English or I'm going to say and chemistry is greater or equals to 40, Mhm. So this should have some kind of greater equals to, and also kind of add that here. You're past your jump. Okay? Else, Elif. So I'm just going to kind of add all of this. And then I'm also going to add that. So I'm going to say Elif. So math score is greater than 50 and physics score is greater than 50. Maybe um and also maybe math score is greater than or equal to 50 and physics score. Okay, so this time around maybe we could see maybe we could just reduce chemistry here. I say or chemistry is this, but more like we could wrap this and that works. Or chemistry. Okay, let's just put or English. No, and yeah. So this is greater than this is greater than English is greater than uh okay. This is less than, right? So you have failed your jump. You have not really completed the requirements for your jump. And can you run it on an X block? Of course you can. Else, and welcome. You failed jump. All right, so actually, I just hope you guys have the idea of that. So and here is just kind of, let me just show what it means. So basically, anytime we're talking about the not, if we're talking about the not, and then we're talking about the and, then we're talking about the or. This is just basically what we're talking about. Just think about it as a universal set like this, and then we'll have something like this, and then maybe something like this. And then let's say this is B, this is A, and this is C. And then this is point X, this is point Y, this is point Z, this is point K. Now, if you look at this right here now, you're going to see that X means AX. For X, the expression X means A and. So for X, what the expression means is what? A and B and C. All right? So for that is for X. Now for Z, I'm just going to give you some intuition. So Z here means C and B. So for not, you could ask not uh not A. All right? So for K here means what? A and B, not C. And then for X, for that's Okay, we have Y. Okay, then Y here. So for Y, what we have here is A and C, not B. So that's actually what it is. Not to worry. Really very easy to have a grasp of just basically what is being talked about. All right. So you could see that that's it. So that means each time we so it means that each time we kind of create any sort of we use the operational, that's the condition there. It means that we want you to okay satisfy so and so expression and then also satisfy this expression and also satisfy this expression and also. So you see that this is really very tight, but here we have the or, so we use the or to loosen it up. So if the English score is even this, or the chemistry score is even less than that, so that means you've not really satisfied the point for your what? For your jam. So that's actually going to be that. We don't really want to waste so much time on that, but yeah. So there's also what we call membership and identity operators, right? And that is the in, not in, right? It's something that is very important. It's something that is really very, very important in uh, in in Python programming, right? Because you can remember when I was telling you about using when I was talking about using reserved. That's, or rather, I'm going to say, when I told you about not using reserved keywords. Now, there's some words that are like in, not, is. These are what membership terminologies, right? Okay, I'm just going to delete this here. So maybe anytime we kind of performing any type of membership testing, uh, membership. So do some membership and identity operations. All right, so basically, what are we going to do? So basically, let's say, for example, now we kind of jump a bit. So let's have a list. Let's say A is equals to, for example, now, let's say health children is equals to, let's also have a list. And then we'll have yummy, and then we'll have 78. Because a list can take different data types. We have true, we have Samuel, we have John. So if we say, in this case now, this is a list, right? And that means this is a list because if we kind of do something like print, remember, print type of children. Okay, so that's going to give you a class called lists. All right. So what does it mean now? So uh, where does membership testing now come in now? So membership operation, let me just kind of spell this one. So what it does right here is that we could say if Yami and children, now this is the n. We won't know if this is inside of this term. This is a list, it's holding an item, right? Print Yami is present. Okay, so let me just kind of comment this out. And because we've not gotten to that. So you find out that here, it kind of clearly shows you that what? Yami is what? Present. All right? So that's just basically it. If Yami in children, print Yami is present. Now, if I say, for example, here, watch, if I say if, let me just kind of comment this part out. Okay. Now, if I say something like if false, not in children, print uh, false is absent. Okay, false is not defined. All right, so that is, we use false. False is absent. All right, so please just make sure you spell correctly, right? So you see, false is not there, but if I cannot do true, it doesn't run anything because it's there. So there's nothing to that. So you say else. So that's why we use the else block now. I'm not going to say. So the else block is always something to fall back to. That's the meaning. So we say, we will not say true is actually present. So that's it. So see that true is actually, so it's a, if true is this thing, not to say true is absent, or if else true is actually present. So that's just true is absent, so true is actually present. All right, so cool. So this is what we call what membership what testing. So we use it several times in what this. Now also what we call the is, right? Now, right, the is. Now let's say for example, now we have let's say for example, name is equals to David, and then see surname is equals to David again. Now let's say if name is surname, print yes. Now watch. So what happens? The name is the what? The name is what? Surname. So I wouldn't have used the word in because I don't think it doesn't make any sense using in, right? That's logically now if I'm reasoning it now. So we could use a better word to now compare it, right? So instead of us saying equal to, right? We could say if name is surname, print yes, it is, right? All right, so let's kind of check out if we have other types of data, maybe like a dictionary or something, or a list. Let's say, for example, we have uh, class scores is equals to I for I in range, I in range of maybe 10. Don't worry, don't worry. I'm definitely going to explain that. And then we'll see maybe past scores is equals to maybe if I don't let me have something like I don't know, for example, I could have maybe 0, 2. All right, so normally if I want to check the length of this particular item, I could just print length of class scores, right? So that's just to check the length of the items inside it. So this list, this is what we call list comprehension. I just did it just to show you something right now quickly. So here, if I say something like maybe if two in class scores, print there is a number called 2 inside it. All right. So you see here, well, there is a number called 2 inside it. And that kind of tells you something about how we use, double quotes. Anytime we are talking about strings, we do use double quotes, right? So if we want to use a kind of quote inside of a double quote, it's always advisable to use double quotes outside and then now use your string. Because if you use your single string here and watch what's going to happen, you see, it becomes a problem here because it doesn't know whether you're ending it here or here. So this is actually good practice. All right, so let me show you what class course looks like. I don't want to confuse you. So that is just a list of numbers from 0 to 9. Okay, it doesn't really include the last number. It starts from 0 to the, it doesn't include that particular stated number. It just kind of gives you 10 numbers. So I just kind of, still on membership testing. Let's use something proper now. Everybody can understand now. Let's say diseases, and then we say we have yaws, we have malaria, we have onchocerciasis, we have leishmaniasis, and then we say old diseases is a question. And then I'll say diseases can print diseases is old. Now it kind of returns false, right? Now, why did it return false? The reason is because these are two different objects, right? So it returns false because these are two different what? Objects. So that's it. And if I do print, for example, yours in old disease, it's going to return true because there is yours. Now let me just put something like HIV. So that's false. First of all, as much as they are both the same, they contain the same distance, they are different. In the memory, they are stored as different objects. So that's why it is false. So you say that this thing and this thing is the same thing. No, they have the same properties, but you know me say they are the same. They are stored differently, right? So you say print HIV in all diseases, it's not there, so it is false, right? So but the moment I add it here, it becomes what? True, because it's there. Of course, this is definitely still going to be false because the list is no longer the same. So this is what we call membership testing. So we could go on and just to show you so many things, right? Uh, yeah, it could actually do membership in terms of you could actually do membership in terms of strings, right? And of course, all these things are definitely going to work. And yeah, all right. So what I mean now is you could have your name. What's your name? Let me just kind of give you an idea of what I'm talking about. Let's say for example, section is contraceptives. And I'll say print contra in section. False. Now, because it's not the same. Now, but immediately I change this to C, it becomes true. Remember, it is case what? Case sensitive. Let me mark that. Case sensitive. In that have been programming. Okay, so guys, that is definitely going to be that for now. I don't think there's much of what to worry about right now. We're really progressing really well. Remember, is checks the memory identity, whereas you know, equal to check the value, but equality. That's why here, if you see, we have A is this, B is that, C is equals to A, and then we have if we say print A is equals to A, is equals to B, and then we're kind of printing A is B. That's false because they don't have the same memory address, and because it's in the memory is stored differently. But then when we say maybe A is C, right? Because here we are assigning C to become A. Of course, it's true because they are same object. And then if we say print A is B, it's false because they are different objects in memory. But if we do the value check, of course, we'll get the same. So that is how we are able to get some of those differences, all right? So I've kind of explained the if-else statement. This is just kind of a grading system, which I just want to show you. Or for again, let's say your score in school, your score, or let's say your exam score is 78, and then you say if your exam score is greater than or equal to 19, or so rather 70, uh, remember we'll do a colon and then we'll print you got an A, elif, your example. So it's going to take another expression. It's greater than or equal to maybe 60. To print, you got a B. And if exam score is greater than or equal to 50, print, you got the C. And if exam score is greater than or equal to 40, okay, D, else. So the else is not going to take an expression. So print, you failed, you will fail. Yeah, all right. So I'm going to run that. Of course, you got an A. Now we cannot change this to 43. You got a D. If I change it to maybe 31, failed roughly. If I change it to 67, of course, you got a B. So it is actually that for that. Now, I think we could also have done this, right? And this is if has ticket, if these are where we can perform some kind of nested conditions. And of course, we could keep nesting to two levels now, so that it will make it really very readable. Now, I'm going to explain this. Now, when we talk about nested conditions now, just think about this way now. Sometimes we can place an if statement inside another. All right. So it means that now, if you look at what we were doing before, now we're trying to use logical operators to wrap it around it. But it's possible that we can use an if statement, right, to nest inside of an if statement. Now let's take our own example right now. And yeah, that's going to bring us to that nested condition. So I'm going to say nested conditions. All right, so let's see, for example, here, are my the patient, the patient, what are we going to call this patient now? Patient or the vomiting score is, well, let's do something that is going to make some sense that we can easily relate to, right? So let's not complicate our terms. Maybe we could do something like um, uh, weight. Now let's assign weight to maybe 68.7. Now, I'm going to do this now here where we're going to give some user input, right? So that let's make it much more realistic, okay? So here now our weight is this. No, our weight is going to be our float input. Please enter your weight, all right? In kg. So let's tell them how they are going to enter their weight. Now, we're going to have height. So I'm going to say float impute. So please enter your height in meters squared. Okay. And now, so how our now age is going to be int. Now, you could want to leave that way, but very important, right? Impute, please enter your age as at your last birthday. Okay, so I'm going to just bring this up. First thing that is going to pop out here is print. Welcome to this program, right? Welcome to this Christian health service. So let's call it health service, or better still, we're gonna say name, name, string. So name is going to be string impute. Please enter your name. And then also to form, we use the format specifier here. Colon cast to say the name. So pass the literal here. In JavaScript, we call this a template literal. So say name that the person will come to this. So means that once the person passes their name, it's stored as a variable. Then that variable is now stored inside of this triggered immediately. Then the next line. Now, do you know what I want to do right now? And before we run this program, now let us now I've saved this now. I'm going to save this, right? Now, what we're going to do now is I'm going to show you a normal nested loops without taking user input. And then we'll now write this pro exercise, this game here, where the user is going to pass in some user input, and then we'll now question the like once the user passes in some kind of input, of course, we'll definitely question, we'll use some if else logic to wrap around it, all right? So that means here, if we have our age as maybe, here now there's no user input, probably maybe 29, and then we'll see height is going to be equals to maybe 1.8, and then we'll see weight is equals to maybe 80, right? We'll say that if the age is greater than 18, now if Now we're nesting it. Now this is what we call a nested conditional. Now if the height now is greater than maybe 1.5. Now remember, the reason why it starts from this indentation, now it tells us that it's still under this. So it means that this also has to be under this. So we could now print here, could print and say that you are an adult that, okay, let's kind of increase it to, let's say 1.7 or 1.7, yeah. This is going to equal to this. You're an adult that is very tall, or not really very tall though, because somebody who is 1.7 is not really, really tall, maybe, and then, but just for the sake of this program. But then what if the height is not? So there's going to be an else block here. What if the person is greater than 18, but the height is not greater than, is not greater or equal to this thing? So you could say something like else print, uh, watch, you are you are an adult that is not too tall. Now remember that we still have our first else here, our first if here. So we now say else. So because let's say for example somebody is not even greater than 18. So it should be heading down. It doesn't need to enter inside this box. So the only reason why these next conditions are going to be triggered is if it satisfies this. Right? So first of all here, I could decide to say, okay, let me print you are an adult self. Okay, that's still cool, right? Then I'll still nest inside just so that you guys will understand what I'm doing, right? So first of all, you are an adult else here, and I'll say print you, remember you wrap it, you are not even. So let's run that. You see that this is definitely going to work. So because first of all, and first of all, it's a age is greater than 29. So of course, it prints this one. The reason why I'm putting this print here now is because so that you know how the conditions is going. So this one works. And if the height is even greater than this, then this one will also work, right? Let's take the height down to maybe something like 1.4. Now watch. First of all, you an adult works, right? Because it's nesting, and then it checks this condition inside. No, it doesn't work. So it goes out immediately, right? It goes, okay, you are an adult that is not too tall. It goes out from this condition, then moves into the else block here and say, oh, you are an adult that is not too tall. And that's it. It doesn't even come here. Now let's say this is 1.9999. And then here we have a height age of 12. What happens? It checks here, is it greater than 18? No need to of entering. It goes down to the next else of this corresponding if. And then checks, okay, you are not even an adult. So no need of us even checking inside. So this is just basically how nested if statements works, right? So we're going to practice this now by running a game now. We're going to create some small practice here now where we'll allow the users to pass in some inputs, and then when they pass in these inputs, we could now when they pass in these inputs, all right? So what we're going to do right now is we can now use it to create some if blocks. So I'm going to just complete this program by saying, okay, uh, if name, by if name here, uh, this is more like, say it's true, the person entered the name correctly, maybe you entered the name, something like that, right? And that means that it's actually name, okay? But just let me just show you what I mean by that now. Right here says, let's say, for example, I go to this place here, and I'm sure you guys really understand. This say, let's see, let me just use something I've not used before. Jar is equals to children. Let's say if jar print yes. Now you see, it means that the fact that this is once you declare a variable, it becomes true, right? So even if I didn't say if jar is equals to maybe adult or something. So the fact that I've said if jar, that means it's true, right? It is true. So the program should run. That's what I mean, right? Yes, a name was declared. All right. So that is just basically what it means. So once this has happened, it is what true. It means that it holds true that something was declared, that a name was assigned. Rather, I don't want to use declared. That's more for JavaScript developers. So first of all, if name, that's what I mean here. Then I'm going to now say if uh, age. So if age is greater than 30, right? Now I'm going to say if, yeah, so could you print something? Because you print, you are now above 30, 30 years. Now, if weight is maybe greater than or equal to 44.5, maybe 78, just to shift that 78 or 70 rather. I mean 17.0, print. You are an adult that has a weight that is big, okay? Else, now I could do continue, but I don't want to do that now. Okay, so print your age is big. Age is not, no. Your weight is less than 70.00. And then, now if, now remember, we're still under this block here. So it means that if this thing is even greater than this, okay, I think I could just put that up here. Now, if height is maybe greater than, because all the if, we first of all consume all the if, right? So if height is greater than or equal to 1.8, right? So print the fact that you are an adult and too tall to wait and too tall is terrifying. Okay? And then I'm going to say else here. Now this particular block, this particular first block. So I'm going to move this up. So I'm going to say print you have to level up on your height. And then I'm now going to come to this else. That's the one for this one now. That's if this height now is greater, if this thing qualifies here, and then also the height now is no longer greater than 17 here. So that's the else here. So we'll now say else. Now, we could also add some kind of early, but I don't want to make it so dating now, so that it's not going to, become confusing to somebody. So print, because yeah, why we are having this if here now is that this person is maybe not greater than 17, right? And wait, so I'm going to print you are an adult, please level up your weight. All right, so here now, so this is kind of a weight game, a weight checking game, a weight and adult checking game. And then so maybe we could come down here. So we have now here, so you're an adult, please level up again. Now remember here now you are an adult with weight and please you you have to level up your height. So here we have else. So it means that so you're an adult, please level up your weight first. Remember, this is different from this now. Okay, so because this person now has weight, but the person fell because of height with much weight. So let's say with much weight and the height is too tall and terrifying. And then here, but this is because of this here, you're an adult, please level up your weight first. And of course, we'll come out here. So this is what I'm going to have on else. We're going to say print. You are not even up to 30 years of age, please. All right. Okay, so this is it. And then we're going to say else. Now this is the last else now, which is no name was entered. And then we're going to say, please, print, please enter a name. All right, so I think that's it. So our game is ready. So we're ready to play and we'll run it. So first of all, it's going to ask us your name. Let me try to pass it. Okay, I just tried to pass it. Welcome to this health series. And okay, I think I didn't spell this correctly. Let me just kind of check. Enter. Welcome to this health series. And I think because of that string, just the name. Wait, let's kind of get all of this properly set. Okay, so now what we're going to do now is print an F string here. Let's just make it make more sense. Name and Mr. Name. We'll add an F string. So say F string. So pass just passing name. Okay. All right, so I think I'm just going to close this for now. Let's just make our program sweet and easy. And so we're going to also use an F string here. Again, I'm going to say name and you are this, which more weight of. Now let's pass in that weight. What was that weight? The weight is weight. Okay, and under that has the width of, that's that width. Remember, this is what we call F format specifier in Python. So we're passing that's the variables that they did store. So width of width and your height makes you too tall. And okay. So it's a name. All right. So sorry, it's becoming like spaghetti. What? Please level up your width of width and so I'm just gonna add a format specifier there. So I'm gonna call this name. You are not even at 30, sorry, which one is you are just page. Okay, please enter the name. If name. So, all right. So is there any other thing we haven't touched? Ghana above 30 with age of. All right, so guys, I think that is that. So we're going to just run this. So enter your name. I'm going to enter David. So David, welcome to this health series. Please enter your age as that of your last birthday. So I'm going to enter maybe 26. Okay, please enter your weight. Maybe my weight is 67.2. Please enter your height, 1.9. David, you are not even up to 30 years of age. Please, you are just 26. Okay? So you see that's how it works. This is not really different from what's happening. And please, you are just 26, okay, years old. Okay? All right, so let's try again. Enter your name. This time I'm going to enter Sarah. Okay? So it says, so it can say, Sarah, welcome to this health series. Please enter your age, 34. Please enter your weight, 35.7. Enter height, 1.9. Okay, Sarah, you are now above 30 years with an age of 34 years old. Sarah, you are an adult. Please level up your weight of 35.7 yet. So what do you actually realize now? You see that this kind of executes and stops here, right? So Sarah, where's Sarah? That's kind of okay. You are now, so you need to level up here. So because we did it, Sarah, because of Sarah's weight in kg is less than this. So this block doesn't row. So this is what rows next. And then, of course, it terminates from the loop. All right. So that's actually what you actually need to understand. Very, very, very much important in nested conditions. So I just wanted us to have a glass of this game. Don't worry. It's something that definitely going to make a lot of sense. And as time goes on and all of that. So I would have just wanted to check out one more thing. We will try to enter nothing. And of course, it's not really going to work. Okay, so we get back there. All right, so that's just how it is. We kind of advance, like I said, we touch on our slides and then we move back into we touch on our slides and then we move back into that's a proper practice where we get much more deeper insights. All right, so that's it. So here has ticket. If it's yes, then if it is greater than this and than 18, then if it's yes, it does this. And so that's what we call nested conditions in programming in Python. Well, so kind of hands-on exercise that we could do here. I've already showed you this. We give the user input for age, yes, no. We check the membership. If it's this age bracket of these things. So these are actually some kind of exercises. Of course, they're going to be committed on my repository and free to get your hands dirty. But other than that, you could actually just jump into my Git repository and get all of this. So some of the key takeaways from operators here is that, we have our arithmetic operators, we have our comparison operators, we have our logical operators, we have our membership operators, we have our identity operators that lets you kind of evaluate and manipulate data. And then we have our booleans, which I've actually showed you. And then, it kind of has every comparison returns true or false, which is what we've been doing here. And then we have our if or else, elif, where Python runs the first matching branch, order matters really well. So, they place specific conditions, before general ones. I cannot nest carefully, very important, because here I could, if I wanted to mess this up much more, I could add some elif here, and then you see that it can become challenging. Let's take, for example, here, if the height is greater than this, I could just still add say elif and say if the height is maybe equal to, if it is maybe greater than or equal to 1.6, then also check this condition. And of course, what happens here now is that at this point now, it's going to now, instead of jumping into this else, to check this condition again to be sure it qualifies. And then if it does qualify that, everything automatically is definitely going to run well. So guys, I really want to tell you that, programming Python is just practicing a very simple programming language, not really very difficult, but it makes a lot of things really very easy when you continue to practice and get meaningful insight out of it. Okay. So that's actually how it works. And yeah. So actually that is that for now. We are done with that, although we continue to progress. And the next part of it now is we're going to be getting into data structures, right? So we're going to be working into data structures. So if you're watching this video, maybe whatever time, we started this video by talking about basically all the parts that we're going to be going through, looking at. So here we're going to be looking at data structures in Python. Okay, we're going to be looking at data structures. So data structures, I'm not talking about data structure and algorithm. Just we're talking about data structures where we look at some stuff like lists, dictionaries, tuples, sets, and this is actually like really very important. That kind of prepares you ahead for what you have. That's how to handle data, because in your journey as a machine learning engineer, you're going to be working with data structures, right? So when we talk about data structure, we're talking about lists, we're talking about tuples, we're talking about sets, we're talking about sets, we're talking about dictionaries, right? Now, so you see that each of these data structure have some features, or it has some kind of characteristics that it possesses, right? And from there, we might talk about some of the methods in some of these data structure, in specific what? Data structures. Now, when I started this video at some point, there was a point where I did something like the name is equals to Cynthia, And then I answer it for I in range, just example, I say for I in range. For I in, uh, for I in, because this is membership now, for I in name, then I now said print. For example, I'm just giving an example, right? I said print I and I and equals to this, right? And then it kind of gave me this, right? Cynthia. Now, when I did this, right, I kind of told you that this is just more of me iterating all over this, right? So what it means is that there are some type of data structures where we can perform some of these operations in. I don't want to rush into loops, start talking about loops, while loops, and all of that. But I'm just kind of painting the scenario for you that we can iterate over a sequence, right? And some of that sequence is what we're going to be talking about. There are so many sequences. We have the lists, we have the tuples, we have the sets, we have dictionaries. Now, lists, we usually abbreviate them with this, right? For sets, it's usually a bracket. Some of the objects inside of the set, and these are the why sets and dictionaries hold similar structure. But the difference here is that the dictionary might come key value pairs, but we're going to talk about them one by one. Okay, so let me just comment this out. Now, thank you for that, right? So we're going to start with lists, right? So what are lists? So a list is any type of data structure that holds maybe it holds multiple data types. It is mutable. That's according to the mutability of this. It is very much mutable, and it has the capacity to do it. It has the capacity to, more like that mutability there now is it's kind of performing so many operations. You can transform a list, you can mute it, you can even perform arithmetic operations in a list, which is actually really important, right? So it's mutable, right? And it can be modified. If I'm trying to repeat what I just said, I mean mutable. Unlike tuples that might be very immutable, it's very immutable. So as somebody who is a machine learning engineer, you're going to be working with a data set, right? So think of that data set to contain some rows and columns, all right? Now, let's say you have a data set for diabetes now, right? Diabetes data set. Now let me just show you something, okay? I'm just going to push it up and like that. Now, if you have something like, well, so if you have something like, a list, for example, here now, let me just come to somewhere here. I don't, I hope I hope I've not gone out of where I'm supposed to be. All right, so we have something like a list, right? Now, we said that a list is represented this way. Now, let's say you're a healthcare worker, you have a data set like this, right? And then we have this, we have this, and we'll have something like this. Kind of have this, and then we'll have this. Also have this. Now, this could be age, this could be height, this could be weight, and this could be temp, and maybe this is, maybe, what are we going to call this now? Status. All right, maybe it is 21, 1.8, this is 35.7. Temp is temperature is 36.7, and this is positive. So I'm going to mark it positive. This is negative, this is negative, okay? So it could be anything, right? So here it is 39, this is 1.6, this is, maybe we could use 71.0, and this is 37.1, something, something. I think this is kind of quite high, but just leave it that way. All right, so this is maybe 18. This is maybe 1.4, something shorter than this is. No. This is, maybe okay, just do this. Sorry, I've messed this thing up. So this is going to be 60.0 and maybe 35.9 and then negative, okay? Now, what can you see here now? We have something like age. We have something like age, and this is what? A list. 21, 39, 18. That's a list. This is height, and that's going to give you 1.8, and that is going to be 1.6. That's going to be 1.4. That's a list. Now, this here is going to be weight. Thirty-five point seven, 71.0, and 60.0. Okay, that's a list. So here is going to be something like temp, and here is going to be something like maybe okay, I thought I've not messed everything up. 36.7, 37.1, 35.9. That's a list. Now here also, we could have something like status. Okay, it's going to be positive, negative, and negative. That's a list. You know, when we talk about lists and as a data structure, a lot of people think, we are looking at maybe something different, all right? So, but essentially, what you just need to understand here is that when we're looking at data structures now, we're trying to prepare ourselves ahead of what is coming. So let me say I have age, and I have something like maybe 18, no, sorry, 29, 32, 19, 28. Okay, and then so this is a list. So what makes this a list is that it can actually hold multiple data structures. So we could have something like data set, and no, I don't want to use the word data set. Let me say random variable. We're going to reserve that for dictionary, and then we're going to have something like maybe 32, and then this person now root positive. This was now root 34.5. This was now root or maybe this is true, and then this was now root Sandra. Now, this is a list, right? How do you know it's a list? How did we know it's a list? Because when we print, remember, we check the type. We check the type. So we wrap it with a type function here and pass in random variables. Right? We're going slow, right? Because a lot of people have misconceptions about programming. So we need to go slow. So you look at this now, age, right? If I also check and say print type of age is, and then I wrap it and put type inside of it, and I wrap in age, type of age is of class list. So this is a list. Now, imagine I change this age now to a bracket. Now, what will happen? And I run it, it has changed to a tuple. Remember when I told you about data structures, I told you that for list, we represent list with block brackets, whatever thing I want to call it, right? Then we represent tuples with this because tuples are immutable. They don't change. You cannot change it, right? You can't change. We'll come to that anyway. So, but sets are represented by maybe curly braces, but dictionaries are represented by curly braces. But I will still know the difference between sets and dictionary. Okay, let me just kind of try to change this age. Now, remember, we're using age now. More like we're focusing on age now, right? We're not really focusing on random variables. It's still list. Let me just kind of comment it out so that it doesn't run again. So if I run this, it's out. So if I change this to a bracket, so let me run it again. So it kind of tells me that this is a set. How do we confirm that? We go up. I did mention that for set, they are what unordered. So they are what? This is a set. We'll come to that. Don't worry about the definition. We're still under lists, right? So I'm just trying to show you how the brackets are based on orders. Then we'll focus fully on lists. Before we are done with lists, we'll move to set, we'll move to tuples, dictionaries, and all of that, and then we'll get out from there. So now, but how can we get this thing to become a dictionary? Because a dictionary takes in key value pairs. So I'm going to just wipe this H out. Okay, no, don't wipe it out. Rather, I will put something like a key inside of this. I'll call it H1. Okay, I'm going to put another key inside of this. Call it H2. I'm going to put another key inside of this. Colon, use a colon to separate that. I'm going to call this H3. Yeah, I think that's it. So I'm going to use a colon. That's it. So what happens if I run it? It has now changed to a dictionary. It's no longer a set. Okay? So don't worry. Well, I'm going to come to all of this. I just wanted to just let you know what some of these data structures are. So what dictionaries are? You're going to be working with dictionaries severally. In short, when you look at your data set, when you look at our data set here, this is a dictionary, okay? And then each individual item is a list. Then depending on how you want it to be, a tuple or set, you can decide to maybe typecast it or whatever. But don't worry, that's by the way. Okay, all right, so we're just going to clean all of this up. Let me just clean everything up, okay? All right, so we're going to start with, so this is data structures, right? So the next topic here is going to be lists. So we're going to look at what? So I'm just going to, so this is what we call a markdown. I might not have really talked about this, but what do we mean by a markdown? So this is just like, if you're working with Jupyter Notebook or whatever, maybe a text editor, instead of you just having to wrap your comments, you use a markdown. I think I will definitely make a video on markdown separately later and then but post it on my channel. But for now, just kind of have this. So what did we say lists are? Is any kind of data structure that is what? Mutable. We can change it. So let's say, for example, we have age. I think we're done with, let's say we have glucose levels, and then we have everybody's glucose as last time I checked. Probably, I think mine's quite cool. I'm not a foodie guy. So let's just say these are their glucose level, all right? Now, what does it mean by this being this? We can change, we can remove something from here, we can change it. So I could do something like glucose. Now this is holding a variable, right? Which is called a list. So I could say glucose levels. Just to be sure I spelled that correctly. Dot append. Okay, dot append, maybe let's append it's 9. Now, what does append mean? Append is a method for a list. Now, what are methods? Now, think of it this way. Now, we will talk about this when we get to object-oriented programming. Now, when you have a function, there are several You know, when I do print this, let me just do print type of glucose levels, right? It gives me a class, which is what? Lists. Now, inside of this class, there are something we call methods. Sometimes people might call it functions. You can call them functions, but that's fine. All right. But basically, what we want to know here is that we have functions or methods that are attributed to this class. Let me also show you something else. Let me say, for example, now, let's say your surname, the surname is maybe, let's say something like Adeyemi or something, right? Now, each time I say surname dot, now what happens? Immediately I use the word dot, it calls up all the methods that are attributed to this class string. So in programming, let me tell you something. In programming, almost everything is in a class. Even the print function is in a class. So if I say dot capitalize, right? I don't know if it's called, you could call it, so it capitalizes it to what? Adem. Let me just kind of take this to down. You see, it's Adem. Let me take this to Rufus. You see, it has capitalized it to what? Adem. Because there is a method inside of the class of strings that is called capitalize. So what's that method? Don't worry, don't worry, don't worry. You're going to really understand this because in what I'm saying is this now, is that you have a blueprint, a class. So inside of this class, there are several methods. So that method is just like, think of it like you create a vehicle. You can say, I drive, I move, I park, I change oil, I change fuel, put fuel, add water, add kerosene. All these things are methods. Right? Human being ourselves, we are a blueprint of God. So it means that being blueprints of God, there are several methods that God expects us to do. What are those methods? God will define you. David dot go to church. I'll start going to church. David dot go for tutorial. I'll start going for tutorial. David dot do this or do that or do whatever. But essentially, just basically what I'm saying is that for each particular blueprint or class, there are methods. So I could just say surname here. I'm just showing you something. I'll get back to the list now. Dot maybe strip, dot left strip, right? I have to call the method. So it's going to take me down to strip. There is different, what I mean by strip now, let me just say I give a space here, right? Watch. Okay, so let me just kind of remove this. So that's, all right. So now let me just watch. This is different. This space here is different. Look at this is the space I'm talking about here now. You see, it takes it out. Watch. Now let me say surname dot end with. Now I could do something like if surname dot ends with maybe let's say for example, if it ends with E, print this name ends with a letter E. I'm just kind of teasing, right? And else, remember, that's why we learn everything in line. Say, else, it doesn't. Let's see if that works. Okay, it doesn't, right? Because it doesn't. Now, let me just kind of say ends with and I change this surname here to, well, let me just clean this thing up so it doesn't throw up an error. And I change it to Adeye. Now let's see what will happen with this space now. Okay, I run it. Of course, it strips it. It takes, now what happens here is strip, it removes that space. Now let me even remove this strip here. Let's see and run it. Okay, print surname. Watch. So there are expected spaces here, right? And then let me just kind of run this. Sorry. Cool. It doesn't end, right? If this name ends with I, it doesn't. This name ends with I. So let me run this. And it says print because of what? That space. There is space here. There is space. You can't see it here, but there is space here. That's why. So but now look at what I'm going to do now. If I kind of remove this now and print, that space is out. So let me just kind of bring this stuff here now, just to make it easier for you guys now. Surname is equals to maybe add the or something. Okay. Okay. Oh, I didn't change this tense. Sorry. The name, this name ends with the letter I, rather. Okay. All right. So I'm just going to run this, and of course, everything works really well. Sorry about that. I should have actually stripped this off. So I could just do that, perform that here with a surname dot lower. That's if it is I could just dot lower. Of course it does, but let me just kind of print. Let's print surname now. You see that? Okay. I think we remove all of this. Cool. So just to be sure this is matching that. And wait, hold on. Let's see. Let's see. The name is equals to David. You know how this. And then I'm gonna say, okay, yeah, I know. It's not, it can't change it. So let's say new surname is equals to this. So this is what I'm supposed to do, and then I'm going to say new surname. I'm going to tell you why that happened now in a jiffy. I just want to make sure everything's good. New surname now. Now what happens here now is that it changes this, right? If I print this, it's going to print out this surname as lower here without this print function, right? It's going to print it out here as lower, but it cannot mutate. Strings are immutable. I cannot change the initial object unless I'm going to assign it to a variable. And I say new surname now. And I'll say, okay, surname dot lower. Okay, that go and hold that value, surname dot lower, right? Then print for me new new surname. And then it gives me what? Add. Now, basically, what I want you guys to just know here is that this lower here is a method. Are you seeing how it works now? This is what a method. So the way it is happening to this string, because if you do print type of surname, it's going to tell you that it's of the class string. So this is a class. So it has a lot of methods inside of it. So that's why most times I could tell you, read up the documentation of maybe it's so and so framework or whatever. But just basically for you to understand methods, how it works. So what am I saying here? Let's get back to business here. So I think I could delete all of these for strings. We don't really need that. So basically here, what we're saying here is that we are appending its 9 to this particular glucose object here. So it now has what? Glucose level has its 9 sort of. So if we kind of print type of this, remember it's still that, but let's just print glucose, now the new glucose list level. So you see that 89 has now been added into it. So there are other things we can do, dot pop, dot remove. We could do glucose levels dot. Immediately we press dot, it lists out all the methods that are attributed to this list as a class. So these are functions. You could call them functions. If you call them functions, not bad. If you, whatever thing, but you could sort, you could remove. I could remove remove 78. So let's print glucose. In short, I could just call glucose level because this is PyCharm. And I see 78 has been removed. Okay, so we could do glucose. So basically, all of these are what we're going to be doing, glucose levels, right? Sorry, I have to spell this correctly. Glucose levels dot clear, I could clear the whole thing, and then I've cleared it. So if I paste glucose, sorry, I didn't spell that, and that's empty. So I've cleared it. So there are a lot of things you could do with list, but then I just want us to kind of just to be sure that we have the concrete understanding. Let's just kind of look at what we have in our documentation, right? Okay, but then this is actually some of what we can do. We're going to look at that shortly. And there are several methods inside of the list. We could remove stuffs, we could put in stuffs, we could add, we could pop. Let me just create another list. Before we look at that documentation there, maybe we could have fruits, and then maybe have something like maybe something of maybe mangoes. Remember how we are typing? You must make sure that all your strings are wrapped in quotes. Strings can be wrapped in single or double quotes. I can have a single quote here of pawpaw that works, and then I could still have this. Then we can have maybe guava. I could have maybe uh, orange juice. I could have pineapple. Okay, and then I'm gonna say fruit. Let's add fruits. Now I can decide to change this mango to Fanta, right? When we look at lists, right, so you have something like 0, 2, 0, 1, 2, 3, 4, 5. Now, what am I trying to say? When we want to access any element inside of this list, we access them based on index. Based on what? Their index. So what do we mean by that? So this is index 0, 1, 2, 3, 4, 5. That's how programming works. In programming, whenever we're accessing, whenever we are counting from 0. A vast majority of time in programming, if you're asked to count how many assign numbers to this, each of these numbers takes an index of from 0 to 1. That's why when we say something like for I in range of 5, maybe I'll say print I, watch what's going to happen. It starts from what? For you to print numbers in the range of 5, it starts from 0, 1, 2, 3, 4. How many numbers are here? 5. But because it started from what? 0, 1, 2, 3. So that's how it happens in program. So what am I trying to say? If we want to add to this now, ordinarily, I could do fruits.append, and then I'm going to add 56, right? So if I do that, of course, that's going to work. Now, let's say I want to remove the first item here and change it to something else. So I could do fruit. Now, there is something we call the bracket notation and the dot notation. All right? So we're going to use the bracket notation. So we say fruit of 0. Now let's print it. Let's print it. What is it going to be? Mangoes. Now if I print fruit of 1, what is it going to be? Pawpaw. If I print now fruit of, let me go to the last one, -1. Let's see if that works. Now the last number now is 56 because I added 56 here. How do we know? Let me print the entire list again. Print fruits. So this is the list. But remember, append means to add something. So I added what? 56 here. If that is going to be confusing, I could decide to remove that what I added. All right. And then you can run it again, and then it says that's out. So the last item here is purple. So if you want to access from the ending, you can start with -1. If I go to -2, it's going to take oranges. Now, what if I do -9? at least is what? Out of range, because it kind of goes, -9, -8, sorry, -1, -2, -3, -4, -5, you're out of range. Okay? So you can either go forward or backwards. If I do 5, it's still out of range. 5, reason, this is 0, 1, 2, 3, 4. So there is no 5 inside of this. There is no index of 5. So if I kind of keep this at 4, of course, it's going to give me pineapple. Let me comment this out, okay? So it's going to give me what? Pineapple. But if I want to go back, I could use what? Negative sign. All right, so that's actually that. Now, the reason why you must understand this now is this is what we call uh, assessing list items, right? That's trying to assess some of the items inside of this list. Of course, this is how it is. And, you use this indexing, to assess it, all right? Now, that is definitely going to be that. Now, let's open another cell. Remember, I keep opening another cell here. Now, let's say I want to start manipulating this list now, right? So how do I want to manipulate it? I want to kind of I want to change this mango to something else. What was the definition of a list? It is what? Mutable. It is what? Mutable. What does it mean for something to be mutable? You can change it. You can remove something from it and put another thing. So I'm going to, what am I going to do? I'm going to assess this element. I'm going to copy this here, put it here, and then assign it to what? Papaya, something papaya. So what I have done now is I have now I'm saying, please check what is in 0, as put it, replace it with this. So if I kind of print fruits, you see that one. It has now removed that mangoes there and replaced it with what? Papaya. Now, this is something we're going to be doing several. Let's say, for example, now we have patients, conditions, and then we have something like the HIV, we have syphilis, syphilis, we have tuberculosis, we have tuberculosis, we have what else? What's the other disease people are disturbing people with? Diabetes, and then we have maybe leishmaniasis. I think it's actually leishmaniasis. Now, what am I going to do now is I could decide to say, okay, this is a list, right? And then I could say, okay, if now let's because we've learned this now, if patients, if HIV in now we are applying membership testing, right? Is in patients' conditions, right? What are we going to do now? So we'll now say print, for example, let's print HIV is present. Road no clear. Okay. Else, let's say a leaf. Let's say for example, HIV and syphilis. Okay, so now what's going to happen now is that this first condition is going to be triggered, but in and in okay, it's in this, right? And then let's say and which other disease did I not list now? And say leprosy and leprosy. Okay? Okay, so if elif, then we could say print maybe honestly run for your life. Else print root clear. So now if we run this now, right? Okay, so honestly run for your life because these two conditions are not inside of this list. Now, but now there's a reason why I'm doing this now, just to refresh you now. So let's say I want to remove, I want to kind of count the number of items inside of this list. How do I do it? To count number of items in a list. How do we do it? So I'm going to say print length of patient conditions. So let me just put the something here. I'm going to say the number of diseases in that place is 5. So that's 0, 1, 2, 3, 4. So that's the number of items here is 5, okay? All right, so what are other things we can do in a list now? So like I said, I can do patients. Let me just kind of copy this so I don't have to type so much. Dot extend, I could insert, I could pop. So let me sort, dot sort, and print. Now it's mutable because it has sorted it. But if it was a list, if it was a string, now we'll have to assign this to another variable to print out that resulting one. So print, so you see it has sorted it by alphabetically, D, H, S, and T. Okay? So that's also another thing we can do inside of a list. Remember, the reason why we're doing all this is just for you to understand. Then we're going to do patient's condition dot copy. We could do dot copy, that works. Dot copy. What we mean by dot copy now maybe is I'm saying new list here is equals to maybe patient dot copy. Then if I print new list, of course, it's still going to give me that one. So that's what dot copy means. So it's not really something too serious, right? So dot count, of course. No, that's not how we do. So look at what I'm going to do now. So we're not using dot count. No need for that. So we could insert pop and if we pop, it removes the last one. All right. So it starts from the last one. And what are other things? So they're just basically edit everything that we're going to do. We just want to do what is relevant for us. So we could reverse the list. And let me just kind of print that. Okay, so we reversed the list, right? Remember, we removed this. We did remove what's this stuff. So let me just kind of see if we can print that. None. Okay, so none is actually inside of that. I think we're actually kind of removing everything from there. And a lot. Just understand that we can insert, right? We could insert, we could actually insert, we could mutate, that's change positions, -1 should be whatever thing, anything, right? So these are actually list operations. That's some of the methods we could do in the list. And also, we could also, let me show you also another we could do. We could also perform arithmetic operations there. Could do this times 2. And then let me show you what the final list disease condition is. So this is what it is. Remember, we reversed it, right? That means we turned it upside down. So I could do this plus this. Let's see what happens. So it adds this, like it kind of doubles the list, right? So I could say combined, I could assign a variable to that combined, no, let me call it doubled double diseases is going to be this, and I think I've already assigned that. So if I do double print double diseases, of course, you're going to have that. Now, we can also perform some arithmetic operations. We could say print double diseases times 4. So it's going to multiply everything into 4. But this is not really so nice, particularly in terms of when we're going to be working with NumPy arrays, right? Because we might have, let's say, for example, now we have something like names. Let's say, for example, we have items, right? And then we have something like 1, 2, 2, something like this, right? And we see something like items, because this is a list, times 2, print items. Now, we might, well, what's that? Items times 2, print items, and it's still giving me items. Okay, okay, double equals to this, double. All right, it's good. So now you say in this kind of case right now, okay, we might want to say, okay, we want to multiply this to see that list actually really performing very poorly in terms of that. So we can go on and on and on and on to talk about lists, but just kind of have it in mind that you're going to be working with several lists. It can hold several data structures at the same time. You can also use what we call the list method to change something into a list. Maybe you're returning a JSON file or whatever thing, and then you might want to convert it to a list and then maybe use some of the list methods or operations to handle it. But just basically me telling you some of what is possible whenever you are working with a list, or maybe you're performing some kind of list operations in Python. Okay, so now, so guys, that's actually that for list. Let's look at sets, right? No, not set now. Maybe we could look at tuples. Why do we actually look at tuples? Now, the reason why we look at tuples is because of the fact that there were tuples. These are actually data structures. So I'm just going to kind of put this here. That are what? Immutable, right? So it means that you can't change them. You can't change it. And excuse me. So you can't change it. You can't change it, and they are used to store. We use it to store some kind of maybe permanent maybe data that would not change. That would not change. So think about it as maybe you're doing something on maybe fruits, or let's say coordinates, right? For example, that we're trying to do a GPS coordinates, right? In a health survey, and then we might want to save that as maybe, remember we use the bracket, and then we say 4.555, that's to the west, and this is 5.63 something to the north. So it means that this is not going to change. We can loop over it. We're going to come to that. We'll come to loops. But I just want to kind of hurriedly talk about all of this so that when we talk about loops, conditionals, and all of that, it's something that will make a lot of sense, all right? So actually that's, guys, you could just check out this, maybe maybe I can add another thing to the south or something. Maybe just a random number of 1.77 some stuff, and then maybe it's a GPS. Maybe just kind of add them to the east, 9.3 something, okay? Now, so when we say GPS coordinates, first of all, we're gonna print type of GPS coordinates. So that's going to tell you is of the class tuple. And so what actually to solve the attributes here? So we also have methods in this tuple. I can't do something like GPS coordinates of maybe 0 and then assign it to maybe 7 point something something, right? It cannot work because it will tell you that tuple does not support assignment operator. But I could check what that is. I could check what that particular one is. So I'm going to call this accessing tuple items. Okay, so when we get to machine learning, definitely we're going to see all of these. I could also check this second one, GPS coordinates of 1. And probably I could wrap this with print function. I could also wrap this with the print function here. I could also wrap this with print function, GPS stuff of 2. Now, what happens if I try to wrap something outside of the coordinates? To get Python, just GPS coordinate, or maybe 7. Like what happens? It throws up an error because it runs the first 3, but it takes this out of range. Okay, I don't have up to 7 items out there, so I'm just going to take this out. That's it. So this is actually how we access objects, items inside of a tuple as a data structure. Okay, and yeah, you could also do some more, but just have an idea of what this is all about. Okay, so I think that's just it. Okay. Uh, it can also work if you check from the back, -1. Of course, that's also going to work. It works. So, but just just kind of a refresher, okay, for you to have, just an idea of what it talks about. All right. Okay, guys. So that's actually that for tuples at this stage now. So let's check out if there are methods of what we could do with tuples, maybe some kind of dot. So we could count, we could check the index, but we can't iterate over it. We can't change stuff. We could still loop over it. I might just want to kind of go advanced a bit for x in GPS coordinates, print x. Of course, we could iterate over it, but we cannot change anything inside of it. We can't rearrange it. It is going to be the same way it is, all right? So that's actually one of what you could have here. So now remember, let me just show you something here now. You could have something like mangoes, mangoes species. No, let me just see something like, um, let's say, for example, health, health status report. So we have a tuple that has a positive, positive, negative. All right. All right. So now watch. If I print health status, so if I cannot print health, um, so if I cannot print health status, I'm just trying to know why this is. So it's going to print out all the unique elements, right? No, not sorry, not that. It's going to still print out everything that's inside of it, right? So I could just print length of health status, and that's 4, right? Yeah. So, but that's the much I can do inside of it. I can't really remove anything inside of it. I can access stuff, of course, sure, but we can't remove it. But now watch what happens. We have like 3 positives inside of this. So that's just kind of a refresher now of tuples in Python programming as a data structure for now. Of course, as time goes on, we might be jumping into some kind of advanced task. So let's look at sets as a data structure. Sets. So we talked about lists, and we talked about tuples. Now we have sets. Now what do we mean by set? Now set is a data structure. Sets are data structures in Python that returns some sort of unique values, and it is unordered, right? It is unordered, and it only returns unique values. Now, let me show you what I mean by that. Now, let me say now, for example, now look at this last tuple here. Let me just kind of trick your brain now. Then I say new set is equals to, now let me say is equals to, so the set of health status. Okay, and then I can just print new set. Now, you see, it now returns only positive and negative. All right? So don't worry. Let me show you what sets are. I think that what I did now looks a bit advanced. Now, what are sets? They are what? They are data structures in Python that returns some sort of unique values, and it is unordered. Unordered, we stated it. Now, remember, when we did list and tuples, they have an order, right? There is something like a last item, there's something like a beginning item and all of that. But it's for set, let's say for example, we have conditions, and you have something like what do we use for sets? We use curly braces, right? Sick, healthy, crazy, mad, awake. Now, and then maybe I have something like awake, and then maybe sick. Let's just use one type, sick, mad. Now, what was going to happen here now? So if I print conditions, now what happens? First of all, two things has happened here. Initially here, we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 items, right? Now, but when we now print the set now to get our set, how many do we have? 1, 2, 3, 4, 5. So what happened? It removed every duplicate. So it's going to only return unique values inside of it. Is that clear? So that's the same thing that actually happened here, where we had length, positive, positive, negative. But when we now move this thing into a set, it will only give you negative and positive. And this is something that is very useful in machine learning. Sometimes when maybe we're trying to, a patient now is asked to fill a data form, and then they're entering something like maybe yes, no, no, none, and then we now use some stuff like maybe pandas to now change some values now into let's say for example, everybody that ticked none and also no is now no. You see that we have double no, but now we need to only one. So we need to pass that particular part, maybe we'll call it a data frame. We don't call it a data frame. That's what we call it, right? We have data frame, and then if it is one list, one particular list, we have to now convert it, to a set. More like just to make sure we have only one item and not duplicate. So that's what set as a data structure does. All right. So is immutable, of course, is mutable. It is mutable. You can change stuff, but it is only going to return holds unique values, and it's unordered. So the first thing we saw here that it returned uh, unique values. And now it didn't just even stay at the same arrangement. He scattered everything. Crazy is now in front. Sick is now second. Mad is now third. Held is now fourth. Like everything is just scattered. Awake is now the last. So what does it mean? What it means is that what we can assess items based on position. Nothing like this, right? Is what because it's subscriptable. We can't assess items, based on indexing because of what it's really unordered, right? But of course, we can assess the length of condition. We can, of course, that's going to give us five. So this is what it is, right? That's sieve that, all of those, right? We can assess the length, sure, to assess the length of the set, right? We can, we can we can also assess the length. We can add, of course, we could do something like conditions dot. Now, you see, we could update, right? And then let's maybe kind of say conditions dot. We could add, let me just add maybe Jones Sal, and I'm going to say conditions. So let me just print conditions. And I see Jones Sal has been added. And then what do you notice here? The next time you run it again, print conditions. Okay. You could just want to remove, let me just say print conditions dot remove, you can dot pop, of course, remove howdy, howdy. Okay, so we have to print conditions. Okay, I think I didn't spell that correctly. Okay, what is it? Conditions dot remove. Are you sure this is just print? Okay, let's go and print conditions. Okay, so that's removed already. Then we could print conditions.pop is going to remove the last item. Okay, first one, okay. So print conditions. So that's it. So conditions. Okay, so we could say print conditions dot clear. Each time you're calling a method, you must make sure you add this curly braces because that's what we use in calling a method, right? So we say conditions, empty set, nothing is inside it again. So that is what we do for set. So don't worry, when we start practicing how to use sets, of course, everything is going to really make a lot of sense. We could still also loop around it. We could say names today is equals to Chizaram, Michael, Cynthia, Obed, Patricia. So we could say names today. I forgot what I wanted to do. Okay, yeah, okay. So we wanted to loop around it. Say from asking names today, print X. of course, you see, syntax, it's to say that it's very unordered. It doesn't follow the same order. It kind of scatters everything. So yeah, you could just iterate over it. And all right, so that's actually for sets right now as data structure. So let's look at dictionaries before we get into our notes real quick, just for us to, just have some information before we start checking out what is inside of it. And we're going to check out dictionaries. So what are dictionaries? So dictionaries is a data structure in Python that is mutable. It contains key value pairs and a lot of operations can be performed on it. Now, don't worry, guys. Some of what I talk about, some of these data structures, I'll definitely come back to it, particularly when we walk around the slides, but just kind of to give us some insights of what we are doing, right? So what do I have as a dictionary? So I'm going to have something like data set is going to be now use curly braces. Now, there are rules here. There are keys. Remember, dictionary contains what we call keys and values. Okay? Okay, I think I'm typing on the wrong cell. I'm still on the markdown. So I'm going to delete this and open a code folder. So it contains what we call keys and values, right? So what do we mean by keys? So by keys, we mean here we can say, okay, dictionary, right? So this is a dictionary. How do we confirm that? Say print. Let's know what this type of data set. Okay, that's a dictionary. All right, so now what we are going to do right now is, so we're going to put in our keys and values. All right. So what are keys? So name. So it's because David. So that's a string. So of course it takes that. Age 27, and then so you take a comma. Now remember we are separating with colon, right? And then I'm gonna say school Harvard score scored high, true. And just to know, okay, there's no comma here. And also, what else can we talk about? Status, negative. I think I could just use a camel case here. Maybe I'm going to say disease status. Yeah, negative. All right, so also, guys, we could also have like exam, something like exam score, just so you know that a dictionary can also take in a list 67, 80. I don't like that. It's also 77, 89, 81, 88, 92. So just so you know, right? And it can also take in a dictionary inside of it. So that's a comma and that's it. Okay? And then position, BMI, and it's going to be maybe, I don't even really know this stuff, 26 or, and then I doubt, maybe probably 26. Okay, that's a good score, 26.8. Now, see, basically here now, you see that a lot of, so this is what we call a dictionary, right? So we could have a list of dictionary. You see, I could fold that. If I press here, I could fold it. And of course, I could decide to fold it, okay? Now, this is what we can have a list of dictionary, a list that contains dictionaries. We could also have a dictionary that contains what? Dictionaries. Because instead of the dictionary, I could have a key, and then instead of that key comes a dictionary. Maybe I could say uh, score, maybe details. No, it must be wrapped in code, and then I'll now have the dictionary here and all of that. It works, okay? Details here, I could say maybe I could say something like maybe high, or maybe whatever, or details 99, or maybe overall score. Let me just put this as overall score 99. Now, this is what we call what? A dictionary. Now, remember, the last one we did was we did for uh tuple set and all of that. Okay. So what can we do in this dictionary? Now, first of all, it contains key values. What are the keys? Name, age, school, and all that. How do you access the keys? To access the keys, we say data set, so we call the object dot keys. So let me just kind of print that. Print. So it's going to give me the keys. So the keys are name, age, school, scored high, this is status, and all of that. So this is a method that we're using assessing the what? The keys inside the dictionary. Okay? So that's it. So to access the values, only, and I'm just going to put something here. I'm going to say dictionary keys. So let me just copy this, not to waste some time. Values. So we use dot values, and that's it. It's going to give us dictionary values 27, 27, David 27, Harvard, true, negative, and then that list. All right, so that's actually that for dictionary, okay? Excuse me. Now, the next thing we can do right here is we can decide. So we could decide to say, okay, since we actually have we have our keys, and then of course we have our values. Now, can we change stuffs inside here? Of course we can. We can add, we can change, we can remove, we can subtract, we can minus. In short, dictionary is so porous that a lot of things can happen inside of it. So we could say data set. Now we have what we call, in assessing dictionary properties. We have methods, we have our approach. So let me just call it this way. Let me say approach to assessing dictionary properties. Okay. Remember, I showed you the dot keys. Dot keys. That this is for the keys. For the keys. Excuse me. Let me come up. Then I showed you the dot values. This is for the values. And then now we have what we call the dot notation, of what we call the dot notation. And then we have what we call the bracket notation. Okay. Now let me show you what that means now. Now let's say data set, I want to access this particular like the name, right? So two things are there. Let's say, for example, now if you look at the disease status, now let me remove it. Now let me keep a space here and run it. Of course, that's going to work. But normally we know that it's ideal to use the camel case or snake case. So, but if I do something like maybe data set dot uh, dot name, right? If I print it, if I say print the data set dot name, what's that? Was it not name that we used? Okay. Okay, so watch. If I print data set name, now good, it gives me what? David. Now this is what we call the what? The bracket. This is what we call the what? The bracket notation. What's the issue with this? The bracket what? Notation. Now we could also do something like print data set dot um dot age. It's supposed to work. So this has no attribute age. Okay, all right. So that's no method age. But this is something that is really applicable most times in JavaScript. Like we do them in JavaScript. We could use the bracket notation. So, but then you can just continue to access your object using the bracket notation and all of that. You know, you could see dot age. No, not that. Data set age. Right? Of course. What's the issue now? It's not subscriptable. Okay, I made a mistake here. All right, so 27. So that's it. So that you could see how we're assessing objects, right? Now let me just show you something we can do. Now we could decide to mutate this particular dictionary. I can try to remove this, right? And let me just show you something I can do. I can try to change David, now change the name to somebody else and reduce the age. So let me say, I could say uh, new data set of name is not going to be equals to Cynthia, and then data set of age is going to be 20. Print data set. All right, so you see that name is now Cynthia, age is now 20. Now let's say I want to also add another new key and value, right? So I want to add something else here after overall score. So I could say data set. Then what do I want to add? So I want to add cycle, academic cycle. Then I'm going to set it as Hamatan. Print data set. Now we'll check. So you see academic cycle has been added to Hamatan. So guys, like I just want to tell you that there are a lot of things you could do inside of dictionaries. We could decide to remove the last one. So I'm going to say data set dot dot. Okay, so we use the dot to check out the methods. So dot. Just show you we could clear, we could copy, we could pop item, we could like a lot of things we can do, right? So we could check the keys, we could pop an item. Let's pop C, expected one param argument. So maybe we could say name Cynthia. So that's it. Yeah. Of course, maybe if I kind of come here now and I print that set again, you see that is out, Cynthia is out. And I'm going to say data set dot pop item. maybe one. Sorry, I made a mistake there. So it's going to remove pop item. It's going to take out the last one. And maybe I'm going to say, I'll say last item. I've already overwritten that last item now. So that is now going to be overall score. It's going to throw, okay, pop item is this. Print last item. Okay, that's still BMI because immediately I ran it again, it removed this overall score. That's why the last one now is this. So the more I continue to run it, it continues to take it out. It takes out the last one, and then it takes it out. Watch till the list is empty. And that's it. Okay, the dictionary is empty. So it continues to remove that, okay? Okay, so I was just going to run that again, just so we have our everything intact. And I think we could probably cut up with an error somewhere. Okay, okay. All right, guys, I think that is just basically what you need to know. For now, remember, I can run that again. Okay, the list is empty now. And let me just run it again. Just to make sure that the list is no longer empty. Still empty. So I'm going to restart my kernel. I want to work with that list. So I'm just going to give it some time and all of that. So there are actually a lot of things we could do inside of a list. We could loop around it. So the next thing we're going to be looking at now is we're going to just go straight into more kind of data structures and then get some explanations. And that's it. So let me run that again. Just to be sure. Okay, so this is where we are having that error. Okay. Okay, so I just want to kind of oh, just to make sure I have that. All right, uh, so my dictionary is back. Okay, so guys, I think those are actually that for now. Let's kind of go back to what we have. And yeah, just to have some clarity in understanding. Okay, so we'll still come back to all of that. So we have what we call loops and control flow statements in in Python. Repetition, of course, is really very important, but we don't want to also always be inside of the copy and paste trap, right? Whenever we are working, and that's why its loops are really very important, much more very fundamental in helping us avoid the trap of, having to repeat something over and again and again and again, right? So basically something we might want to be repeating again and again. We could just, we could just kind of just wrap it inside of a loop and then it runs that several times for us, like without having us to repeat it again. Like this is something we're going to be doing, severally in our practice here. So, here, I've actually explained all of this, but I just want to have us go through some of these slides to have, some much more clarity in understanding what I'm talking about. So there's something called the for loop, all right? So the for loop is definitive. It has a definitive iteration. So now the first item here is where to start with, and then this is where to stop. So we'll have start, stop, and then step. If you add anything here, it's going to run. But by default, the step is 1. So unless we decide to maybe override it, that's default parameter. All right. So that's actually that. So this is the first type of loop that you're going to you're just going to come in contact with, okay? So there could be a defined range of items, and then you just want to kind of loop around or iterate over that sequence for that particular time period. So let's say, for example, here, and maybe I'm just going to show you what I want to do. For example, let me just pull this up a bit. So loops. So what do we mean by loops now? So yeah, we're talking about the for loop, right? For loop. So let's understand what loops mean. So loops helps us to minimize the number of times we want to execute a given computer program manually, right? It helps to checkmate repetition of what's code, and gives us that access to to execute multiple to execute tasks that will require multiple time to be done, but done in less line of code. So yeah, I know my division might kind of might just be so layman-ish, right? I don't want to speak big English. Just what is it all about? Loops. It's just instead of us having to write print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Take for example now, maybe I'm looking at the for loop and I want to print. They ask me print 10 numbers. I print 1, print 2, print 3, print 4, print 5, print 6, print 7, print 8, print 9, and print 10. Now watch. So you see what it took me to print all these numbers. But this is something I could have written for I in range of. Now what's I? Now I can be anything, right? So this is just going to store, it's going to be used to store, the value when it's going to be iterating. So it's more like because this function is going to end with colon, right? So anything you're going to be passing inside of here now, right? The number of times it's going to be iterating now That's what I is used to store, right? So for I, anything, it could be for clothes in the market, in the market, in range of 10. Now, if I want it to be like this now, I'm just going to say to in 11, right? Okay. Then I'm going to now say, no, in 10, let's leave it as 10. Then I'm not going to say print clothes in the market plus 1. That's it. So it can be anything. So not only when you see an I and all of that, it can be anything, right? So it could be for Tinubu in range, for Tinubu in 10 or range, for Tinubu. So if you're watching this video from maybe somewhere, not maybe Nigeria or something, just kind of know that this is a variable that is going to be in range of 8, right? And that's it. So this is what I'm just gonna call this. Just gonna wrap something here. I'm gonna call this year, year one, year two, year three, year four. I think this is where we are at as of the time of recording this video. If you're watching this video in the future, as of the time of recording this video, this is where we are. We are in between 4 and 5. So that's where we are. We are somewhere here at the center at the time of recording this video. So there are tendencies for this loop to continue to iterate unless there is a break statement from a proper, anybody, whatever, anybody. So, but that's just what it is. So for table in range of 8, now you could ask some, I could decide to say, store this as a variable here rather. I could say, I could just say something like maybe tenure is equals to 8. Tenure is equals to 8. So in range of now tenure, okay, of course, it's still going to give me the same thing because this is now a variable that is holding the number 8. So I will now carry that. If I put that variable there, this range will open it up. What's inside your 8? And then to now iterate, ye Tinubu 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 3. Now, because you might be wondering why, if I remove this thing here, you have 0, 1, 2, 3. So instead of, because this is going to start from 0, I'll just give it plus 1. Okay, so that I will not have 0 as an index. All right, so that's why you might see something like I plus 1, or maybe I, and all of that. It's still the same thing, and everything works out. So this is actually what we need to understand about range. Now, tenure starts from, this is the tenure, right? So, but how about I want to do something like maybe for I in range, and then maybe I just want something like maybe start from year 2, stop at 10, and then count by 2. Print I plus 1. No need to even put I plus 1, just start from 2. So start from 2, 4, 6, 8. So that's second year, his fourth year in office, his 16th in office, and his 8th year in office. Right? So we are going by index of 2. So this 2 here means the step. If you remove this index here, by default, it becomes 1. So it goes start from 2 and stops at 10. But it's not going to count 10. Let's do something like maybe I plus 1 and all of that. So it's 3. So that 2 starts from now, takes in plus 1 and all of that. Okay? If I run this again, and of course, everything returns back to normal. All right. So, but it can only take a maximum of 3 arguments, 3 parameters. So this is what we call what parameters. Now I'm going to explain that right now. So in programming, anytime we pass a method, right? You know when we used to say dot pop, when we are saying maybe something like dot, I think this is the wrong. So remember, whenever we say dot pop, dot list whatever thing. We have dot clear, right? We have dot add. Now just understand that inside of these places now, they are expected to take a parameter. Although not all do take a parameter. Like for clear, it doesn't take any parameter, right? It does not take any parameter inside of it. Automatically, once you trigger this method, it will clear everything in the list. You don't need to add any parameter inside it. Okay? So, but some of them needs to take a parameter. So for the range function, it can only take a maximum of 3 parameters. And that is why I'm going to be talking about default parameters, what we call default parameters. We're going to be looking at that in functions when we start creating our own functions. So that we will now be able to now see how so many of these things actually truly work. But at the meantime here, what you just need to know is that what? Once you just put the dot to call the method, it takes in what? It doesn't take in any parameter. All right? It doesn't, the dot clear doesn't take any parameter, but then other ones do take. Dot pop likely doesn't take any parameter. So here now, what are parameters? These are some of the arguments that it can take. You can tell it starts from 2 and stop at 20, stop at 50. That's okay. So the default here now is going to be 1. It's going to be moving based on 1. If I say move by 10, it's not going to move by what? 2. The next, if you add 10 here is 12. If you add 10 here is 42. 22, add 10, 42. If you add 10 here is 52 to pass, so it will stop here. Okay? So that's what we call what? Range. So that's it. So it works in range 0 to 4, 1 to 6. It doesn't take what? Part one. Like it doesn't take more than 3 arguments. But if you don't put the last argument, there's what we call default parameters. We'll talk about that somewhere when we create our own functions. So we have what we call the while loops, right? So we're going to create a game right now to just make it, synchronize everything, get into your brain, right? So it's actually a condition that runs until a given condition becomes false. So that's why sometimes we can jump into an infinite loop. All right. So we have what we call what? A while loop. We have what we call it? A while loop. So what does the while loop do? So what basically the while loop does is that what? Let me just show you what I'm talking about. It runs until a condition becomes what? False. Right? So it's ideal for user input and all that. So let me just kind of show you something right now. Before we look at while loops, right? We need to understand how we can iterate over a sequence, which I've done several times. So for this for loop, we could have something like maybe conditions. Okay, we've cleared it. We have this is good. Okay, so say for X in diseases. So this can be anything. Usually we'll say for disease, singular in diseases, right? Print disease. Now, usually that's what we do. So this is also another type of for loop, right? Where we iterate over a sequence. Please note this, very, very important. Another type of for loop where we do what? Where we iterate over a given what? Sequence. All right, so that's actually going to be that for now, right? So for that, for diseases, right? So now the next one is we're going to be looking at while loops, right? So what do you mean by while loops? So while loops runs until a given condition is true, right? Sorry, until a given condition becomes what? False, rather. Okay. So let's say, for example, let's say, for example, now, let's go to our this thing. So I'm going to create a file here. I'm going to call it loops.py. Okay. So I'm going to say, let's say password is equals to maybe David 1234. And then I'm going to say, why password, why, why true, no, let's use for why, password, let me just see here, password. Why code is not equals to password. And so I might just say maybe the count is equals to 0. Okay, and because we're going to be counting this. So what's going to be our password here? Let's just kind of create a game for now. Let's just understand this while true maybe no, I'm not going to use while true. So while password is not equal to, okay, let's just put this here. Maybe, excuse me, David 1234. Now remember, we'll put a colon here because it's a function. And so, okay, look at what we're going to do now. We'll pick this and put it here. This is what the password is. So while trial is less than 6, okay, we're going to say um, enter password we say code is equals to password is equals to, for example, we'll say is going to be int. Okay, no, we have numbers here. Okay, we could want to use, no, let's not use, let's a string of say input, because we want to create a game. So we say input, enter your password. Okay. And I just want to do it in a way that we all understand. So count, now watch. So while trial is less than 6, right? Code is equals to, please enter your password. If code is equals to password, right? Then, of course, break. So we'll now print, welcome to this, welcome to Nokia World. All right, so that's it. If code is this, okay. I think the break is going to be here. Else, try again later. So let's see, let's just try. And my count is greater or equal to 6. So we say count plus equals to 1. Don't worry, I'm going to explain. So you could just say this is equals to count is equals to count plus 1 less than, why count is less than 6. So count starts from 0 and then we run it. Okay, this is why count is, while our count is equal to 6, code is equals to string enter your password. If code is equal to password, print welcome to Nokia what? Else break. Then break, okay? Then it goes out and then so we say print, thank you for trying. Okay, so that's always going to be the last term. Welcome to Nokia word. Okay, so if count is equals to 4, so print, so we're just kind of creating a game. So whenever the count gets to 4, when the person is trying to unlock the phone, so we'll say you have one, you have 2 trials left. 2 trials left. Now, if the count is not equal to 6, print, thank you for trying. You have been blocked. All right, so that's it. So now, first of all, why now count is at 0 here, and then y count is less than 6. So this is the password. So what is the while loop now? So the while loop is going to be continue to run. Now this is kind of a while loop that has, it's not really nested, but let's see what happens here. So code is going to be string, enter your password. So, but now we'll now check this condition. If this code, this person entered here now, is equal to that is equal to now, is equality now, is equal to this password that we stored universally here. Then welcome to the world, it will break out, and that's the end of the program. But else, please try again later. Count plus equals to 1, it will go back. Count equals to count plus 1. To go back, count is still less than 6. Of course, that's going to run. And like that, it will continue to run till it gets to 6. All right, so let's run. So enter your password. So I'm going to enter rubbish. Try again later. Enter your password. Now what happens now when I run it now? Watch, we're using the while loop now. So the while loop is running, right? So what happened is I entered the wrong password. It was not equal to it. So it said try again later. So 1 has been added to this count. So this is 1. All right. So let me just kind of raise this up. Okay, hold on. Let me just reduce this so that. And so I'm just going to kind of drag this up. So enter your password. I'll enter. What's that? Okay, let me start it again. So enter your password. I'll enter rubbish. Try again later. Enter your password. I'll enter another rubbish. Enter your password. Enter your password again. Now it will tell me that you have 2 trials left, which is here now. So count is now equals to 1, 2, 3, 4, right? So count plus 1. I wanted to use count plus equal to 1, but I didn't want to confuse anybody, right? So count keeps on going. So enter a password, enter another rubbish again. Try again later. Now this is the last one. If I enter any rubbish now, that means this is what happens in your phone when in short, this is what is built in with your phone, right? Whenever somebody is trying your password, this is the way the logic is being written. It's written most of the time. It's written. This is exactly how the logic is being written in banks. So when I now enter a wrong password here, try again later. Thank you for trying. You have been blocked. So, okay, now it's asking me to enter my password again because I should have put a break statement here. Okay, so that break statement now means that it will take me out of the program. It will take me out of this loop. Right. And this is one of the problems with while because if you don't put it, if you don't put this break statements appropriately, it will continue to run, right? So imagine I have been blocked here. Imagine you're asked, because machine learning is going to teach you software engineering very well. So imagine you're asked to design this system now, and then you now forget to put a break statement here because you have vibe coding and you are not understanding how the code works. So you see that you're not giving the client access again to enter again. So that's why here now let's run it again. Now let's start afresh to see if we're going to encounter that challenge again. So I'm going to run it. So enter your password. Wrong, wrong, wrong. 2 trials were wrong, wrong. And that's it. So you have been blocked. So they've now blocked me. So it will now return a server API to the users that this person's phones was stolen, and that's the end. So this is just basically how while loops works. We just kind of created a mini game, a mini project using a while loop. All right. So, but what about if I'm to get it right? Let's try to get it right. Let me delete this stuff. Let's try to get it right somehow. So, wrong now, wrong, wrong, wrong. Now let me get it right. David, 1, 2, 3, 4. You see, welcome to Nokia World. So it now takes me out to the next part of the program. I was not blocked. So if I did not put this break statement here, it will have to ask me to continue to try again and all of that. All right. So this is just kind of a practice of how we use, while loop. There are actually many other ones we could do, like, right? Maybe let's use the while true. Maybe, for example, so so let me just kind of use the while true. I just want you guys to see this properly. So for example, I'm going to say maybe password is equals to nothing, empty, nothing is inside this place. So I'm saying while true. So we use while true many a times when we have a loop that we want it to continue to repeat itself. So we don't say while true, we say name is equals to string. I'm going to say string input, enter your name. And then I'm going to say age is going to be string, no, int now. So we're going to impute, say enter your age. And then now we're going to say password, passkey. Then I'm going to say int. No, the one is an int now. So we're going to say, okay, int, no, so impute, register the password. Okay, so I'm just trying to make out something. I don't know what I'm thinking about right now. So if our name, okay, maybe we cannot say register a password, and let's say, for example, we say passkey, new passkey is equals to impute. We say enter your password again, and say if passkey is equals to new passkey, print welcome to this program. So I'm just going to use like a kind of an F string here to say, just to wrap that name, because that name is already stored in a variable name. And then, of course, we'll say break. Now, what will happen here now is to say else, print password does not match, does not match, does not match. Kindly enter correct password. Uh, let's put the person's name here so that they, this, they'll tell you your name. You say, David, your password does not match. So name. So remember, we use a format specifier. Remember, we do that with a format specifier. So what do we need this for now, right now? We don't really do this. It doesn't work anywhere right now. So we just kind of delete this, right? So we're just using a while loop now. So what will happen here now is this. This condition, once it becomes true, it will break this loop. Or else we will continue to enter our password till it match, right? So this is just kind of a password game. No, not a game anyway. A uh, password app. Just call it anything you want to call it, right? So we're going to run this now. Okay, let me just delete all of this. Just reduce this so that we can see my screen clearly. Okay, so let me just control backtick to bring up my terminal, and then I'm going to run it. So enter your name, David. Enter your age, 26. Enter your password, 123456. 123455. Enter your password again. I enter another rubbish. Invalid password. Okay, did I make a mistake in my name? Oh, I think so. I don't want to make a mistake. So control backtick. Uh, okay, I don't want to make any mistake this time. Is there anything I need to put? Blah, blah, blah. Okay. So, all right. So enter your name, David. Enter your age, 26. Enter your password, 123454. Enter your password, 123455. David, your password does not match because you have to kind of check spellings. Your password does not match. Kindly enter correct matching password to proceed. Okay, so that's it. So I'm going to save that again. Sorry about that. Let's cue this. So you press here, and that's how do I bring up my terminal? You can also click here, click on new terminal. That's also going to work. So I'll click on run. So you say enter your name, David, enter your age, 26, enter your password, W1234. Enter password again, W1234. Now, David, welcome to this program. Automatically, what the while loop does is that because I have satisfied that, it will automatically will use the break statement to do what? Break out of that loop. So that's why I have David, welcome to this program. And that's it. Okay? So we could continue to go on and on, but these are actually some kind of very familiar, easy examples that really help you guys just get in touch with while loops. But just basically, just understand that we might not really be working with it so many times, particularly when we get started with machine learning. But whenever we are building there's authentication part of our software or whatever, then of course, this is something that is really going to be very much important for us. Okay, so that's actually while loops in Python. Well, so loops control, break, continue, pass. I might not have really talked about some of these, but we still use continue. Sometimes, like I said, the break statement is we use it to skip, to get out of that particular loop. Continue is to skip. Let's take, for example, here, we have something like for maybe, let me just do something different now because I'm talking about the break. I've showed you how the break statement works. We use the break statement to come out of that loop, or else it can't bring us out. So how about what we call the continue, and also how about what we call the pass. So we use the pass most times whenever we create a function. Let's say, for example, we create a function and maybe we are not yet ready to add what we want to add. We could just say pass, or probably we are running a program and then there's some particular area that we really don't want that particular expression to perform an action. So we're asked it to do or to pass, to just leave that part and continue, right? So this is actually what we do. We usually do there, particularly in our break statement for pass. So let's say, for example, I said for maybe two in for underscore in I don't want to use, I'm just gonna use something in range, and then I'm gonna say 20, maybe go to start from 1 and stop at 19. And then if, now remember, I could see is if that if E is equal to maybe 3, 2, let's say for example, okay, let's come put the 5 break. Now watch. Okay. So if E is equals to 5, when it gets to that 5, break, then if E is equals to 5 break, and then we need to actually have a way to print E. So, and if it's equals to 5, break, and we could say print E. Okay, let's gonna take out this. Okay, all right, so what we'll do now is print E. Okay. If E is equals to 5, and okay, yeah. So break. So that's it. So it stops at 5. So what happens here is if I remove if I print E, if I uncomment this here now, right, if I kind of use comment to remove this now, start it to run, it will print to 18, right? So now I just want to show you how the break and continue statement works, right? So but here, if I kind of just take out this back and whenever it gets to 5, stop the program, break. But what happens if I say continue? And of course, let me just kill this because I don't need that. So watch what's going to happen here now. Once it gets to 5, once it gets to 5, what it will happen is it's going to skip 5 and continue to 6. All right? So let's just kind of see that real quick. Okay, and so I'm just going to run that, and that's it. What's happened now? So, mm, pass, and then also, let's say, for example, we step it at 2, take out this, and then run it. So we have this 9. So let's say here at 9. Nothing happens. Continue. Still run again. I'm trying to know what. And wait, if you hit 9, break. Okay, it stops. And so means that it continue and A. Okay, good. So what happens here now is it kind of stops it and then continues and then starts printing E again. So it omits the E at 9. 9. So what happens here now is that after the continue here, watch, this is where it's supposed to be for you to have that continue, and that's it. So watch what's gonna happen. Oh, I don't know why this thing keeps going down. So for if is this continue, so we can't put it before here, particularly for the continue statement, because already it has to pass through this, right? So everything is going to be running until when it gets to 9, then it will continue, skip it, and then continue to 11, and all of that. So that's how it works, all right? So it's fine. So for the pass, nothing happens. Pass, nothing happens. It just continues to move and all of that. So look at where pass is really going to be very notable. Let me show you where pass is going to be really notable now. Let's say I create a function and I say calculate age score, and then and I kind of go down and then I create another function. Watch. Let's say calculate. This is just an example real quick. Calculate BMI, and then of course it takes in some parameters. Maybe it takes in height, and takes in weight, of course, the height. And then I'm gonna say return weight over height squared. Now I try to print calculate BMI. This just kind of, I mean, I put 78, 1.9. Now it's not going to run because of this. So what I could do, maybe I could also pass, and of course that's going to work. So it's going to let me at least abandon this for now. We will come back to this. That's what it means. And then that's it. So this is just kind of a real quick example. Don't worry, we're definitely going to come to functions. So that is just that. And nested loops, of course, we could have nested multidimensional logic. We're going to be encountering this several times in Python programming. When we can, let me just show you what I'm talking about right now. So I'm going to use an example on nested loops now. So let's say nested loops. Remember, we did nested, right? We did nested conditionals. So for nested while loops rather, not nested loops. So this is what we could do. Let's say, for example, we have our children. We're going to be doing this so much, particularly when we'll be doing when we'll be using operating system for computer vision. So let's say, for example, now we have something like fruits. I'm going to use something, let me say new fruits. As maybe something like maybe mangoes, apple, and then maybe something like banana, and then pawpaw, and then also cereals. I don't know if that's a fruit. That's not a fruit actually. So what we could do now, we could have another list. Now watch. We could actually have another list now to say section is maybe uh for example we could say maybe usually we could have something like big and small. Let's say big and small. Now watch, we could have something like for fruit in new fruits. I'm going to call this thing fruit so that you guys can really sections. So it will be easier for you guys to understand and also practice well. Now I could now go inside again and loop again and say for section in sections. All right. Then I'm going to say print fruit. No, I'm going to say fruit because this is what is holding each of the individual item here. Fruit and just gonna say, what am I doing? Use a comma to separate that, and then you're gonna have a section. So this is going to give you a nested. So you have mangoes big, mangoes small, apples big, apples small, banana big, and down to cereals. All right. So what happens here now is how does this nested loop works? So all of this, right? This is going to iterate over this and then iterate over this. This one is not going to iterate over this. This is also going to iterate over this. This again inside of this inside of this, and this again inside of this and that. That's how it works. Okay. So that's what we mean by what nested for loops. It's something we are going to be using. Now, if I want to kind of go advanced slightly, let me show you what I'm talking about. So I'm going to import OS. And so OS means operating system. Don't worry, don't worry. I just want to show you how we do use that. So we could have something like categories here. For example, diseases. And let's say I want to create images for my neural network. Don't worry about what I want to do now, right? It kind of seems a bit advanced at this point. Now, I want to create folders here. I want to create folders. And you're going to see how we can use nested for loops to practicalize that. Now, essentially, what I'm going to do here is, now, you see, there's no folder in my computer here, right? So instead of me manually creating it now, I'm going to code the folder. So let's say I have, what am I going to put here now? Probably I'm going to say diseases of, actually, let me call it animals. Animals. Okay, so I'm going to call this cats. Cats. No, let's call it cats. Dog. Then I'm going to have horse. So categories here, I'm going to have something like my training. That's the folders where I'm going to keep pictures to use to train. I want to do something like a training. I want to get images for dogs, cats, and then divide it into the ones I'll use for training, the ones I'll use for testing, and then the ones I'm going to use for maybe something like validation, right? So let me kind of add something here. Maybe I'm going to add something like a cow. So of course, training, and then I want to have tests. Let's just leave it this way. Let's kind of throw the validation away. So what I'm going to do now is for, because I'm talking about for, next up for loops. So I'm going to say for animal in animals. Okay, I'm going to say for category in categories. Now, what I'm going to now say is that I'm going to say part. No, that's all I'm going to say. I'm going to say folder is going to be equals to os dot path dot join. Then I'm going to now pass in, what am I going to call these folders now? Data set, and then inside of it is going to be animal, and then I'm going to have category. Don't worry, don't worry. So I'm going to now say os dot make directory, and then okay, I think I just spelled that well. Os dot make directory. I'm sure I imported this dependency, but it's definitely going to work. And then I'm going to pass in folder, and then we'll have what are we going to put to say exist? Okay, equals to true, and just run it. Okay, good. So you see, we have cat. Inside of cat, we have train, right? We have train, we have test data set, we have cow, we have what do you call it? We have just look at how I nested the loops, and I kind of created like I nested the loops, and I created like some subfolder. All right. So you see how I've just kind of automatically done that. So if I want to kind of add images, right, to these, I could just maybe import numpy as np. Don't worry, this is just kind of advanced. Then I'm going to say here images, image is going to be np.random.randint, and then I'm going to pass in probably numbers from 0 to 255, and then it's going to take in so rows and 3 color channels, not three, and then np dot uint, is going to be the type, data type, d type is going to be equals to np dot uint8, and I think that's done. So we're going to say our path is going to be equals to path now is going to be os dot path dot join, and then we'll pass in our I'm just going to use an f string here. Then I'm going to see join the folder with the image. Okay, and we want to create images and add inside of it. It's a kind of difficult task, but not really. So we want to join the folders, and then I'm going to say okay, let's kind of use an f string here. And of course, so instead of the f string, we're going to say cat. Sure, let me just say folder, right? So that's the initial folder. And then I'm going to use an f string to say cat. No, what are we storing the folder? So we'll say animal, and then it's going to take in animal. Okay, let it be a dot png file. And how many animals? For maybe it's going to be how many pictures? Maybe let's say for I in range of maybe let's have 10 photos. All right, don't worry. This is just for you. Let's just kind of play around. And .png. What else are we gonna do? two decimals. 0 to two decimals. So that's it. So I think this is it. So the animal is being stored here. And then this is definitely going to be stored inside of this. And let's run that and see what happens. Okay, no, we're not done. Then we'll now say, hold on. I'm going to import CV2. So it's CV2, but I am right. Then passing our path and image. So print image successfully saved. Or D, what is D? Ooh, it's a mistake. This is where I was supposed to put this. Okay. So that's it. So image successfully saved. If we click on this, you see that we now have pictures inside of this. Okay. So this is just kind of a picture. But then we're supposed to be having so many pictures, not a range of 10. Okay, mp.here int and okay, yeah. So what we'll now do now is that you just kind of check out this. Now you see that we have some of those images kind of distributed inside of it, and that's just basically it. All right. So I don't really want to complicate this doc.png. If we want to add some some numbers there, we could do it. So I'm just trying to look at all of this so we don't really advance it so much, and then it becomes really very tough or tactical to understand. So this is just basically what I want you to understand here now is look at how, sorry. So you look at how we nested the for loops, right? So we have this, and then we have another for loop, and then we also have another for loop inside of this. And then of course, everything works out really well. At the end of it, we have our images and so don't worry about this. Don't worry. I'm definitely going to explain all of this. We'll get to all these points. But basically why I'm just shining this to your face now is just for you to see how to perform for nested nested loops. Okay, so guys, I think that is it. So there are some kind of patterns that begins to come up, searching, how to, how some data structures and some kind of algorithms, but these are really not something that are really going to be so important for us right now, because we're not really getting into data structures and our algorithms. But look at some common pitfalls there. Sometimes people make mistake in terms of the line. They get off by one errors. They don't really just out of the intention, they make mistakes. Just kind of look at how I kept everything neat, in terms of my own indentation, right? And something that is really very going to be very important for you. So the loop never starts. So once sometimes people can also make mistake, particularly in terms of how they configure the loops, and quite very important. So this is a game, here we've already played our own game. Guess the number, if not, guess dot is digit, and then enter a number, and of course that's it. So this is actually a game out there that I have actually created for you, just to make everything very easy for you and just, of course, ensure that you find very, very massive fun, inside of it. So now we're going, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is what we call list comprehension. We also have what we call dictionary comprehension as well. But for now, I think this is actually kind of very quick. So we have tuple unpacking, where you can have two lists and pack it, unpack it, and all of that. Let me just kind of show you what that is. And let's say, for example, it's mutable. We can X, Y, Z could be different lists, and then we put it into something else. Maybe it could be a tuple, and of course, right? These items here can also be a list. So there's actually that. So that's actually going to be that for our, for data structures. We are done with data structures and for loops. And of course, these are just information that are really very useful. So the next thing we're going to be going into right now is we are done with that. So we're going to be going into what we call functions. Functions in Python, right? So we're going to be looking at what? Functions in Pythons. So I'm just going to wrap this here and I'm going to say functions. So what's a function? So now I'm going to do this teaching in a way that it's really going to make a lot of sense. So the first thing I will always do is I'm going to explain terminologies. When I'm done explaining terminologies, then I will now, when I'm done explaining terminologies, I will now kind of, go through the slides so that everything is going to make a lot of sense, for you, all right? So this is actually what I'm going to be doing right now. I'm going to explain terminologies, and when I'm done explaining terminologies, I will now go through the slides so that a lot of things, a vast majority of things that I'm going to be talking about is going to make so much sense. So now, if I talk about functions now the first thing you need to understand is that what's a function? I'm just going to count. A function is actually a reusable block of code. So a function is a reusable block of code in programming. Now you're gonna see, we're gonna be performing a lot of wonderful stuffs here. And let me just kind of create a new file. I'm gonna call this, I didn't spell this correctly, but don't worry. Functions.py. Okay, so this is where I'm going to be performing some kind of functions practice for you guys, all right? Okay, so now okay, all right, so I think we're done with this. We're going to be moving into the next part of it, which is functions. So now let me show you something right quick, real quick here about functions. So here we're talking about what? Functions. So what do you mean by functions? So is anything that we can what? Reuse. So let's say, for example, we might have a code block here that says something like hello, or maybe any sort of stuff, hello. Now, what it means is that we can be able to reuse this function block, one, reuse this function block again, two, reuse this function block again, three. So let's say this is hello, precious, right? So we could use it in such a way that we say, hello, Cynthia. So we can say, hello, Morgan. We can say hello, princess. All right. So that's what basically a function does. Okay. So this is basically what we call reusable block of codes, right? So we can do a lot of things once we've created a function. So we're going to create several functions. Maybe we might create a function that calculates BMI. So we can create the functions that calculates age. Then we're going to also talk about what? Function parameters. We're going to talk about default params. So this is where we will get to understand how you know how parameters works, because mostly here whenever I'm talking about parameters, okay, it kind of scares so many people because some people now feel like talking about parameters is like maybe uh just so you know how what we mean by default and what we also mean by what normal what parameters. Okay. Okay. All right. So those are actually that. So what are we going to be doing straight up right now? I'm going to be showing you what functions are, and then of course I have some deep explanations about functions that I'm going to read you through. So let me just kind of give you a warm refresher on that, and then that's it. So like I said, usable block of code. So you could say something like, remember, let's say for example now I'm going to say name is equals to uh, for example, Chiamaka, for example, and I'm going to say class. No, we don't use class because that's a reserved keyword. So we say something like school class is equals to PhD. Let's say PhD. So I could say print something like it's an F string. I'll say hello. I'm going to say name. Congratulations on your class, on your new class, which is school class. Now, you see that this is becoming a problem because if I want to do for another person now, maybe let's say, for example, the person is in pre-nursery, I have to copy this thing again, right? And then, in short, this time around, so I have to even put another new name. I'll say, uh, new name. I'll call this person Morgan, and I'll say something like MSc. I'm going to say new name, and then I can run that. And see, hello, Morgan. You see that the line of codes here is so long. So this is where functions comes inside, right? So we have like how many lines? 1, 2, 3, 4, 5, 6, right? Almost 6 lines. Now, let's say I want to do for another person again. I'm going to say Ezigbo BSc. How many lines? 1, 2, 3, So this is kind of several lines of code. And so how many lines here? We have 9 lines of code. Just record that now. We have how many lines? 9 lines of code. Now let's kind of create a function that takes in people's name and congratulates them on their new class. So we're going to call that function. Now, how do we define a function? The first thing we define in a function is we use the def keyword. So we could call this congratulations. That's the name of this function. School checker. Let me just call it something shorter. Maybe call it school checker. And then the function is going to take in, it's going to take in name, okay? And then it's going to take in school class. Now remember, we're talking now, it's going to take in an indentation. We indent. If we want to pass, we could pass, but we're not passing now. So what is going to happen inside this function now? So we're going to say return an f string of for example, we could return what f string do you want to return? So I'm just going to copy this and paste it here. Okay, so you see, it takes in this parameter and it takes in. Now, you see, this is just 2 lines. So what this means now is that if we want to run this function now for Chiamaka, Morgan, and Ezigbo, so what we're going to do now is we're just going to say print school checker. No, yes, school checker. And then now this is what we call what? Parameters. We call this what? Function parameters. That's what we call this. We call them what? Function parameters. So by calling them function parameters, what it means is that these are some of the parameters that we use whenever we are creating a function. Okay? Any function that we want to reuse, several times, we have to pass in some kind of parameters. Then pass those parameters inside the function body. All right? That's the matching parameter now has to be inside of the function body. And then, of course, we can now, perform some action. So right now, so if I want to call this function now, because I returned it here, I'll have to print. If I printed it here, I'll just call the function ordinarily. So that is the rule. Don't worry. I'm going to do more examples. So this is going to make a lot of sense. So when I want to call this parameter now, I'm going to say name is going to be equal to now. The name is the function argument. I'm going to pass in an argument. What is this argument going to be? Name here could be what? David. And then what again? Then school class, which is another functional argument. This is what we call the what? The param name. That's the name of the parameters, right? So school name is going to be, the school class now is going to be MSC. Okay? So you see, that's it. So I'm done for David. I run it. It gives me hello David, congratulations on your new class, which is MSC. Now, if I cannot run that, I'm going to change this to PhD immediately. And I'm going to change this to Cynthia. And then I'm going to change this to John, BSc. Now you see that how many lines of code do I have? 1, 2, 3, 4, 5. Just 5 code. Under having 9 lines of code. And it means that I can reuse this function body anywhere, anytime, anybody. Now, ordinarily, I could decide to call this function here without ordinarily passing this name here. But the reason why I'm doing it is because as a beginner, you might just want to kind of have it. And you need to make sure that the parameter, the arguments is your person matches the sequence through which you did what? You created the what? The parameter. That's the argument here, John and BSC, which is the matching argument here name must come first before what this, or else it's going to make a mistake. Because Python doesn't really know that this one is the name or this, whatever thing you put there, that's what it will return. So if I just run this, it is still going to what? Work without me necessarily calling the function this thing. Now, what happens if I remove one here? And of course, come to this line here. And I run it here. Now, it returns a type error. Now, what is the type error? It says a school checker has a missing one requirement positional what? Argument. Okay? School checker is missing one required positional what? Argument, which is what? School class. Is that clear? So it means that there is a mismatch here. So it's expecting what? One more. What if I remove this one? Two positional arguments are missing. So I need to find a way to put something there. Maybe David, I could put Chioma and Masters. Okay? So that's it. I think that is actually going to be that for now, just for you to understand. There are actually some other common functions that you might get in a programming lesson. Someone might tell you greet and maybe greet, and they say that's a greet function. Maybe it's going to take in def. That's the define keywords. Of course, that's what it must always take inside the function. And then you might not pass a parameter that works. So we're going to print good afternoon, sir. Well, this is going to work. So if I call the function greet as many times as possible, V is not defined because I mistakenly passed that. So good afternoon, sir, good afternoon, sir, good afternoon, sir. All right? So as many times as possible. So I've saved this particular statement expression inside of this function. And that's why each time I call the function, it's going to run. So what about if I try to do greet and then I pass David? Now it's going to say that greet takes 0 positional argument because when the function was created, there was no positional argument that was passed inside of it, right? So that's why we need to do what we really need to make sure that if we have some parameters, passed inside of this, that number of parameters also matches our arguments, our positional argument. So I think I'm just going to comment that out, and I'm just going to say, just add a comment. I say this is wrong, okay? Because the positional argument must match the what? Must match the default, must match the what? Parameters, the earlier stated parameters. Okay, so that's actually going to be that for functions right now. So what again do we need to have very much awareness about? So the next one we must have to have some kind of sort of awareness of right now is that since I've actually kind of created this right now, I'm going to show you what default parameters are, right? So there might be a situation whereby we might not really want to pass 2 of them. So this is what it is. Now let's say I want to calculate my BMI, okay? Calculate BMI, okay? And then it takes in maybe weight, and it takes in height. And let's say the default height is 1.8, and okay, that's default human height by 1.6. So it's going to return we're going to say weight over, I'm just going to wrap this inside of it. This, for good practice, weight, uh, this is going to be weight all over height squared. And of course, it takes me out of there. And when I'm going to do, okay, when I do print, now calculate BMI, and then I pass in weight of 89.7. And what's going to happen here? Now, it worked. Why did it work? Because there's what we call a default parameter. This is a default parameter. Instead of this particular uh, argument here, or instead of this particular function, I added a default. So it means that even if the participants don't add a second argument here, you must pass in the weight because there is no default for weight. Weight is just given there. So it means that you must pass in something. So that's why it works, right? So this is what we call what? A default function parameter. Okay? So this is what we call a default what? Function parameter. So we can also override the default. We can override the default. The default, remember, this is what it falls back to. So how do you override it? By assigning something. So I could do print calculate BMI, then I'll pass in maybe something like 40. Now watch, without 40, we'll see what it will give me. And then we'll print calculate BMI with 40 and then 1.8. Now watch, you see, this is what we call, I'm going to now say this is what, this kind of say, default function result. Then I'm going to call this, the what? Overriding default function result. Default function result. So that's it. Just so you have an idea. So here now, I gave it a parameter. So what happens here now is that it will no longer choose this particular parameter that we have here. So it will overwrite it with this and then pass it inside of it, and that's it. Okay? So that's what we call what? Function. So remember when we actually demonstrated some stuffs here, we tell you that these are actually some function blocks that are reusable. And of course, we could reuse them as many times as possible. That is also that. Now, are there other things we can do in a function? Of course, we could also create something extensive before we now get into the slides, just to keep us very warm. Let's say, for example, I want to create a game. So I want to create a game, want to create a function. Want to use a function to create a game. So I want to use a function to create a security system. Now, we're going to be using this function several times, and understanding of this function is going to make everything really work out well for us. All right. So let's say we want to create a function to open open your, that's to unlock phone. So this function, now remember the naming convention will start with, unlock phone. So when you unlock the phone, pass, the next thing is going to be what? Uh, check, check, um, enter, register. Okay, first of all, it's going to register user, now pass. Then the next thing is going to do what? It's going to check your BMI. So we're trying to create an app. So it's going to check your BMI. And then the next one is now going to maybe not check BMI this time now. Could do something different. If you check health history, okay, and let me just kind of use this stuff here. And then what's the next thing? Just so that we can really, really grasp this. Then the next thing is going to play guessing game. Or play no ask questions. Ask further questions, right? So we're going to pass. So if I run this, of course, nothing happens. I'm just going to remove all of this, control backtick. Okay, so that's it. So we're going to start by creating a function that is going to create a security system. Then when we create that security system, after creating the security system, we'll now, once we're done creating the security system, we'll now register users, and then we'll now check their health history and then ask questions. Those are actually what we're going to do with this function, right? So the first thing I'm going to do right now is inside of this is, so what am I going to do right now? So we're going to say password. So to unlock the phone, we're going to say count is going to be equals to 0. Then, because it's still inside of this function, and then I'm going to say y count is less than, not is great, is less than or equals to 5. And then I'm going to say code, maybe password is equals to int. I'm going to say input. So please enter your password. And then we'll now say if password okay, we probably could just say passkey is equals to 1, 2, 3, 4, 5. And then the next one will now say if the password that you entered is equals to passkey break. First of all, it will print welcome. You have successfully unlocked the phone. So break. else. Now, what are we going to do now? Else, print wrong password. Kindly try again later. Okay. And then remember that's what it is. So name is equals to, we'll ask the username to put their name. We can ask them to please name is equals to string, so impute. Kindly enter your name. So if password is equals to passkey, print welcome, you have successfully unlocked the phone. Break, print wrong password, kindly try again later. And now, so after that, count is count plus equals to 1. And then we'll now say if count is equal to 4 or 3, print listen to me, my friend. You have 2 trials left. And then we could have a nested function. I'm going to come to that. And then I'm going to say if count is equals to 4, so say you have 1 trials left. If count is equals to 5, print you are done for now. You uh, you have been banned. Break. Okay. Okay. All right. So guys, and then so this is okay. So this is actually what is going to be. We define the function. Count is this. If count this is our password, y count is greater than or equal to 5. Give us your name. Then we'll tell the person, please, what's your name? First of all, tell us your name. And then we'll see name. Then if the password is this, we'll say welcome. Name. Break. Then print wrong password. Name. And of course, we are not count plus equals to 1. And then, of course, we break, and that's it. So the next thing that happens there, if the person calls that breaks, then it should enter into the next function. We loop into the next function. And I think we could have this as a universal stuff somewhere here. So maybe we could say something like define another function. So we call this basic details. It's going to take a name. It's not really going to take in anything for now. So let's just kind of have that. And return name. Then we could say something like age is equals to int. So say impute, enter your age as at your last birthday. And return name and age. All right, so guys, don't worry, this is my kind of seems slightly advanced. I just want to make it really very well. So break, and of course, we could continue. And so with my next, these functions. So we might have a nexted function. Okay, so we'll say register user. And then what I'm going to say here is we have some names. Just trying to think about how to position this now. So name is equals to this return name and all that. So okay, for now, let's not next it, right? Let's just keep it very simple so that it makes some sense for us. And so it's going to pass. So here we're going to say, okay, what's it going to take? So since that is there, we could just say, okay, here is going to be what's your name? So when we're done with that function, when the person has unlocked the phone, uh, this is and okay. So I just want to make the game a bit slightly complex. So we could call this security system. we call it security system. Okay, just kind of comment this out. We'll come back to it. We'll definitely come back to that. Let's just make it easier now. So the name is going to be what's the name? Can you enter your name again? Again, enter your age of last birthday. Uh, we'll say maternal. So what are we going to be using on location? Impute. Name. Maybe I think that's actually cool. Where do you live? And then, of course, register. What? Maybe you could ask questions of blood pressure. Okay. You could ask string of no float of input. Uh, what is your blood pressure? And then, so we could just put a format specifier there. Say name. So just say, and then of course, um, last checkup string of int string input. When was your last body checkup? Okay. And then so that's just basically it. This function is going to run all of this. So return name, age, location, blood pressure, last checkup, and then of course, okay, last checkup. Okay, so all right, so these are actually good practices. And then the next one we're going to do now is check history. I think both of these are actually same thing what we want to do. And so is there any other thing we might want to do? Let's just kind of run this for now, get started and see what we have. So here, okay, so now the next one we're going to do, we have to call the function, right? So you can't run without calling the function. So unlock phone will be the first function that will be called. And then before we now have to print before we have to print some sort of name. We don't have to print register user. So that's how it works. Okay, what's the issue? It says that name is not defined. Name is not defined. Oh, we cleaned that up. We removed it. So we'll start again. Main.py. Enter your name. So welcome to this BMI calculation. How did that work? Now watch. So I think this is the wrong. Okay. So what is your name? My name is David. David, please. And now watch what happens. So I put my name here. So this function now takes that name and stores it inside this place, right? And then that's how it works because this is a global variable. So it can be accessed here. Okay. So David, please enter your password. And I enter rubbish. It crashes my program. Oh, because of what? David, please enter your password. So it expected me to enter an int, but I think I did not enter an int. So we'll address all of this when we do our try and accept. So let's go again. Okay, so what's your name? My name is David. This, I'm going to enter numbers. Wrong password, try again later. Wrong password, try again later. Wrong password. Listen to me, my friend. You have 2 trials left. David, please enter your password again. You have 1 trials. You have been banned. Kindly enter your name again. Okay, so you see that we are done with this function, right? We are done. So, but this is now the second function now that is running. So I'm just going to kind of bring this up. So enter your name again. I'm going to enter Samuel this time. Welcome, Samuel. Can enter your age as of last birthday, 23. Where do you live? California. So what's your blood pressure? 34.2. What's the last checkup? So Samuel, California, this. Now, you see that we've kind of done something really very magnificent right now, okay? So what we want to do now is we want to do this thing now in such a way that if the first person, if the user crashes, if it crashes, all right, there is also opportunity for us to continue. But just kind of get, this is just like, just a kind of refresher to you about what a function looks like. And that's just it. So we're going to be performing other advanced functions, when we come back, and look at all of this. But that's just it for now, basically, for you to get started working with functions in Python. Okay? Okay, so guys, the next thing we're going to do right now is we're going to now look at our notes, just kind of giving us an understanding of what a function entails, what it means, and the direction it's kind of leads us into, particularly at this time, right? And really very useful. Okay, so what is function? So we're just going to kind of go through that right now. And just to let that. Okay, so just kind of present that. Okay. Okay, so I'm just going to scroll down a bit. Just to show us what I'm talking about, putting it much more in practice for a lot of things there to really make massive sense. So I just already explained is that it's a usable, block of code that performs a specific task. You write it once and you can use it as many times as you need anywhere in your program. Okay. So here you can see I am explaining here that you can imagine a hospital machine that takes a patient's blood sample and returns the diagnosis. Every new patient uses the same machine. You don't build a new one each time. That machine is your function. So that's just a kind of an analogy, right? So you just input your patient's blood sample, it runs the test and gives you the diagnosis return. There's no need of us creating new machines. So that's just an analogy of what a function is. So, but then the question is, why is function important? What makes it really very important for us? Now, the reason here is that, most times we don't want to repeat code. We don't want to repeat code. We want to just ensure that our code is really very, like we have more like we just want to make sure that we have a very neat code and not having to write so many logic all the time. So you can see how I demonstrated that in the practicals that I use right now. Okay, so this is just to make it much more easier for you to understand really well. So that's how we to work with functions. Okay, so you don't need to copy and paste same code 10 times and accidentally introduce bugs. You just need to set up the structure and everything is going to work. So we organize your code, you break big problems into small named pieces. Your code becomes readable like chapters in book instead of one giant paragraph. Every machine learning model uses functions to preprocess data, train models, evaluate accuracy, and make predictions. Functions are just like the machine learning code. So it's easier to debug. When something breaks, you fix it in one place, the function, instead of hunting through 50 lines of repeated code. So that's actually how that works. Okay, so just to drag this really well to make some sort of sense for us, uh, I just want to show you something like I already showed you uh, how the basic function syntax looks like. You don't really have to, you know, you don't really have to write code several times. Okay, just kind of initiate some sort of small short function, piece of function, and then it's not something that's not defined and it hasn't really run yet, like writing reciprocal cooking. Then you can now use it again and again. So def means define. You define the function. The keyword def tells Python, I'm about to describe a new function. Always starts with def. Then the greet here is the function name. So we have what we call the function name. So you see, when I did this now, I just want to tell you this is the function name, right? So you can choose the name, you can use something meaningful, anything you like. Greet tells anyone read the code exactly what it does. And then we have what we call the parenthesis, which is this. That's the function the parenthesis holds inputs. Okay, it's called parameters. For now, it can be empty because it means no input is needed right now. So unless maybe probably want to have some kind of input, and then of course, that's where you have to run or maybe passing some arguments and all of that. So for the indentation, the body, so that is the body, the function body. Now, I just want some people to understand something that in JavaScript, right, usually how you know the function body is that you can use a curly braces to wrap it, okay? And then where you make your expression, your argument or whatever thing can be the function. You can use something like your lower brackets to wrap that part. But basically, just what you need to understand here is that parenthesis is what you use in holding the input. It's called function. That's basically where you have the function parameter, whereas the indentation is the function body. The code that runs when you call it, we always indent with 4 spaces. Now, there's another we call calling the function. We have to always call the function, right? So what do we mean by calling the function? So a function does absolutely nothing until you call it. So you could just see what I did sometime here, when I was coding, uh, particularly in my practice notebook here, where some of the functions, even here as well, I didn't really call the function. Then when I finished, I just got, let's say for example, now I just removed this line, I'll comment it, and then I run it. Of course, let's see what's gonna happen. I run it, and it might ask me to enter my name because that name is not inside of a function. But the moment I take this name now and put it inside of this function here, and then run this again, and run it again, you see that it doesn't run, nothing does. Okay, because I have not called the function. But immediately I call the function, it asks me to enter my name. And that's where the whole business starts. So that's just basically what calling a function implies, or that's what it means. So a function does absolutely nothing until you call it. Writing a function is like writing a recipe. Calling it is just the actual cooking of the food. So we define it once, we call it many times, and that's it. So so this is just what it is, and of course, some of the steps you could use to write a function is to define a function. It reads and stores the information instructions. Nothing runs here. You call the greet function. The function Python finds the function, jumps inside and runs every line inside of the body, and then it prints and executes. hello appears on the screen and all of that. So that's just what it is, really very easy and simple. Now, so just kind of pardon my slides, just keeps moving so fast. So this is what we call functions with one parameter. So if you want a function to work without different inputs each time, that's exactly what parameters are for, right? So the code, what is what function with one parameter? Maybe for example here now you could just run this function, right? So you say print hello new. So what it means that each time we're going to call this function, we must have to pass a parameter here, right? So that's it. So this is how a function works. So understanding parameters is something that is really very imperative. The word name inside the parentheses is a parameter. It's a placeholder. When you call the function, you fill it in that placeholder with a real value. So hospital analogy is that the machine has a slot for a patient name. Every time a new patient arrives, you slide their name in. The machine does the rest automatically. That's why you can have hello David, hello Sarah, hello Dr. Smith. Okay, so guys, that is actually what that is. And we're going to look at how to call a function, with an argument. So I already told you guys this, right? So you can have an input versus an output. This is the function, and the parameter is the name listed inside of the function definition. So it's just like an empty slot labeled, put the name inside here. So what is the argument? The argument is just like saying, David, this is the actual value you pass in when calling. So it fills the slot at the moment of calling. That is what calling a function with an argument does. So anytime you're going to call a function, you must pass in the corresponding number of parameters inside of it. So, but what happens whenever we have multiple arguments, multiple parameters? Okay, which is what I'm going to be explaining right now. So functions can accept more than one input, okay, because they are usually separated by what? By comma. So this is where functions start feeling very powerful. So you can add two numbers. You can create a function that adds two numbers. Uh, of course, probably we might not have really performed some kind of arithmetic operations, for functions. If you look at something like this and maybe practice. So I think I'm just going to kind of close this. So let's say we're going to create a function that's mathematical operation, then it kind of takes in A, takes in B. Okay, so we're going to say return A plus B. So we're going to say mathematical operation. So print mathematical operation, then we're passing 40 plus 67. And that's it. So it gives you 1, 1, 2. So this is just some kind of mathematical operations that functions can actually perform. And so it defines the two slots A and B. So this is the first parameter. It's going to take this second parameter. You call with the two arguments. And then what happens is what is stated inside the function body happens, which is to add A and B. And then the functions computes and prints A plus B, which becomes 3 plus 5, which is printed. So in machine learning, functions frequently take multiple inputs, which is what we're going to be doing again and again. All right, so the next thing we're going to also be looking at right now, after we are done with some sort of multiple input, is the return statement. So what I mean by the return statement, this is one of the most important concepts of all Python. Understanding the difference between print and return will change how you think, which is what I actually talked about. So whenever we use the print, we just call the function, right? It's going to show it. We don't need to wrap it inside of a print function again. So the print function here displays the value on the screen for you to read. The value disappears after. So your program cannot use it. Like announcing a number loud. Once saved, it's gone. Whereas what does the return? So the return, what it does, it sends the value back to whoever called the function. So it can be stored. So it is passed to another function or used in a calculation. It's just like handing someone a physical object they can kick. So if you look at what I did here, let me just show you something. So you see that here, I kind of returned name, age, location, blood pressure, checkup. So that when I'm not, if as much as I printed it, right, it kind of returned this. I could decide to do something like this. A, B, C, D. How many is this? 1, 2, 3, 4, 5, right? B is equals to register user. Then I'm going to now say print A. And then, of course, it's going to run, it's going to be a long stuff here because we'll have to run the whole program, one by one before we get this. But just understand that it's going to give us, like, basically what we want to run here because if I come in and answer something like, maybe what's my password? I say 1, 2, 3, 4. Say 1, 2, 3, 4, 5. Okay, so what's my name again? I'm going to say David. I'm going to say what's your last birthday? So 27. Where do you live? Nigeria. Okay, and then body checkup. I don't really know. Last week. Okay. So that's why you're going to see that the function, what's going to happen here is, so it says print A. Okay. I just kind of call the function. So, but if I just say, okay, return this, it was not going to return this, right? Because I've already kind of asked it to print. So that's how we do. We can store these things inside of another variable and then use it. And this is what we're going to be doing many times in object-oriented programming. All right. So those are actually what you need to know. And it can return, send the value back to whoever called it. And of course, in machine learning, almost every function returns a value. And of course, those are what we're really going to be doing, okay? So let's kind of take a look at we're using return values slightly again. So once a function returns a value, you can capture it in a variable and do anything with it. You can store it, you could print it, you can use it in math, you could pass it to another function. Essentially, you could do a lot of things with it, okay? So you could capture a variable, right? You can capture and use the result, return A plus B, and then of course, just basically a lot of things, right? So because some of this is why this thing matters, is because we can chain the functions together. The output of one function feeds directly into another. This is exactly how machine learning pipelines work. Pre-processing, training, plus prediction. So we could store it for later, save a result to a variable, use it 10 times, later without recomputing. And something that is very efficient and clean. All right. So we could build complex logic with it, combine multiple return values to build richer calculation. This is just the foundation of everything. So just to understand that returning functions is really very pivotal and it's something that happens again and again. Now, I want you to know that as much as we are returning functions, there's something we call default parameters. Okay. So when we talk about default parameters, we're talking about that is just to study what I explained before, which is what? Which is default parameters are sometimes you want a function to work, even if the function doesn't provide a value, which is what I did, right? When I created the BMI calculation, then I kind of used some default parameters uh, to reinforce what I was doing and all of that. But you see that I did a BMI checker. I passed in the weight, and then I said, okay, there's going to be a default parameter here, which is going to be what? The default parameter is going to be 1.6 here, remember? Okay? So that's why when I now return this, if I call this function and I pass in only one argument here, then that means it has to use the default parameter to calculate the what? To calculate the body mass index. That's going to be that's default argument, default parameter that will be used. So those are really very important. And of course, we just needed to know how default parameters work, right? You set a default in the definition, which is what I did here. You're going to see it here. You set it here. And I'm just kind of going to close that. And you write some of the names. You write the name. So it could be whatever thing that you want it to be. And then you can pass the value. You can override the default parameter, which I did here. And you could see how I clearly overrode the default parameters. And just actually some basic programming knowledge that you must need to have. We are going to be doing also along the line while we are working, our source machine learning. Okay, so but essentially, I think it's something that is easy to have some kind of grasp of. Not really so difficult. Just see straight to the point. And yeah, so we pass the value, we override the default. We call the greet, that's a greet method. And we could decide to pass something or whatever, but if we don't put anything inside of it, it's going to output a little guest in this case. So yeah. So what is the return statement? I literally talked about that. Okay. And then we're going to look at keyword arguments, okay? Which is really, really, really very important, okay, in functions. So what are keyword arguments? Now, if you look at the first function that I did create, okay, you're going to see where I clearly mentioned that you need to pass, you could decide to pass the keyword argument here, name, and then secondly, I decided not to pass it here. That works really very well, okay? And that is really very important. That's something that's very, very, very important and pertinent, in programming, where we use, we set the keywords and like the reason why it's very pertinent is that sometimes you might want to just have more clarity of what the matching key parameter is. Okay, so you don't want a situation whereby you now mistakenly enter the wrong one, at the first or something. But just basically for you to understand that the keyword argument, the keyword argument must match the parameter. Okay, the whatever thing that you're putting in, right, must match the initial parameter. So this is name, it must match name. School class, it must match this. same here, this, same here, this, same here, this, and same here, this. So that is what we mean by keyword parameter in functions, okay? So I'm just kind of guiding you through basically everything that I've done, just so you have more clarity on that, all right? So why do we use keyword arguments? The reason why we use keyword arguments is because of it's because of the fact that we want it something that is more readable and because it kind of makes it very clear. It tells us, okay, this is what this value means, and it is much clearer than just having uh, maybe something like maybe number 25, something. But when you have a keyword argument, you kind of, okay, this is what matches this. Okay, this is what matches this. Okay, this is what is this. All right. So that way, everything becomes very, 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 very much easier for you. And, like just overall makes some sort of sense. Do you get? So that is why we use what? Keyword arguments, right? It's more readable. It prevents some kind of mix-up. And, with many parameters, it's easy to swap the order. So keyword arguments eliminates that risk entirely. And that's why it's something that is very much common in machine learning libraries. Functions like model.fit, epoch. Just understand that we'll be using these things again and again and again. You can't just look at this function and say define info name, print name. You have your positional argument and the order, and then you say info David, and just kind of both of them is going to produce the same result, right? Because here there is no keyword argument, but here there is keyword what? Argument. So the keyword makes it in the sense that the order doesn't matter. But if there is no keyword, order, if there is keyword, if there is no keyword, order matters. But if there is keyword, then order does what? Matter. Please, this is very, very important for you to understand in Python. Okay, so we also have what we call the args, flexible arguments. So I'm going to kind of show you what this means. So let's say, what if you don't know in advance how many inputs the function will receive? All right. So plus args lets your function accept any number of arguments, 0, 3, or 100. Okay. So define slash, use the args, start numbers. So print numbers. So sum numbers. So this star as to star here, the star collects everything. The asterisk tells Python collects all the arguments I receive and pack them into a tuple called numbers. All right? So it can work with any count. You pass one value, you pass 100 values, the function handles it without any changes. So look at this now here. Yeah, I have like 1, 2. Output of 1, 2 is 3. Output of 10 is this. Output of 5 is still 5. No output, still the same, it's still going to work. Okay? Now, I'm going to show you how this thing works right now in a jiffy. That's the quarks, args, and functions. So I'm going to just say def. I'm going to say some just say numeration. Then I'm going to pass in the star args. So I'm going to say return number, return sum of args. So here I'm going to say numeration passing 45. Now let's see. Print Now, see what happens here now. Because I use args, right? It means I can do and undo, right? I can do what? And undo. So it means that I can even decide to say, okay, let me have uh, args times 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 12, 56 or whatever. And then here, let's see what's going to happen. And you see, it means that here, this here now, that's all the numbers, all of this here, times 56. I'm just going to have only one number here. So this is going to give me 46, 56 times. Let me just do 4. So it packs it into a tuple. Let me just see. What I'm going to see this. And then I'm going to say this times 4. Maybe we could say sum, multiply. We could say sum. So it's going to multiply this star by 4, get all of them into a tuple, and then sum returns the sum. That's what we call what? The args. I'm just going to comment that out. All right. All right, so that's how it works. So it's going to collect everything, collect all the arguments, pack them into a tuple called numbers, and that's it. So you can sum all the numbers there, can do anything, and all of that. So, but remember, it's going to be packing it inside of a tuple. So if you multiply a tuple, what will happen is that a tuple is going to, it's just like, let's say, for example, you have something like this now. Watch what's going to happen. If I say, def of maybe stuffs, and then I'm going to pass in some ads, maybe, maybe num, what am I going to call this? Let me say items. Then I'm going to say return, return items times 3. Then I'm not going to have stuffs, print stuffs. Now, what happened here now? Let's put this at 6 and put this at 9. Now, what happened here now is 6 is going to be multiplied. So 6 is now the number of items inside of this list. It's going to come out how many times? 3 times inside of this list. 9 is going to come out how many times? 3 times. So each time you use this as, it kind of returns whatever thing you're giving it to it inside of a tuple, and that's it. Okay? So it's going to return or pack it into a tuple. Okay, so that's it. Okay, guys, I think those are actually really that. I just kind of made everything like really so simple and easy. And we also have what we call flexible arguments. Okay, so let's just kind of carefully see that. Let's kind of carefully watch that without. So these are actually some of them. Let's look at keyword arguments. Okay, so keyword arguments is like tags, but instead of just values, you receive named key value pairs. So it's perfect whenever you want to pass uh, in label data without knowing the labels ahead of time. So for example, look at now, we define an info and we double asterisk of data. And then this part time now is double asterisk. And then we say info name is equals to David, age is equals to this. Output is going to give us, what's it going to give us? It's going to give us name and then also give us what? It's going to give us name. The output is going to give us here now. You see that, okay, since we've kind of have this as our keyword argument, so if we call the function now, we can decide to now pass in some data here. Name is equals to David, age is equals to this. And then output is now going to be what? Name, David, age, this. All right? So that's how we use keyword arguments, okay? So each time we want to get some kind of key values, right? Unlike the other one where we just have to work with, one asterisk, particularly to wrap and return us back some stuff inside of a tuple. But here we have it as a double asterisk. I just kind of basically giving you guys so much insights on all of this. And then you know that here all the named arguments are collected into a dictionary, and the most natural data structure for any kind of labeled information. So here also you can have this city NYC, New York City, of course. Output is going to be named this, age is city that, okay? And just kind of basically what it's going to be. Okay. And then you want to access specific values. So you could say, okay, define this. Then watch here now will show that, okay, that data. Then we can print, okay, patient is going to be data name, age, this is going to be data age. And then here will come and say, okay, name is this, that is that. Then that way it's going to give us some kind of specific information. All right, so we're going to be looking at functions instead of functions. That's what we're going to be looking at. So in Python, you can define a function instead of another function. These are called nested functions and encapsulations. And that's what we're going to be showing some kind of practical inside of that. And, anytime you're coming out of an inner function, you must call the function. So you have to calling the inner function from inside of the outer before you call the outer function. So this is when we use it. We use it most times whenever we're performing some kind of encapsulation. We hide a helper logic inside of a function. The inner function is private. It does its job quietly without clustering the global space. And then it kind of gives us, some a complex function into smaller labeled steps. I'm going to show you a very didactic example here of how this sort of worked, okay? And, inner only exists inside of the outer, so you cannot call the inner from outside because it's private to the what? Outer function. So let me show you what that means in real time right now. So before we kind of continue. All right, so the first thing I'm going to do right now, I'm going to create a function. I'm going to go back to our function scope. So because I told you guys that we're going to be coming back here to arrange our security system. So let's just kind of comment on all of these things again. We're going to work on everything again. So what we're going to do now is we're going to create a function. So we're going to call that function, we're going to define it. We're going to call it security system. And of course, I'm going to pass. Now, inside of this function, first of all, the function is going to give us some sort of stuffs like maybe the name and Just kind of something like that, right? So instead of this function, we might have something like maybe create password, password check, because this function is going to run first. Let me just kind of call it basic details, okay? And then inside of this function, okay, so once we're done outside of this function, maybe we might have something like password, another function called password checker, okay? And so we have this function here. We're going to have some kind of global variables inside of this function. And then when we actually have this global variable here, because when this function is going to run, it's going to run from top to bottom. And we want, I could have stored this function here as a maybe global variable, but wait, let's just have it as a function. Then we'll call the function, right? So pass for now. So we'll call the function. Then when this function runs, then it's not going to check when this function runs, okay, it's not going to, first of all, this function is going to run. Then whatever thing we got from this function, we now get into this particular function. We'll check our password. And then when we are done, I think we'll now just basically return whatever thing we want. So this is what we call nested function, okay? Let's just have a test of that. And the first thing we're going to do now is so basic details here. So what are we going to call? So inside of this function, we're going to add username, impute, string, impute, enter your user name. Okay, so that's it. Then immediately it kind of enters your username. The next thing we're going to ask for right now is maybe we could ask maybe a random question of age, int, gonna impute, enter age as at last birthday. Now, this function is going to uh, so we'll call the function. So we'll call the function here, said, okay. So it kind of drops those values for us. And let's just kind of have these stuffs here. So we could say something like password. We could say passkey. We'll continue using this example. Passkey is equals to 1, 2, 3, 4, 5. And then we'll now say, what are we now going to say? We're going to say enter y. So we're going to say y. So we also have count is equals to count is going to be equals to maybe 0. So let's start counting from 1. Y count is less than 6. So this is great actually. So just to make that. I want to know what is the issue here. All right, so you need to make sure that the line is straight, okay? Then so y count is less than 6. So what we're going to say is enter. We say print hello, hello username. Okay, hello username. And then we'll now see hello username. Kindly enter kindly enter your password. Okay, let's kind of have this pass key here. Pass key. Enter the password you'll be using for this phone. If new password so say username, please enter your password, okay? And then because we have the functions or the functions, we want to make sure we have a proper program. So say enter username again. Please. So we're gonna have this here. Please confirm. So this is going to be your password. Again. So now what we're going to say now that if password passkey is equals to new passkey uh continue else else break. So password else we're gonna print password does not match. Please enter it again. Now what we're going to do right here now is so this is where they will save their password. So we're going to wrap this with a while loop, right? So we're going to say while true, right? So this is going to be wrapped under a while true, okay? And then before we now have, we're not going to now have our basic details. which is still okay. Okay, still inside. Password does not match. Please try again later. Okay. Please enter it again. So if it does, else, okay, if password is equals to this, then continue. So it will skip and then continue right here. But if it doesn't, then what is going to happen now is else password does not enter. Try again later. So it has to it has to fulfill this particular loop here before it comes out. And then we also have another the continuation here. Count is equals to while. So while count is less than this, we'll say hello username. Kindly enter your password. Kindly confirm your new password. First of all, we'll say print welcome to this particular Nokia product. So I'm going to say print enter a password. Um, so we'll call this login. So let's build the logic of our game. Login password. So we're gonna have so wrap this with an input. Of course, it has to be an int. So I think we could decide to cast this as a string. So yeah, so you just let's organize it now. So this is our remember we're talking about nested we're talking about nested for loops, right? And since we're talking about nested for loops, so we have this is our security system. So inside of here, we have basic details. So while true, username is this, enter your username, age is, enter your age as of last birthday, passkey, int, please enter a password you will be using for this phone. And then it's to say, okay, new passkey, okay, please confirm your new password again. So if this password is equals to this, print correct password. Uh, break. Else, print password does not match. Please enter it again. So that's going to take us out of this particular function here. So we now call this function instead of this inner function. And then we'll now use what's the name here, right? We'll use that name here. We'll now store it inside of this here. So we'll say y count now is this. Now here now, the person has now gotten the phone. So you say count is equals to 1. Y count is less than this. Print, please welcome to this Nokia program. Welcome to this what? Particular health, I'm just gonna use something, health checker app. And then we're now gonna say, okay, login. So you need to log in. So login, string, input, hello. You now say, kindly enter your password. Now, if login here, login password is equal to you see if it matches the new passkey, If it matches it, break, break. So we're gonna print login successful, you break. Else, print you forgot your password, kindly try again. Now we'll say count plus equals to 1. And then if count is equal to maybe say like 3, because you're gonna say print you have 2 trials left. Because here now it's going to stop at, if it's less than 6, it's not even going to get to 6 because we're using the less than there. And then you have 2 trials left. And then if count, so we're going to check if our count is equals to 4, we'll print so we're going to use an F string to hello username. You have 1 trial left. So I'm just going to use another string here. Say hello. If count equals to 5, you have been banned from this phone. Kindly contact and support break. So, this is what a nested function looks like. So instead of this function, we have a function, and of course we could have some kind of global variables here if we want, but that's actually really up to us. So I'm just going to kind of break here, and then I'm going to call the function security system. So print security system is the name of the function. So I'm going to run it. Enter a username, David. Enter age as of last birthday, 27. David, and please enter your password you'll be using for this phone. 1, 2, 3, 4, 5. Let me kind of get it correct. 1, 2, 3, 4, 5. What is this saying? Said, welcome to this health checker app. Cannot access local variable where it's associated with a value. Okay, unbound local variable. So, all right, so what we're going to do right now is we're going to just kind of rectify that real quick. And because we are trying to see if login password is equals to new password. And all we could do is mm, okay. So what we can do is we can try to put this somewhere here. Okay, so we're gonna put this here, just to be sure. Okay, so let's go again. I'm just gonna kill all of these just to make it very easy for us. Enter name, David, 26, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh my God. We run into that challenge again. All right, so this is what we could do right now. So let me just kind of show us real quick what we can do. And we could decide to return the values, all right? So we're going to return those. And this is where object-oriented programming plays a very massive role, because here now it's easy. You could just assign that value to some classes and then, of course, return all of them real quick. Okay, so what we're going to, let me just show you guys what to do. This is part of it, with the bug and uh, okay, so let me show you. And so because this is going to be used outside of this function, we're going to keep this outside. We could decide to keep the function outside here, outside of the global scope. Please confirm your password. So we're going to keep, so we're going to keep, so the user starts by entering their password. And then let me just kind of, let's tidy this up. Okay. Okay, so we run this. Okay, hold on. We're not done. Sorry. The variable was not assigned. So this is going to be, if it's equals to passkey, because it's a global variable. Now I'm going to explain that real quick right now. And yeah, you see everything is definitely going to work out well. So okay, username is not defined. Okay. Right. So basically what they are doing here now is just to give us some of their basic details. Okay. And we could just have that here. Everything now makes sense now. Okay, so I'm going to delete this. It now works fine. So I'm going to run this. What's your username? My name is David. Password I'm going to be using for this phone, 12345. What's my age at my last birthday? Now look at what happens here now. So the first thing that happened here now is that we call this function security system. That's the first thing that happened. So immediately we called the function, right? The first thing that now happened was what? The function now ran these two lines. Then it will now first of all go and call this function, right? Then after calling the function, it will now start from here. All right. So that's it. So 26, and then please confirm your new password again. So I'm going to say 12345. Oh, it said cannot access login password is equals to this. Where is my login password? Oh, I put a string to be an int. And because it's already an int. Okay, so let's do that again. Why true is this? Login. Okay, so David, what password? 12345, 26, 12345. Ooh, cannot access login where it is not associated with a value. Username. Welcome to login. No, it's not a global variable. Okay, so we're trying to check cannot access local variable login where it is not associated with a value. And okay, so guys, I think you guys just kind of got the idea here. Is that we have a nested function inside of a function. Now, these are what we call global variables, all right? And these are like nested functions inside of this particular function. So if you look at this here now, you see that we have a variable, we have a kind of a pass key here, which is a nested, which is this is a login here. So what this login variable does here is that it kind of checks if this is equal to the initial pass key that you entered, all right? And then if that is the case, then of course it's going to let you pass, or else it's not going to let you pass because you must need to have that well sorted out. Okay, so those are actually really that for now. I could just continue to run that again and again. You put your name, let's say put one David, and then 1, 2, 3 for something, maybe 23, and then I say something. Please enter it as your last birthday. It will have to continue to ask me to do that. So there are other things we could do, probably sort and arrange, how that's the sequence of our passkeys, but just kind of basically what you just need to understand is that this is basically what we call nested functions in Python. So we have what we call scope of variables, local and global scope. And that's what I really explained outrightly here. You see that this particular function here this is a global variable to this particular, internal functions that you have here. So that's why function passkey here can actually work inside. And of course, username can also work inside. Then if I kind of define anything outside of this particular, that's really the hierarchy, that's the top global function we have in this particular security system that we're building. So that's what it works. So created inside of a function. So any variable that's inside of a function is a local scope variable. You can't really access it. All right. You can't really access that particular variable inside of a what? Inside of a function. So when we have local variables, you see that local variables must finish before the global variables starts running. So that's the order of precedence that we have. That's why if you look at what I actually did right here, now you see that some of these local variables, they have more higher priority compared to global variables that we declare outside of the function. So those are actually really that for now. And just to keep you still on the game, we have what we call lambda functions, okay? Lambda functions are also another type of functions we use in Python. There's something we call arrow functions in JavaScript, and that's almost the same thing as what? Lambda functions. So when we talk about lambda functions, this is basically what we are talking about. I'm just going to show you something real quick right now. And just for you to have an idea. Okay, so I'm going to delete this. So I'm just going to take out this. So whenever we talk about lambda function, these are kind of short functions, right? So when you say a function, let's say, for example, we say now shorthand functions that are written in Python, right? So I'm just going to show you what this tells in a jiffy. So for example, now if you have a regular function, I could say add A or B, okay? And go print add 2 to 3, whatever you want to do, okay? But basically, whenever we are looking at lambda functions, we're kind of more interested in what we want to know. Let's say, for example, we could define lambda in one line. So, okay, this is maybe add is equals to lambda of A and B. Then anytime we say add, passing those parameters that we've got there. All right, compared to having to traditional write the whole function, from scratch and all of that. So that's just basically how lambda functions work. So let me just kind of show you quick what I'm saying. If you have, for example, a number no, let's say, for example, let's say calculate age density. And let's say, for example, the age density is given by d over w squared, d over w squared. Now, what this is going to be now, say lambda a d is going to be what? A is going to be A, and then we say A over, I think this is going to be D and W, D and W. So I'm going to say D over W squared. So say calculate age density, and then we're going to pass in, this time around, we're passing maybe 20, 12, and 19. And that's it. So it kind of gives us A, which is, sorry, D and W, which is going to be 12, and then W, and then basically squares W, which is kind of what makes the value really very high. And maybe this could be 200, and then runs that, and maybe reduce this to maybe 3. And of course, it still may have some kind of meaningful output. So this is just basically what lambda is. Let's check what we want to say, square of circle, square root of number, square root of norm is equals to lambda, and then we have x, and then we have x squared. So we're gonna say square root of norm. What's the square root of 3? Is gonna give us 9. So that's how lambda functions will. So we're going to be using lambda functions most times, maybe particularly in classical machine learning, but just really important for you to have a very clean grasp of. I think that's actually that for now. Yeah, so really very important, very, very important, and easier to basically navigate. So that's how lambda functions work now. So we use it heavily in pandas and matplotlib. So also have functions with conditionals as well. Yeah, just so we could have a function. If age is this, return this, else this, and all of that. They'll ask it to check. So this is something really very important for us to have very big awareness of, because functions can receive an input, an age value, and then which could be from a form, a database, or a CSV file. Condition is evaluated. Condition checks whether the value meets each condition top to bottom. The label is returned. A function returns a category string. And this is exactly what machine learning classification models do. Let me show you what I'm talking about right now. So I'm going to say define, because here now, right, it could take in whichever value you want to compare, right? So you could say define, maybe, for example, weight density. And this is going to take in weight. Now, if the weight is greater than, if the weight is equal to 79.4, is greater than or equal to 79.4, was print. Of course, we could just return, and you will say return no time to return. Let's go print. width is excessively high, else, or if width is greater than or equal to 50, or print that width seems to be a bit moderate, else width small. So I'm gonna go there and then I'll say width that's going to take in something like 45 points. And then maybe width is going to be 9.3. Width density is going to take in 77.6. And that's got a lot of stuff, right? So this is excessively high. Seems to be a bit moderate, and that's it. So that's what we call functions with conditions. So I'm just going to write this here. I'm going to say functions with conditions. Functions with conditions. So this is actually really very, very important and paramount for anybody who is kind of navigating machine learning. So there are kind of some real life examples that I've just kind of shared out there, patient risk function and, just how to navigate some kind of, params, and it's very important, very useful. Yeah, this is actually really very important. So you have, define your risk, and then if it's this, and then you return that, you print risk of this, and that of that, and just a lot of that, right? So this is just basically what we do. I've kind of left some other small practical examples, that you can, define your params, check out keywords, tags, lambda, scope of function, nested functions, risk classifiers. That's all of that for you to get started with functions in Python. So in this video today, we're going to be looking at object-oriented programming in Python. And this is going to be a very tactical part, right? So this is just very, very, very important because it's something that's not really so talked about. So I'm going to talk object.py. Okay. Okay, so this is actually what I'm going to be working on right now. Now, I'm going to tell you something about object-oriented programming before we get in, as usual. So the first thing I'm going to do right now is I'm just going to come down and let me just kind of swing this down a bit and just show you what's. So what I'm going to do right now is this. I'm just going to show you something real quick. So what do we mean by objects now? Now, remember when we started this video like lots of hours ago, about 10 hours ago, I did mention that you could have something like maybe maybe name, and then see name is Chidinma or something. And then you kind of do print type of name. And then it gives you that is of the class string. Now, this is something we all agreed with because of the fact that in Python, you know, objects, a lot of things are stored as objects, okay? So we have something that are of class tuple. That's why we said we could have something like name dot uppercase, upper, and then it gives us everything in upper. We could do something like maybe name dot lower, and it gives us everything in lower. And then we talked about the fact that it can really not be mutable, right? It's immutable in the sense that you could have, you could have, you could have a name, right? Or you could have, something that's from this particular object. Because name here, as much as this is a variable, this is just kind of a blueprint of this in this class. So that's why it has some kind of characteristics of stuff you can do inside of this thing, call some methods, and then of course it's work. The same thing happens with list. List is just a blueprint, right? It's just like a blueprint or an object. So when you now start using the dots and all of that, navigating the methods around it, of course, it starts changing loads of stuffs. And, that's it. That's the starting point. So basically, what I want you to understand here right away is that we could have some, we could do the same thing for objects, right? Object-oriented programming. And I'm going to show you what the paradigm is. And of course, we're going to have a very long exercise there. And then of course, yeah, from there, who knows, that's going to kind of give us so many stuff. We could try one or two try and accept and maybe just talk about generally what NumPy and pandas entails and as well as matplotlib, and that's it. So first of all, I'm going to get to this, and this is what when we talk about object-oriented programming, this is just basically what it entails. And yeah, so let me just kind of have that in full screen, just so that I could show you some of the things you might have been craving to understand. Okay, all right, so okay, so now if you look at this right here, I think okay, that's actually the best way. Now, what is object-oriented programming? Now this particular part of this section now is something I feel like we need to start by talking about, like having some serious theoretical grasp with, because it's going to really help us a lot. So object-oriented programming is a way of organizing your code around things called objects. So instead of writing one long list of instructions, so think of it as designing a hospital system from scratch, okay? Designing what we call what? A hospital system from scratch. So the hospital analogy here now, the hospital has patients, doctors, and medical records. Each of these is a distinct thing, okay, with its own data and actions. So object-oriented programming lets you model exactly that in code. So in plain terms, whenever we talk about objects, it's just like the thing, a patient, just think about it like the data, the details about each thing, the names, the age, diagnosis, actions, and all of that. Don't worry, we're going to actually explain these things now, like in a much more, smoother term. So the reason why we deal with OOP is because It's not because we want to waste our time, but the reason why machine learning engineers deal with OOP is that OOP is not just a good style of programming, it's a foundation of professional software. So every major Python machine learning library, be it scikit-learn, be it PyTorch, Keras, is built on object-oriented programming. If almost a vast majority of things we talk about today in Python, is built around with object-oriented programming. Okay, so we could use it to build real apps, structure web applications, and APIs that features don't tangle into spaghetti code. And just like maybe kind of looking at, the way we are writing code, and you're going to see how nested spaghetti, and all. So most of all of this is that we're actually doing right here now is that we wrap them into what? Objects. We wrap them into objects, and it's kind of makes our life really, really very easy. Okay? So we use it to power machine learning systems, machine learning models, data sets, and pipelines are all designed as what? Classes. All right? So understanding object-oriented programming unlocks how they truly work. Okay? So you write some sort of reusable code, and you write a patient class once, and you use it for 10,000 patients. There is no copy and paste. There is no chaos. Just easy. You stay organized. You could be working on a very large project, but just when you organize it in classes, it kind of it makes everything really very easy, manageable when each concept lives on its own. We're going to show you what this thing is all about. So remember, when I start this thing, I was talking about classes. When I said, maybe let's say, for example, we have fruit is equals to, maybe I could just go through several data structures here. Mangoes, and then we have cashews, we have bananas, we have oranges, and I want to say print type of fruit. It tells us okay. It tells us is of the class what? List. Don't forget, remember, this is a what? A class. So we're going to come to that. Now, I would have just wanted to jump in to show you some stuffs, in OOP, but I just wanted to kind of have good details here. So we're going to have something like a class. So a class is a template or a blueprint that defines what a thing looks like and what it can do. All right? So, but it isn't the thing itself yet. So just think about it like designing a blank patient intake form, at a hospital. The reason why that form is existing is because any kind of real patient can, that can jump into it, fill it in. But what your class is that uh, it's going to help you create some kind of moving objects for whatever thing you want to do. All right? So what's your first class? Your first class here is maybe you could have a class of patients, you pass, and then we'll have line by line. Now listen, so you could have maybe class keyword that tells Python, okay, I'm defining a blueprint. So patient is the name of the blueprint. So it could be camel case, by convention. So that's what that's going to take the name of whatever thing we're going to do. Then pass here means just keep it empty here. We're going to pass. Just don't worry. And then we have a real world connection before a hospital admits or whatever, blah, blah, blah. But just basically, this is how our methods are definitely going to be created, okay? So if take, for example, here, we could have an object, which is a specific, it's just kind of a real instance created from a class. If the class is the blank patient form, then the object is the fielding form. So P1 here could be the object. And of course, before we call that particular blueprint, we could create all of that. So we could have class as the blank, this, and all of that. So let me just kind of show you what we're talking about right now. So we can have class, and I will say patients, patient admission, patient admission system, okay? Now, the first thing we're going to define, we're going to define an init method. And that init method is going to take in a self. We probably pass a name, we pass in an age, and then we'll say self.name is going to be name. So that's what we are storing it as. And I'm going to say self.age is going to be age. And then we could define something, a function, which is what we were calling then. So we could call this greet patient. And then this is going to take in self. And then we could say print self.name left string. Good morning. Good morning self.name. And then of course we could have another method here. We could say this is to say thank you or whatever. Say thank you. I don't know why I'm running out of ideas. So yeah, I could say maybe this could be to drive patient. It's going to take in self. So we're going to print here. We'll say hello self.name. Come and drive. Now, so this are what we call, this is the class. Now, this is the same thing as that string that you have. This is how it is at the back end of the program. So this is the class. This is the constructor. So we call this the constructor. So this is where you define some of the parameters that are automatically going to be run. Now, imagine I cannot print here, welcome to Python here, and I try to call maybe a blueprint of this class, create an object, and I say patient1 is equals to patient admission system. Automatically, it's going to print, okay, I want to know, patient admission is not defined. Okay, so I'm going to pass in patient admission system. So I'm going to pass in the name, maybe Angel Duca, and then maybe 24. Let me just kind of delete this so that this thing stops disturbing us. See, welcome to Python. So what this constructor means here now is that it is automatically displayed. It runs automatically. Immediately, you create a blueprint. Automatically. You see how all these things was assigned immediately. Okay? So I'm just going to delete this. And then I'm going to now come down here. Patient.1. So I'm going to say patient.drive. that is dot drive patient. That doesn't take any keyword. Patient dot one is not defined. Did I spell it correctly? Run Python, fine. Hello, Duka. Okay. I don't like these things disturbing us. All right, so you watch. When I now call this method, watch, if I run this, hello, Duka, come and drive. Are you seeing it? Hello, whoever, Duka is stored here, come and drive. So that's why you see it here. So you see hello, Duka, come and drive, because uh, this particular blueprint stores Duka, and then it stores Duka and then 24. So if I want to call the age, I don't think I pass. You are self.age years old. Please come and drive. So let me kind of run that again. Hello, Duka, you're 24 years old, come and drive. And then I'm going to add this here as well. And then let's say we change to greet. We don't want to drive again, want to greet. So say patient dot greet. Okay. So you see, it greets me, good morning, Duka, you are 24 years old. So this is what, just a snapshot of what object-oriented programming is. Now, also what we call inheritance. Inheritance. I think I'm not taking user inputs for now, uh, but I could just keep. Okay, I could just keep some values here, just so it makes some kind of sense. All right, so that's what I'm gonna do. So I'm gonna just run this, and then you can see, okay, everything still works really fine. So let's kind of go back now. So you've seen what I did now. I created my first object and then printed it. And then of course, how do we check the class? We could do something like maybe print type of patient one, class of main Python admission system. So we created our own class, and that's it. So the init method that I was using here is what we call, it's one of the init method is Python's automatic setup method. It runs instantly, immediately you create an object. So this is where you can give the object a starting better, like filling in the patient's name and age the moment they register. All right. So the class is of the class patient. So you define the init method, you pass in the name, just like I did. So it tells Python to run this automatically when a new patient is created. You see how I created that welcome to Python program, and it ran immediately, even without me, even without me calling or printing or whatever thing. So that's how the init method works. Self.name is equals to name, self.age equals to age, just need to save parameters. So we could also create objects with real data. That's also very much possible. We could use the init method. Just look at what I did right now. And I could decide to create some other params, another object. This is patient one. What about I create patient two, and I call it patient admission system, and I call it Michael, and then I say 77. Okay. So when I say patient 2 dot um dot drive, and it says, hello Michael, you are 77 years old. Come and drive. You see how that works? That's object-oriented programming in action. So we could create as many multiple objects as possible, and it's easier to run because that's just what we call reusable block of code. That doesn't stop there. It continues to happen. Uh, then self. What is self? Okay, self here means we could decide to use this in several classes. Just to show you what I did here, you could see that when I created this blueprint here, self.name, I used it here. I also used it here, right? So I can define it here. This is more of the global scope of this class. You know, not this is actually the global space actually, but here at this particular at this particular region here, so once you define anything beneath the constructor here, you can use it, inside of the classes, and yeah, you don't really need, to have to continue to define that again and again and again and again. Just really very easy for you to do, and so it's one of the most confusing concepts so many people find very difficult, whenever they're starting, their journey programming in Python. So you can actually add methods, teaching a patient to act. A method is just like a function, like I talked about. So method gives objects the ability to do things. The patient doesn't just store data, they can greet, report symptoms, or change risk levels. And then you have to notice that almost every method starts with self, and adding a greeting method like maybe class of patient, you define init, self, name, age, uh, stuff. So many of this actually makes a lot of sense. And then you could see how I defined, this, because when you define self here, it defines a function inside of a class. It gives you the access to the entire body. So that's why whenever I define a function anywhere, I can actually use it throughout the body of this particular function. So how do we call the methods? We use the dot sign, and then we start calling all of them. So that's just it. If you look at this here, the blueprinter patient. So what we do here is we say David 30, Sarah 45, and then we use a dot to call it. Hello, my name is this. And once the method is defined inside the class, calling it on the object is simple. You use what we call the dot notation, because that's what we usually use in calling, a method in Python. Okay, so Python automatically passes self for you. So you don't want to type it whenever you're calling it. So we'll kind of have some example here, which is not really different from what I did, definitely going to leave all of this in my Git repository for you to have really massive, checks on. So we'll kind of look at encapsulation. So what do we mean by encapsulation here? Now, look, encapsulation means bundling data and methods together inside a class and controlling what the outside world can access. So every piece of data should be freely editable, a patient's blah, 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 and all of that. So there might be time when we might use a method, inside of an object, right? That's inside of the blueprint itself. And usually we use the underscore sign, right? So look at this particular class here. So here now we have, I'm just going to bring this inside here, just so that it kind of makes some sense. So if we look at this code here now, we have class, which is patient. Okay. Okay, I'm just going to kind of. Now, so we have self.name is equals to name, self.underscore of age is equals to age, and then define age. You now say get age as self, return self.underscore age. If we run this, it's going to give us David because that's just it. Okay. So this is what we call encapsulation in Python, pattern and object-oriented programming. So double underscore makes the attribute private. Outside code must go through get age, a control window, prevent accidental modification of sensitive data. So when we talk about inheritance, so let's say, for example, we define a block of code here, right? So we have class, so it's just kind of a new class automatically receives a feature from an existing class and adds it into its own. So this thing prevents us from rewriting code, and create a kind of natural hierarchy that just like, somebody can adopt something from somewhere, right? So let's say a class here, you define a constructor, and then it takes a name, greet self, hello, I am whatever dot self. Now, what does inheritance mean? Inheritance means that we can create another class, right? That class is going to be patient. It's going to take in the person. So we define the init here and say, okay, self name. But we'll say super dot init of name, self dot age is equals to age. Automatically, it's going to inherit that particular feature from that class and of course return it to you. So this is really so simple and easy to understand because we're going to be doing several of these, particularly in our machine learning practice. So that's it. So what inheritance here is, we can override the method, you know, as much as we are inheriting, it doesn't mean that we cannot override. We can, of course, surely. Why not? We can. Okay. So, but the idea here is that what? Uh, we don't want some of the customized features, like if we method overriding here means, okay, we are customizing inherited behavior. Sometimes a child class needs to replace a method it's inherited rather than use the parent's version. This is called what we call method overriding. The child class defines a method with the same name, and then Python uses the child's version automatically. So overriding greet and here, now look at this now. We have a patient, okay, and then it kind of inherits, this person is going to inherit from this. So that's why I see define of self, and then, okay, I am this, and then class doctor inheriting again from person. And then you see that self, you print, I am this, right? And greet self, I'm Dr. Smith is going to take, I am Dr. Smith. This is, I am a patient. Okay, of course. Check me in. And when you print P of patient, David 13, and you see it's going to take in D of Dr. Smith, which is this, is going to take in, hello, I am this, I am Dr. Smith, all of that. All right? So that's what we call method overriding. So more priority is placed to the what? Lower variables compared to the what? Top ones. So we could have multiple objects, a room full of patients, one of the greatest powers of object-oriented programming. We create multiple patient objects. Of course, for P in this, we print p.name, p.age, and all of that. And of course, those actually really happens. Okay. So, but basically, what we just want to understand here is that we could just kind of apply some list, string concatenation, and all of that. Each object is fully independent, and this is really going to make everything really powerful. And this is definitely what we're going to be doing so much in machine learning. So these are we could have something we call instance variables. So this is a class variable. Remember, I was telling you when I was writing this here in OP, I did mention that I could have, a class variable here, okay? And of course, this is something that can still be used, okay? And of course, but most times, whenever you want to call that variable, uh, what you just need to do is, now look at this now. If I show you what I did here now, you see that if I want to call this variable now, I just say patient.drive.this, right? But in this case here, I could just say, okay, that big variable dot, whatever thing I'm looking for here. So P1 is this, patient.hospital, rather than P of hospital. Okay? So this is what we call class variable shared by all patients. And we have what we call instance variable, which is defined inside of the init. So basically, most of what we're going to be working with are going to be instance variable, but there are some times where we share, we use class variables, which are kind of unique to each object, like self.name, patient's name, age, diagnosis, and all of that. But just kind of have an idea of what you guys are doing. Like that's just basically it, okay? All right, so the next thing we're going to do, right now is we're going to have like we're going to be talking about uh, some of the machine learning connection, right? And when you look at the machine learning connection here, OOP powers almost every machine learning library, and everything you've learned maps directly onto how machine learning systems are built. You are not just learning Python syntax, right? You're learning the architecture that powers, scikit-learn, PyTorch, TensorFlow, and all of that. So for the data sets, they are equals to objects, right? And then the model actually equals to classes, all right? So for the prediction here, uh, you know, so for the prediction, each row in a CSV is an object. So a patient class models one row, name, age, lab results, diagnosis. Okay? So just what I wanted to get here now is that vast majority of what we're going to be doing in machine learning connection, OOP powers every machine learning library that we're going to be doing, okay? So it's not really something to worry so much about. We'll be working with classes severally, and we're going to be doing so many exercises, particularly in our machine learning training and all of that. So I think I kind of just want that, really sorted out. So this kind of a mini system for you to have understanding of. We kind of lets us to bring everything together into a small but complete working system. This is the kind of code you'll find in a real healthcare data pipeline, or the backbone of a machine learning processing model. So this is kind of the complete patient system. So we start from instantiation some classes, You need to understand what global classes are compared to local scope. That's some of the instance variables that we did talk about. But just have some very good information about this. Some of the mistakes a lot of beginners do make is the vast majority of time they might have their classes. They could have the some of what they defined. How would I put it? They could have their some of their, they miss the intention, rather. I think that's a better word to say, use there. And, that which is really very bad. If you're not kind of indenting this properly, of course, that's really going to kind of ruin how much you put in your classes. So just make sure you do that, and then also make sure that you assign variables and some of some of your instance variables align, in what you're doing. All right. So this is just kind of an example mini system, patient management system that I've kind of laid out here. So like I just say, some of these are common beginner mistakes. Sometimes you could forget itself in methods. Um, you could have some, you could have you could forget some of the self in the method, and then you could make mistake in defining, skipping some of the units. Maybe that's a constructor, and sometimes people confuse class with object. Patient dot greet, that's an error because you're calling the method and the class. And maybe you have some kind of P1, whatever shit that you're doing. But just kind of make sure that you avoid some of these common beginner mistakes. They are not really advised. And it's kind of very, very important for you to, take cognizance of that. So I'm just going to kind of leave you with some final projects. If you're getting started with OOP, this is just what you could want to build, mess around with some stuffs, assess, check out global variable scopes, do some very important things, and you could check out some of these extension challenges, add a doctor class that inherits from person and then has a diagnosed patient method. You could create a list of 5 persons and loop through it to printer. It just could do a lot of things, particularly if you're somebody that wants to get started with object-oriented programming. Okay, so other than that, I think that's actually really what I want to talk about right now. And I'm sure that you kind of found this object-oriented programming really very intriguing. I've actually made some specific videos on this. And of course, I will continue to make as many much more videos as possible, just to make things really very easy and understanding for everyone. So I'm just going to run through some Python important insights. The idea here is just to kind of give some person some kind of good thumbs up on what NumPy means, and NumPy for excuse me, NumPy for absolute beginners. So yeah, that's what I'm going to do. This is just going to be a very, very short crash course. I'm not really going to be wasting so much time here. So this is, like I said, it's going to be NumPy based. Okay. So now, what is NumPy? Now that you're kind of comfortable with object-oriented programming, and we've covered at least almost all of the parts of, getting started with some of the basics and important information about Python. If you've actually watched this video to this particular point, so what it means is that you are somewhat very much okay in terms of knowing what and what to do to getting started with programming in Python. So we're going to look at some stuff of stuffs around NumPy, and then we're also going to have some cool visualization of matplotlib and some pandas, just for you to have an understanding of what we are talking about. Now, remember that when I talked about Python list, there are several things we talked about, how Python lists can be mutable, and but it's quite important for us to understand some things, that there are some kind of libraries, that are available in Python that are really very good, particularly for somebody who is working on data science projects. So we have NumPy, we have pandas, we have matplotlib, uh, we have matplotlib, and so I'm just gonna close this like real quick. I don't really want just need that shit. Just to kind of give you some insights, like real quick. I'm not going to waste some of the time. So I'm just going to put that there, pandas, and we're just going to look at matplotlib. All right, so good. So these are just some of the libraries that we might talk about real quick, but we're not really going to be going so much in details when we talk about them. All right. Now, what is NumPy and pandas and matplotlib? Now, remember that matplotlib, that's the name, matplotlib is for visualization, pandas is for handling data frames, and whereas NumPy is for numerical computing. Now, let me just going to tell you something right now, real quick. Remember when I did something like this in Python? I did something like scores, and I did, I just put it inside of a list, 45, this, and that. And I kind of did scores times 2, kind of print, watch. If I print scores times 2, just notice. You see, what happens here is it stops here. Let me just make this 12, 12, 23, 23. Now, what did you see? 23, 23, 12, 12, 23, 23, 12, 12. That's what it does, right? So it means that it kind of duplicated the list. Now, this is one of the weaknesses that comes with lists. I'm just going to say weaknesses with Python lists, okay? So I'm just going to write that. Okay, so I'm just going to show you. So you see here that it gives us something like this. Now, but let's assume we want to use NumPy, numerical Python. Like I said, I don't really want to go so much in depth of this. I have a focus on NumPy already, but this is just for you to have some sort of graphs. I could just want to run through the slides just to tell you one or two things that you need to know. But anytime we're going to be talking about NumPy, we're going to be talking about arrays, some of the mathematics that can be performed inside of it, and calculations on held data set. Then how you can be machine learning ready, and then some real world examples. So if you're going to look at this right now here, you see that we have NumPy, which is short for numerical Python. I'm just going to go through this real quick, okay? And then explain in practicals. So that's what it stands for, numerical Python. It kind of contains a list instead of it. And we use it, because it's the backbone of machine learning. We can use it it's very fast, faster than Python, very fast. And it's kind of memory efficient, powers predictions, universal languages, really very good. We can, it's short, it's written in C++, and we could create, it runs on top of C, actually, C library. So we could create our first array. I'm going to show you lots of stuff. We create array and do some stuff, okay? I'm kind of just pause here and get back to the practical part of the whole stuff that we're talking about. Now, this is a Python list, right? Look at how slow it is, and it doesn't perform that arithmetic operation. Now, how do we create a NumPy list? A NumPy array, which is a NumPy list. That's how I might call it. It's a NumPy array, which you can call it a NumPy list because it's an array that has a list inside of it, or it's a NumPy whatever that has a list in it. So so let me say children. I'm going to say something like disease scores. I'm going to have np.array, and then we'll pass a list inside of it. And then I'm just going to pick in scores, and put inside of it. Now, watch what's going to happen when I say disease scores times 2. Now, watch what happened here. It multiplies it by 2 compared to this one that kind of duplicates it, which is not what we want. So this is where NumPy beats, it beats, what do you call it, Python list, because it is really, really, really very fast. And of course, you can perform a lot of arithmetic operations, inside of it. All right? So you could see that, and that's it, and that's how it works. And of course, everything makes a lot of sense. So what are other things? Now, there are also what we call array methods. We'll come to that. We'll definitely come to that, right? We'll of course come to that. But for now, just have an understanding of what NumPy means. You could see this stuff here. You see, we could have something like a disease scores dot. Now you see, we could perform a lot of things. We could view, we could transpose, we could trace, we could change to file, we could sort, we could resize, we could a lot of things can happen. We could reshape it, we could choose, we could like these are what we call array methods. Okay, so this is an NumPy array. So how do we confirm that? I could just print type of this, and it's going to give me is of the class NumPy array. And now the reason why this is really very important in machine learning is because most of them might be working with images. Okay, we might be working with some sort of images and it's a kind of a lot of stuff. So most of all of these are what would be what most of all of this images and related stuffs will require that we do what? They will require that we work with faster data structures, and that's why NumPy add faster data structures that can actually perform some of these tasks in real time. Okay, so yeah. So that's just basically how it operates and what. So I'm just going to show you something right now. Uh, we could also generate we could also generate arrays. So now how do we actually get started with NumPy? We could import NumPy as NP. So this is an alias that we use in importing NumPy. So this is what we call modules and packages, right? So that's what we're talking about right now, modules and packages. So the NumPy library is really very useful in performing mathematical operations in programming Python. Whereas pandas too, we use it for some kind of we use it to make some to handle data. That's if it's data frames, it's sort of kind of dictionaries, or it could be data, some sort of just any kind of stuff that requires us to dealing with large CSV files. Pandas is really the king there. So this is also how we import it. We import pandas through PD. We import pandas as PD. But we're definitely going to come to that just so you understand that this is kind of the short form symbol that we use. Now, what am I going to do now is I'm going to show you how we can create, generate random data, right? So we could do np.random.randint, and then we could say, what's that going to be? Maybe ages. So this is for random integers. So we want numbers from 0 to maybe 144, or maybe 100, or maybe 98. And then we want how many of them? Size is going to be equals to 8. So if we print ages here, it gives us some, if we run it again, it changes. But if we don't want this to change, we could do something like maybe import, what's it, np.random seed, and then we choose a random seed, and that is not going to change again each time we run it. All right? So that is exactly how it works. All right? So you see, it doesn't change again each time we call it or we run it. So I think those are actually really that particularly here. I'm just going to tell you the rules here. The rules here for random random is that this is going to be an integer. So this is maybe probably if you want to generate some random integers. So we use the random.randint. So this is just usually a seed. Okay. And then how about if we want to generate integers clustered around maybe a particular, maybe we have a certain distribution, or maybe let's say, for example, we could say mean. So we have the np.random.poison, and then of course this is going to take in 3, 4. Let's see what it gives us. And it's just going to give you like 4 numbers that are clustered around this particular, we'll use the standard deviation. I want to say names, body scores. So np.random.seed. So that's what it's going to give you. So guys, I've actually made videos on this. Print body. Okay. So that's what it's going to give you. So it's going to give you kind of Poisson distribution, numbers around this particular region, right? And that's it. So it's just going to give you numbers. So we could call this scale. We could call this scale. No, that's not it. We call it lock. I think we just could just deal with that. So let's say I want to have another param. Okay, it's can only taking one parameter, sorry. Let's say we have 22. We have 12. Okay, 9, 9. So it's going to give you some random numbers that are clustered around. Okay, they are clustered around. Now, if we want to kind of generate uniform numbers, which are floats around maybe from a range to a certain range. Remember, like say this is when I use obesity. MP dot uniform. And then we're gonna have something like maybe 13.5 to something like maybe 70 points this. And the size is going to be maybe 10. We're gonna print. And then of course I could just put my seed here. And then that's it. So it's going to give you random numbers. So you might want to just round them to 2 decimal places. Okay, it doesn't take in the round method, okay? So just check out that. All right, so this is floats that are within a range. Remember that the first one here is integers that are actually within a range. All right, compared to the second, which is floats that are within a range. So that's actually going to be that. There are also other ones. You could want to generate what of random numbers that are within a particular range, the confidence interval. So use the MP. So you could say maybe let's say pH scores. Let's be MP dot random. And then let's kind of take in 20. So let's see what it gives us. Okay, first of all, we could print pH scores. And then we could just have this. All right, so I could just shorten this to 5 and then have 10. Okay, it doesn't take in that. So it's going to give 4 random numbers and they're all normalized. So this is what we call the what? Gaussian distribution. Normalized numbers. So there are actually a lot of things we could do. We could perform slicing. slice in here. But then before we do that, of course, let me just show you for choice. Let's say we have, let's say for example, we have maybe MP. I'm just gonna show you this now. Handling qualitative variable. Food choices is MP dot random dot choice, and then it's going to take in amala. So what we're going to do right now is, so I could just print food choices. Size is going to be 100. Okay, let's do 12 by 617. Let's print this. I think that is quite much. So what we're going to do now is we're going to reduce it small, maybe to something like 2 by 7. Okay, so we have 2 rows and 7 columns. Okay, now if we want to have 2 dimension, okay, so it means that each of them is going to contain, oh wow, that's beautiful, or 3 color channels. All right. So this is actually really what we really need to have massive grasp of. This is how we generate some kind of data set in. So let me just kind of reduce this a bit. Okay, and I think this kind of makes sense. Now, if you look at this now, we could do something we call slicing in NumPy. And that is the same thing that I said before, where we'll have rows start, rows end, columns start, columns end. So this is how it works. Okay. So if I look at this now, I could say here, I want food choices. Give me from 2 to the end. If you don't put anything else to the end, and then 1 to the end, change it to gala. Let's see what's going to happen. All right, so let's kind of print. I'm going to explain what print food choices. Now you see that, okay, so 2 to the end, then 1 to the end. Okay, okay. So we start from the beginning of the rows to the end, and that's it. So this is what we call what? Slicing and reassignment. So you see that a lot of things can happen to NumPy. We could change, remove, add, put, and that's it. All right, so now I'm just going to run through the NumPy slides once more, just to give you some some kind of heads up, all right, before I, jump out of this fully. So you could see how we created first arrays, and then also some other things I'm going to be talking about, which I've talked about literally in my focus, is we have what we call several dimensions of array in NumPy. What do we mean by that? If you look at full choices now, for example, if we say print full choices dot n dimensional array, it's going to tell you it has 3 dimensions, okay? Now, let's say the first array that we created here, okay? Let me just kind of take a random one, which is obesity measurement. Yeah, if we say obesity measurement dot n dim, it's going to tell you that it has what? 1 dimension. So we could check the shape, the you know, we could check, we could create special arrays, we can have MPs dot zeros, so just basically most of this I've just talked about it, but I don't really want to go so much in depth in this. We could check out array shapes and dimensions and the sizes, and we could check how to indexing, accessing array elements, which we've done severally. That's basically how to slice an array open, check out some stuff inside of it, and of course, make out the very best from it, okay? And then also we could look at, we could also check out grabbing a range, right? Which is just this slicing that I talked about. You could set, okay, you want to just take from so and so column to so and so column, and then of course everything really makes out some sense. We could check out, we could also perform arithmetic operations on arrays. I told you that already. We could perform, some math operations, like we could perform some division, multiplication, and all of that, all inside of an array. Okay? For example, we could have something like school school scores is equal to np dot array. Or I could just generate something np dot random dot randint. Okay, so the lowest scored from maybe 45 to 90, and uh I want 10 students. So I'm going to say something like np dot random dot seed, okay? And then of course I'm going to give it 5. So I could print school scores. I'm going to be using this to make some explanation. School scores. Now, if you kind of look at this right here, you're going to see that I could do something like school scores divided by 23, for example. And it's going to give me, normalize the variable. I could decide to change this, divide it by 2. Are you seeing? It gives me that. I could do school scores uh, divide plus 2, and it's going to add 2 to each and every one of them. And this is what we call broadcasting. Okay, this is what we call what? Broadcasting. Broadcasting, which we're going to also talk about much in details. But I'm just trying to make sure that this course covers as much as possible, particularly for anybody who has actually decided to enroll for this course. All right. So I could go on and on, lots of stuffs out there. And of course, yes. So that's going to be broadcasting. And So what else could I do? I could subtract as well. Of course, could do some kind of school scores minus 10. Of course, it's going to subtract 10 from each and all of them. So these are what we call arithmetic operations in, in NumPy. So we could perform some core statistical functions. Okay. We could check the mean, we could check the max, we could do all of that. So for example, if I do NP school scores, dot mean, so it's going to tell me what that is. I could do school scores, print the maximum score in this array is 84. So that's it. So it's going to check it. And I could also do something like that. I could say I could check out the minimum score in this array is school score dot mean. That's 53. So when your data is two-dimensional, the axis parameter controls which direction the calculation travels. This trips up almost every beginner, but with the right visual, it clicks instantly. So the healthcare analogy here is imagine a table, rows is this and all of that. Of course, so these are actually other advanced functions. So we have NP.random, normal distribution, and all of that. We have Boolean filtering, which I explained earlier on. And we have NP.where, which we also explained with shipping arrays, which is quite very imperative. And then we have broadcasting, smart math across different sizes. And then we have NumPy machine learning features and targets. And then these are some kind of key exercises that I've kind of left for you. All right. So if you kind of look at pandas, what is pandas, right? This time around. So pandas is actually another important part of what we'll be doing. We could just have a small data set that we might create right now, a random data set. Let's see how we can just mess around. But let me just kind of take you through this just to see. Now, we're going to be working with so many data sets, right? Excel sheets, could be from CSV file. And then there's actually a place where we do get these things. We could go to, we could go online to get some of this data, somewhere like, I'm just going to remember, so check data sets, search on Google, and then you could find maybe malaria data set. So what do we mean by malaria data sets? So I'm just going to open this stuff right now. So it's going to give you some kind of access to, all right, so this is where you're going to come here. So you download this zip file. So you could sign in. I could continue with Google. Okay, it's going to let me download the zip file. So I'm just going to drag the zip file out. I'm going to open the zip file. I'm going to take out the data set. And then I'm going to close that zip file. Okay, so I'm going to open part here. Now, what I'm going to do next now is, if I want to work with pandas, I must make sure that my file is close to that's my path here where I want to work on it. So I'm going to keep it there. So I'm going to look at this. So this is a CSV file, okay? And I'm going to go back to my practice here. I think what is going to make sense is that we could just create a file here and call it pandas practice dot interactive Python notebook. Let's just kind of get out of here. So I think that's definitely that. So, but what's going to require us to do is, of course, we'll have to select our kernel. I'm going to also select that base kernel and everything works well. Now, let's now go through the slide just in a jiffy quickly so that we can now dive fully into it. Now, while we're also doing pandas, we might have to explore some matplotlib visualization just to make you guys, just to make you guys kind of comfortable with what it requires, to just starting to program in Python using some of these data structures, okay? And their libraries. So, so pandas is free library too. You can use it for machine learning, data analysis, lots of stuff. And let me just kind of run you through this, which is all I'm going to be doing. You could install, how do you install pandas? I think I could have just talked about that so maybe slightly. You could hit your, that's a control backtick, and then you're going to go pip install pandas. Okay, and then you could see numpy, matplotlib. That's how to install it. But I'm not going to do that because I already have it installed. You could also install it from by using Windows R command line, and then you could open PowerShell, pip install pandas. You could actually install pandas alone and then you hit it. But I'm not going to do that because I have it already installed, okay? So now you install library, and then we look at what a data frame is. Then I'm going to show you how to create a data frame. And then I'm also going to show you how to view your data frame. Then I'm going to show you how to understand some of the columns. There's something called series. I think at some point in this video, I was trying to remember it when I was talking about lists. Series, it's just kind of one column of your data frame, because if you have more than one series, is a data frame already. So, but don't worry, we'll talk about that in the jiffy. So selecting a single column, how to do that, and selecting multiple columns, and how to select columns with iLock. We'll look at some of that. This is just kind of a full pandas tutorial because we do have one. Data filtering, and then some adding new columns. Of course, we could do that. We could update existing data. We could handle missing data. How do we do that? Data cleaning, describing, how to group data, sorting data, reading CSV file, which is the first thing we're going to do, saving data to CSV, and then mini project, and all of that. Okay, so now what I'm going to do right now is I'm going to show you how we can read that CSV. So right now, we have a data frame here, data set from Malaria, Africa. I don't know what this thing looks like, but you could just have a glimpse of it. This is .csv file extension. So what I'm going to do first here is I'm going to say, okay, df. Now, first of all, we're going to import pandas as PD. So this is what we call the alias for importing pandas. Okay? So it's widely used. It's not like it's compulsory, but it's something that is widely used, within the community, our community. That's several communities of developers. So the first thing I'm going to do right now is I'm going to create a data frame where is df is equals to pd.read CSV. So this is how we read our CSV. And then I'm going to pass data, and that's it. So automatically I've read that CSV. So it's going to let it load. And so this is initiating our df object. So I'm just going to say pandas crash, pandas session, okay? Or better still, pandas. Now, what can I do to this data frame now? Now, for us to read the head of this data frame, or maybe I could say maybe visualize, just visualize the tables and rows, visualize the tables and the rows. So I'm going to say df.head, and then I'm going to pass in 10. So this is what this data frame looks like. Wow, you see there are kind of non-num values inside of this. And then but kind of just see looking at this data frame, you see that there are a lot of things that has to be done here. Now, the first thing we'll do here is to check, since we've kind of seen what the data frame looks like, I'm going to do df.shape, no? df.shape, run it again. So this contains 592 rows and what? 27 columns. So how do we check the columns? To check the column names, I'm going to do df.columns.toList. We could pass it in a tuple. So this is what the names of all the columns inside of this data frame. Okay. All right, so for us to, because we could rename this, right? We could decide to rename this. Now, another thing we could do is that how do we check the distribution of the data? So we could do df.info. Let's just get the information about this data. So it tells us, oh wow, a lot of them are floats, and then objects. Yeah, okay, good. And then we'll now do df to check if there are missing values. So do df.isNar, that's missing values, right? That's missing or non values. Call it non values. isNar. So we're saying isNar is a function, it has a method inside of this data frame object dot sum. So we are chaining the method. So you see that there are so many missing values inside of this. All right, so how do we check? If there are duplicates? So to check if there are duplicates. So this shows you that there are missing values. I hope you know. But for duplicates, we're going to do df.duplicated.sum. Check. I'm going to assign this to a variable check. I'm going to say print the number of duplicates are check. So there are no duplicates, okay? So to confirm that that was right, you say df is equals to df dot drop duplicates. And then when we do df dot shape, it still did not change, right? So that confirms that there are no duplicates. All right, so guys, so these are actually some of the basic things we must need to know about, working with pandas. You could see that we might want to use this to train a machine learning model, but it's kind of so messed up, right? So let's kind of see how we can clean up this data slightly, just so it looks a bit, better. So what we'll do now is df dot columns. First of all, let me see that columns again. df dot columns dot to list. Okay. Now I'm going to copy all of them. So what we'll do right now is we'll say df is equals to df dot columns dot rename columns is going to be equals to. Now let's kind of try to rename these columns, right? Let's just kind of make it neater so it will be easier for us. So this is how we rename columns. So I'm just going to paste this here. And then, of course, I'm just going to pass this. And of course, I could say country. I'm gonna say yeah. Country code. So this is going to take us a lot of time, but we don't mind. Malaria case report. Insecticide, insecticide bed use. Mhm. So we'll call it. Okay, so here we're gonna say people. We're gonna say population safe drinking water. So I'm just gonna copy this. So this is going to change to urban. So this is going to be population safe. So this is going to be safe sanitation. So this is going to be rural. And then this is going to be so this is going to be it's going to be urban. So this is total. Okay, so I'm just kind of making this. This is going to be growth. Man, there are so many columns here. This is not, this is paper, 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 basic, drinking. So this is going to be urban, people, basic sanitation. I'm just going to be sure we have a sanitation and So you don't really need to kind of change the parts that you've changed before. All right, so it's just basically the ones. Okay, so those are actually that. And so we're gonna run that. It's dictated at line 15. Okay, intermittent string literal. This should end with this. 19 something. Okay, so index range got an expected comma in columns. Mm, just to kind of push. So df is equal to df dot columns dot rename columns. Okay, so this is actually how I'm going to try and rename this just to be short because the data set looks really messed up. Okay, I think that's it. So that's a mistake is okay. So we could do df dot columns dot to list. Okay, so we've changed it. At least it's looking okay now. Df dot head 5. Let's see the first 5. All right, so the next thing we're going to do now is we're going to now we're going to attack all the nan values now. So first of all, we'll drop so many of this now, right? So we're going to drop the country, we're going to drop the year, we're going to drop malaria incidence, uh, you know, a lot of things that we're going to drop just to kind of keep, because so many of these things doesn't have any relevance on the on it. So we say df is equals to df dot drop, and then so we'll now say columns is going to be equals to. So what are we dropping? We're going to drop country. Okay. So we're going to drop the country code. Okay. Also going to drop longitude and latitude and geometry. Not really necessary. And for now, so this is how we drop it in pandas. We use the drop and then, so we run it. So df dot shape, you see that that's changed 21 items now because 6 is gone. And now we still have NaN values. Now we could also talk about in our advanced course how we can clip outliers, but I don't really want to stress so much on that because this is definitely the last thing. df dot head again. Let's look at df dot tail if we want to look at it from the net. Okay. All right, so you see, we have serious outliers, serious outliers. Now, how do we check outliers? So to check outliers, we do df dot to check for outliers. So we do df dot. Now we do df dot describe. Now it kind of gives us insights about our data across all the columns. So it tells you here, it's going to tell you the count, that's the number of variables you have, the mean, then the standard deviation, the minimum number compared to, the 25% at a quarter range, the 50% at a quarter range, and so you see that the max, you see what it is, right? So sometimes this is actually really visible for outliers. Now, what I'm going to do right now is, in order to make sure we have complete understanding of matplotlib, I'm going to, from matplotlib, import pyplot as plt. So I'm also going to import that particular library so that just so that everything is going to make some sense. And yeah. So that is definitely going to be that. Okay, so now what you will see now is I could decide to do some kind of visualization, all right? Because that time when I did df dot isna, and then I kind of did dot sum. Now you see that there are actually outliers in all of, there are non-values in all of them. So what I'm going to do is if I do df dot drop now, that might require that we miss out on so much. So, but let's know df dot info, the ones that are, it looks like all of them are floats now. Okay, so we can handle all of we can handle all the non-values now. So what I'm going to do now is I'm going to say df dot df dot columns dot to list. So I'm just going to copy all of this. Or I could say columns is equals to this. Okay, that still works. First of all, let's print length of columns. Okay, 21. All right, so we'll do 4. Okay, now what I'm going to do is df of col for col in columns. And I'll say, we're kind of iterating over this now. So we say df of col is going to be equals to df of col dot fill now df of col dot fill it to the median. And I think that is median. Okay, so now we'll fill out the none. So if you say df dot is now dot sum, you see all the non numbers has disappeared. Okay. So of course we could now go further to perform some change, but I'm not really going to go so further because this is where we're supposed to stop. So let's kind of look at, let's perform some plotting. Let's plot our rural sum plotting. Now let's plot box plot of children fever. So I'm going to say df, that's box plot for children fever. I'm going to say plot the figure. It's going to give me a size, big size of maybe give me 7 and 8. So I'm going to say plot dot box plot. Okay, so I'm going to have df of fever, children fever, plot dot pattern, box plot, showing outliers, children fever. So that's how check it. So I'm going to plot dot show. Okay, so this is what it looks like. I'm just kind of giving you some, some hints. So we could do a line plot. We could do a line plot here for malaria incidence against case reports and all of that. So there are a lot of things we could do. We could say plot of figure. So we could keep the fixed size at maybe 4 and 6. And I'm going to say plot. And then we're going to say df of probably we could plot insecticides used against malaria incidence. So this is malaria incidence against df of insecticides. Just kind of copy that, right? Insecticide bed use. I think this is going to benefit from, let's kind of look at the distribution of the data. When we look at, let's kind of look at the distribution of the data, say df dot head of 10. Let's look at it. Insecticide bed news and malaria incidence. Okay, that's good, beautiful. And that's definitely going to be the last thing we're going to be doing right now. That's the last thing we're going to be doing right now. Just to show you how this actually works really out well. And I'm just going to show you. Okay, so I have this is the second part. Let's say plot dot because we have our plot dot x label. So this is going to be the malaria incidence. Plot dot y label. So it's going to be the insecticide bed use. Plot dot the show. Plot dot title. We're going to see relationship between malaria incidence and insecticide bed nets use. So if we're going to plot this right now with a line plot, this is what it's going to give us. But I think this is going to benefit more if we use kind of a plot that is going to correlate them more. Maybe I could say, I think this is not actually, I could say, what dots. So there's actually so many methods that are actually out there. You could see them. So each time you use the dot, it gives you a wide array of what methods. Okay. So you can have your plot dot subplot, you can have your plot dot, just a lot. Plot dot scatter, that's what I want to use. And I think that's what's going to really benefit from this, not beautiful. So this is the relationship between malaria incidence and bed nurses. I'm not using this, right? So we could use plot dot bar maybe for malaria incidence. So you see malaria incidence distribution using bar. So guys, there are actually a lot of things we could do. We could continue on and on, and or rather haste. So yeah, so this is actually the best. So using a histogram. So it could also take in maybe bars and all of that. It could take in some other params. But I just wanted to keep this thing very simple. For us, we cleaned up this data. We showed you how to visualize. And I didn't want this video to go so much longer, but I'm sure you kind of find this video very useful. Over the last 12 hours, we've dealt very strongly, with some things which are actually relevant, everything you need to know on Python, and some packages, getting started with it. Okay, so for here we started by showing how to import these dependencies, how to read your CSV file, how to identify the head, and then we went further into how to check the shape, transforming the list. We cleaned up the list, and then we check out missing values. We handled it. We check remove duplicates, and then we converted to list. And of course, we cleaned up the column headers, that's the column names, and then dropped unnecessary columns, visualized again, and then removed the non-values, and of course, performed some visualization. So I want to say a very big thank you, guys. If you kind of stayed from this course, I'm sure you kind of find this course very useful. And this is something that is really very important, particularly for all of us, for me. And I just want to really love to see you grow. I've stayed active, particularly over the last couple of hours, just to ensure 12 hours more than that, just to make sure that you get the very best and maximum out of this. So other than that, thank you very much for watching this video. And I think the next thing I'm going to be doing right now is I'm just going to let me just kind of show you how to commit on Git repository, because I'm definitely going to be committing all of this to my Git repository right now. And probably just to make it very, easy, I would have thought about doing that. So I'm just going to say, maybe probably here, I'm going to say git init and git add. So this is git commit in git commit. So it's going to take M. I'm going to say initial commit. Of course, everything is now saved. And so that's it. So you're going to be seeing it on my Git repository right away. I'm going to go to my Git, and of course, commit that, and just to make some sense, I'm going to go to one boss one. So I'm going to say 12 hours plus everything Python tutorial plus modules on packages. So that's it. So I'm just going now when you hit that, I'm going to copy this and of course just embed it on my terminal. I'm going to do git push new origin and